What are data structures? The reason we are talking about this is because if you look at the internet, everyone says if you want to get into this company or that company, they will ask you a question based on data structures and algorithms. So first of all, why such a hype and what exactly data structures are? So before we get into data structures, let's talk about data. See, the entire software industry is based on data. When you do a course on IT, which we call information technology, it's not about technology, it's about information because we work with information. So data is everything. So it doesn't matter what technology you learn, you basically learn or you work on it so that you can work with data. Example, think about programming languages. Why do we use programming languages? To process the data. Why do we use database? To store the data. Why do we use AI? To generate data or to understand data, right? I mean, just to bring it down, everything is data. Now then question arises, what is data structures? Now if we talk about any programming language, we have something called primitive data types. If you want to store a number, we store that in integer. If you want to store a text, you store that in a string. If you want to store a character, you store that in a character. Of course, depending upon different languages, the term or the way you store it changes, but ultimately you have some types to it where you store the data. But what if you have a bunch of data and if you want to store them? It's not just about storing data. Anyone can do that. It's about how do you store data efficiently, and you can also save some memory. The thing is, if you simply dump the data, you are expanding the memory, and if you want to search something from the data, will be difficult. And that's why storing that data efficiently is very important, and that's where data structures comes into picture. So data structure is a way to organize and store data efficiently. Okay, so when you say efficiently, it means two things. First, in terms of performance, and also in terms of the memory. Now, what about performance? Now think about this. If you talk about any software application which we use, it can be a normal calculator, or it can be an application like Amazon website, or any application which we use, a banking application as well. Now, what we do in that application is we use some features using which you can compute something, you can process something. Example, on calculator, you calculate. On the banking website, you transfer money. So what you're doing is you are basically building an application which will do some processing. And the way you build an application is through algorithms. Now, what are algorithms? Set of instructions. Let's say if I want to add two numbers, it's very simple. What you do is you say, take two values from the user, then perform the operation and give the value back to the user. Now, those are the steps, right? Those are instructions. Now, what I have mentioned, the instructions, those are called pseudocode because we're not actually typing a code here. We're not being specific to a language, let's say C, C++, Java, Python, JavaScript. What we are simply saying is, these are the steps you have to follow. And that's your algorithm, right? But yes, when you want to make it work, you have to convert that into a code which will run on the computer, right? That's your actual software code. And you can use any language, doesn't matter, right? But the pseudocode will remain same. Now, when it comes to processing of data for any task, it's important for us to make it fast and also save memory. Now, most of the companies are focusing on this concept of data structures is because they want to give a good experience to the user. Of course, right? If I'm using some application, I want it to be fast. Now you will say, okay, to make the system faster, you can increase the CPU speed, you can increase the amount of RAM. You can do that. But what if with the same amount of memory, same amount of CPU power, you can still make it more faster, right? And that can be done with the help of data structures. Now, if you know how do you store that data efficiently in a proper structure, and by doing that, you can make your application faster. Because in data structures, we have different type of data structures. Example, let's say if you have a bunch of data, you can store that in an array. But apart from array, we have other types as well. We have set, we have linked list. So when to use what? It's not that this is best or that is best. It's all about when to use what. And to understand when to use what, you have to first understand what those things are. Right? How do you decide that this time you have to use array, this time you have to use set? And that's where understanding these concepts are very important. Now, these are not the only options we have. We have tree, we have graph, when to use them. So when you understand those concepts, then we can think about, okay, for this situation, we will use this. And this is why companies are preferring candidates who knows DSA. It will help them in multiple ways. First, it helps them to reduce the cost is because every computation, see, I know you might be thinking, most of the applications which we use are free, right? Think about Instagram. Now, when we use Instagram, of course, we are not paying for it, but then companies are paying for it, right? So the Meta is paying for you to use Instagram. So because those computations will be happening somewhere. Maybe Meta is using some cloud service. Let's say Amazon is in this case. So Meta is basically paying to Amazon for every computation which you do. Okay. Of course, they earn from ads, but then they are paying for it. So what they will do is they will try to optimize it. They will say, okay, if one query takes, let's say, $1 or maybe half a dollar, can we just reduce it more? Can we just make it 10 cents? So that's the thing they are trying to do. And the way you can do that is by making sure you use a proper algorithm with a proper data structure. So why companies are doing it? To reduce the cost. Second, to give a better customer experience so that it will run faster. And if I search something, it should be faster for me as well. So as a customer. Next, when companies want to hire people, they have so many candidates, right? How will they filter those candidates? Now, data structures algorithm becomes one of the way to filter the candidates. Because if you know data structures, that means you have worked a lot on a particular language and you understand how a particular system works. On the other hand, data structures are not the only thing you need to know. If you want to be a good developer, if you want to get hired, there are multiple things needed. Example, you need to have a good hold on a particular language, a particular technology. You should have worked on few projects, understanding the entire ecosystem, not just one language. Working with databases, working with networking, but then DSA becomes one of the important things there. So just to summarize, what are data structures? So data structures is basically a way to organize and store your data in the efficient way. And there are multiple data structures option available there. And you will understand that in the upcoming sessions we're going to talk about. In the upcoming videos, we will talk about what are the types of data structures we have, how to use them, when to use what, and what are the algorithms available there. So I hope you got some idea regarding data structures. So of course, entire series is important to understand that properly. So I hope you're excited. We'll talk about ADT, which is Abstract Data Type. Now, before we move towards ADT, let's talk about data here. Of course, in the previous video, when we talked about what are data structures, we have talked about data. And we also mentioned that in the software industry, everything is about data. So whatever you do, you're doing it for data, right? Now, with this data, basically you get the data from the user, you process data, you also give the output to the user, or maybe you want to store this data in the database for the permanent storage. But the thing is, it's all about data. And whenever we use any language, doesn't matter which language you use, what you do is you store that data in your code somewhere. And to store that data, we use something called a variable. Now, imagine variable as a box and you are keeping your data inside that box. The problem is every box need to have a type. Of course, there are languages which are dynamically typed language where you don't actually mention the type for the variable, but in general, this box will have a type. So that means if you want to store the data, you need a box, which is your variable, and this variable also needs a type to it, or this box needs a type to it. Now, example, let's say if you want to store a number, so we can use something called an integer. Or if you have any other point values, you can also use float or double. Now, it depends upon the languages, how they work. But in most of the languages, we have something in common. We have integer for the normal numbers. We have a float for the point values. And what if you want to store a text? That's why we have string. And in few languages, we don't have all these types. We have limited types. And in other languages, we have many, but that doesn't matter, right? In general, we'll be having a variable and a type to it. Now, all these types are called data types, and they are system defined data types. Or you can also call them as primitive types, is because it's there in the language itself. You can directly use them. But sometimes you want to use some complex data type. And we can create that with the help of some other concepts. Example, let's say if you want to represent a human, or if you want to represent a phone. Now, I love phones, so I'll be using that example. So if we talk about this phone here, now this phone will have a name to it, right? So it will have a name, it will have a brand. Of course, name is model number, then brand, then the configuration, the amount of CPU, RAM, all this are your data, right? So if you want to represent any physical thing in the virtual world, we use objects there, right? Now, in some languages which are object-oriented programming, we do that with the help of objects. Example, in C, we use something called structures. So we can define a structure name, let's say phone, and inside that you can specify what are the properties there. In the same way, in the object-oriented languages, we use something called class. In this class, you create different variables with primitive type, and then the box itself or the class itself is your complex data type, or you can say user-defined data type. User-defined because system is not giving you, we are defining our own type, right? So that's about data and data types. But let's say if you want to store a bunch of data, how will you work with that? And when it comes to data structure, how will you store this data in a proper way? See, what happens is when you talk about primitive types as well, every type will have a way to store data. Of course, that's why we are getting them, right? So example, if you are creating a variable called num. Now, let's say this num is of type integer, and then you are storing a value to it. Now with this variable num, you can perform operations as well. Now what are the operations you can do with integer? You can add two values, you can subtract two values, you can divide, multiply. So you can perform those operations on the number. But let's say you have a string there. Now with string, of course, you will not be adding to string. That doesn't make sense, right? Why you will add two names, let's say Navina and Kiran, you will get a new name. Okay, a lot of parents are doing that for their kids, but that's not the idea here, right? We can't add string, we cannot subtract strings. But yes, with string you can do something else. Maybe you want to see the size of a string. Maybe you want to concatenate two strings. Maybe you want to cut two strings. So string has different operations. In the same way, if you are creating your own type, this will have data, of course, but also you have to mention the operations which you're going to perform. So we have two things, right? We have data and we have operations. Now let's say in data structures, you want to store a bunch of data, as we mentioned, and you want to store, so there's a concept of array. So if you have multiple data, instead of showing them in multiple variables, let's say you have 5 numbers, 2, 6, 12, 21, and so on. Now, if you have all these values, you basically store that in 5 different variables. Or you can create a single array and you can store all the values there. The advantage would be you just have to use one variable name there. So instead of saying A, B, C, D, E, you can simply say nums. You can use any variable, doesn't matter. So what's important is you can use array here. Now when we use array, we are not basically using a primitive type here. We are creating our own type here, own data type, which is an array. Now in this array, basically you should be also able to perform some operation. Example, let's say what if you want to read some value, you want to fetch a particular element, you want to search the array, maybe you want to add an element, maybe you want to delete an element. So this operation should be possible on that type. So in the concept way, when you have a type where you can perform some operation, we call them as abstract, is because the implementation for array changes from language to language. And we don't just have array, right? So let's say if you want to store a bunch of values, we can use list, we can use set, queue. Now when you talk about a queue here, let's say. Now inside queue, we have one more option for that, which is stack. They follow different concepts. So let's say if you want to add an element in the queue, which follows last in first out, which means you have to insert from the end and you will get it from the first. Of course, you can reverse it, you can insert from the start and you can take it from the end. The thing is, you will insert from one end and you will remove from the other end. So that is first in, first out. In stack, it is reverse. You do last in, first out. Example, let's say, to give an example, let's say for queue, we can say a queue which you follow, right? Example, if you want to buy a coffee from a cafe shop, of course, there's a queue there. You have to stand in a queue, and then when your number comes, you will get the coffee. So basically the first person who went there first will be getting the coffee first, right? In terms of stack, it is different. So when you keep multiple books, the first book which you can take out is the last book which you have kept there, right? Which is last in, first out. That is your stack. Now, we have different way of implementing in different languages. The concept remains same, right? So when you have a concept and the associated operations to it, and of course with data, which we call them as abstract data type. We also have map, but we'll talk about those things later. At this point, the point to remember is we can create our own types, and which is a concept. And if you want to have data inside that, and also you want to specify what operations you can perform, that is your abstract data type. Let's talk about arrays. So let's say you have a bunch of values, let's say 5 values. Now, instead of storing them in 5 different variables, we can store that in one particular sequence, right? Or one variable, you can say. Now in this array, you can store 5 values. So let's say we have this array here, and then this will have a name to it. Now, of course, this data will be stored in a memory, right? And every memory will have something called a memory location. So let's say we are storing this data at a location 101. Now what happens is every time you store a normal variable, let's say a primitive type, let's say int, and depend upon how much size it takes. So every type will have a different size to it depending upon a language. But let's say we have 2 bytes. Now inside your memory, let's say if you create a normal variable which is int a equal to 5, now this particular a variable will take some space in the memory, of course let's say 2 bytes, and it will also have an address to it, right? So every time you, in your programming language, you say, hey, I want a value for a, the program will jump to the memory location by searching for the address and it will get the value. But the problem is when it comes to array, we have multiple values, right? And we only have one address. Now that's tricky. Of course, each element here will take the same size. If you say int take 2 bytes, the complete array will take 10 bytes. Is because every element will take 2 bytes. How will you allocate memory now? That's an issue. So what you do is, the array will have a memory, but that is only pointing to the first location, right? So if you say the memory for this is 101, the first element is 101. What about the second element? Now that's where we have to use something called index values. So let's say the first element is at 101. So it will have an index value which is 0. The second element is 1, then 2, then 3, then 4, right? Now for 5 values, the index value starts from 0 and ends at 4. Now why 0 is because we have a memory allocated, right? 101, which represents the first element. So we don't have to give 1 to it. So what you do is the next element is plus 1. That's why 1, 2, 3, and then you can just get it, right? So 101, let's say if you want to get the third element, you have to say plus 2. That's how you do it. So you got the values, you got the index, and you also got a memory address to it. Now with this array, as we already talked about ADT, which is abstract data type, we should be able to perform some operations. Now what operation you can perform on this array? Now we can perform something called a read operation. So what is read? So let's say you want to get the value of an index number 3. Now what you do in this case is you say, okay, my array name is nums, and then for this nums, I want the value at index 3. So in different languages, we have different representation for this, but let's say this is common one. So nums bracket of 3. Now what your computer will do is it will directly jump to the memory address. It's very simple for that, right? So you will say 101 plus 3, you will get the value. So that's how you do it. Now reading is very easy, and computer takes very less time to jump to that particular area is because the computer knows the memory, right? Because you are mentioning the index value. Reading is good. It's fast also. What about searching? Now this is tricky because when you're searching, you're not searching for the index. You are basically searching for the value now. So let's say from this array, I want to search where is 17. Now in this case, your computer has no idea where 17 is because computer only knows about the memory address. Of course, the values are there, but computer has no idea in which location we have that value and do we even have that value. So what a computer will do is it will start from the first location. So basically you have to write a code to search from the first location. You have to check, is the first one 17? If yes, good, we can exit. No, then you have to jump to the next location. Is it matching? If yes, good. If not, next. Matching, yes, no, next. So basically you have to search each element, right? And let's say the element is at the end, you are searching, you are basically tracking to all the different locations. So this is time consuming, right? What if you have an array of, let's say, 1,000 values? To move between these values, it will take some time. What about inserting? Now this will be tricky is because, see, if you want to insert an element, what do you think? Will it take a lot of time? See, if you want to insert the element at the end, that's very simple. You can get the size of the array because we also have to have that option of getting a size of the array, right? So let's say you have 5 values. You will simply jump to the 6th location, which is index 5. And then you will say, okay, I want to add a value here. Let's say the value is 21. And you can add the value. It's very fast. But what if you want to add a value in between? So let's say you want to add that value at the second location. So after the first, you want to add the new value. Now what you will do is, you don't have a space there, right? You can't simply create a new space. You can create space at the end. So what you do is you basically have to move all the elements. And it's not like you can simply move the elements. What you do is create a new block. So move the second last element now to the last block. Then again, you have to move every element one by one. Then you can add your value to the second location. So if you are inserting at the end, that's fine. But if you're inserting in between, that will take a lot of time, and that depends upon the number of elements after the position which you're adding. What about deleting? See, deleting from the end is always welcome, is because you're not affecting your array in total. But what if you want to delete a particular element from between? Now, you can't simply delete from the between, right? You have to delete the end block. But how will you move? So again, when you want to delete this, just replace all the values, right? So that's tricky. So it will take a lot of time, depending upon how many elements you have after that index value. Now, why we are talking about all this thing? Array was simple, right? We can perform the operations. The important thing here is time taken for each operation. And it's not about CPU time. If you're thinking, my computer is super fast, it will be happening very fast there. See, in the world, we have different computers, and different computers have different CPU power, different RAM power, different configuration. And that's why let's not calculate the speed of a code or the algorithm by the actual runtime. Important is the number of steps it takes. Example, let's say if you want to insert the element at the end, that's good. If you want to insert the element in between, that will take a lot of steps. It's because you want to move the elements, right? Now, in the upcoming videos, we're going to also talk about time complexity, which is a very important concept, something called big O notation. But yeah, we'll talk about that in detail later. I know you're excited to hear that, but important thing is, when you write a code, think about the number of steps your code takes, because that defines your time complexity. And if you say my algorithm is good, it should be time efficient. Okay, so for the same particular operation, you can write two different codes. Example on the screen, if you want to print, let's say 10 numbers from 1 to 10, and maybe you just want to print the even numbers, we have two options there. Which one is good? Of course, you will let me know in the comment sections, but the code which is not iterating between all the values is good, right? So that's how you define how your algorithm is good. Now, we can also expand the array example. Let's say if you have a sorted array. So let's say you have an array, and this is sorted by default. So every time you insert the element, it gets sorted by default. You don't have to mention where you want to insert this. Example, let's say you have a bunch of values here, all are sorted, and now you want to insert an element which is 11. Now, if you want to insert 11 there, where it will get inserted? Of course, it will search for the location. Let's say we have a number 9. It will get inserted after 9. Now the question is, how do your code knows where is 9? So you have to basically search. You have to match. Is it greater than? Is it greater than? Is it greater than? And then you have to insert. So that will take a lot of time. But what if you're inserting in between? You have to shift all the elements. So that's about the array and a basic introduction of time complexity. We'll discuss that in detail later. In this video, we'll talk about time complexity. See, the thing is, in the previous video, we have talked about algorithms, right? Now, the thing is, if you want to build an application, basically we are trying to solve a problem, right? And every problem will have multiple solutions. So the steps which we write to solve that problem, that's what we call algorithm. Example, let's say if you want to cook something, you follow some steps, right? Now those steps are your algorithm. Example, if I want to record a video, we do multiple things. We prepare the content, we set up this camera, mic, and then we start recording, then we edit the video. So there are multiple things involved. In the same way, if you want to solve any problem, we have to follow some steps, which we call algorithms. And the thing is, for one particular problem, we don't have one solution. We have multiple solutions. And we have to pick the best one. Now question arises, how will you choose the best one? So when you say best one, what exactly it means? So let's say when I run this application, I want my application to use less memory. Or maybe when I run this application, I want it should take less time. Or maybe both. And that's why we have this term called algorithm analysis. So basically you have to analyze your algorithm so that you can make it more efficient. Right? Of course, as a developer, first focus is the product should work, and then you think about optimizing it. But when you say optimizing, you can optimize in two ways. One, think about the space complexity, and second is the time complexity. Space complexity simply means, can we use an algorithm which will take less memory? And time complexity means it should take less time. But there is one more problem here. And the problem is, how will you calculate the time, or how do you specify the exact time? Because every machine will have a different output, right? So if you are testing the algorithm in your machine, it might give you different time. And then the moment you test this in your office machine, it will give you a different time. So that's not the best thing to calculate the number of seconds it takes. But what you can do is, there is a way you can calculate with the help of steps. But before we go there, let's focus on two algorithms here, and then this will make much more sense. So the algorithm which we're talking about now is the searching an element in a sorted array. So in the previous video, we have talked about array, and then we have also talked about the sorted array. So in sorted array, by default, all the elements will be sorted, right? Now what I will do is, I want to search a particular element from this array. Now there are multiple ways of doing it. Let's talk about the two. So basically we have an option of linear search, binary search, or many more, but let's focus on this two. So what exactly linear search and binary search is? Let's talk about that. So what is linear search? So let's say you have an array with you. Okay, so this is your array, and in this you have multiple values. So let's say I'm going with few values here. Let's say 5 values, and then I'm going to write, let's say 5, 7, 9, 12, 17. So we got this 5 values here, right? And then I want to search a particular element. Now this is sorted array because you can see all the elements are sorted. We got 5, 7, 9, 12, 17, and I want to search a particular element. Let's say I want to search 12. Okay, I want to search this element. So maybe there is a target value which I want to search. In this case, the target value is 12. So I want to search 12, right? And then this is an array. So what we do in the linear search is you go one by one. So what you do is, in fact, we have talked about this in the previous video as well. So we'll make it a bit faster. So what you do is, whatever your target value is, you will compare that with the first element. If it is matching, great. Otherwise, you will move to the next element. Otherwise, you will move to the next element. Otherwise, you will move to the next element. And I mean, of course, at this point, we don't have to go to the next element. So here, we basically got the value. And once you got the value, you can return the value, right? Now there's a problem here. The problem is, what if the element is not there in the array? So of course you have to reach till the end, okay? What could be the best way scenario here? So let's say you are searching for an element. Let's say element is 5, and now we know element 5 at the start itself. So when you have the element at the start, it will take only one step. But what if you have element at the end? So it will take the steps depend upon the length of the array. So let's say if you have 5 values, it will take 5 steps. When you have 10 values, it will take 10 steps. When you have 1 million values, okay, that's huge. Let's talk about 1,000. So let's say when you have 1,000 values, it will take 1,000 steps. That's tricky, right? Now the problem is not it is taking 1,000 steps. The problem is, as your size increases, it is also increasing the number of steps to search. Okay, that's one parameter you have to remember. So that's the theory, right? Now let's understand that with the help of a pseudocode here. So you can see I'm writing a pseudocode. Why pseudocode? Why not some programming language syntax here? Is because we wanted to make it generic so that you can, doesn't matter in which language you work, maybe C, C++, Java, JavaScript, Python, maybe COBOL, your choice. This could pseudocode remains insane, right? Now this can be function, procedure, doesn't matter. So what I'm doing is doing here is we have a procedure, right? It can be a function, and the name of the function here is the linear search. Okay. Now we are accepting a list of items. Now this is your array. The name of the array is A. Okay. And then you are also passing a target, what you're searching. So in this case, we were searching for 12, but doesn't matter. So you have an array with multiple values. It can be 1 value, 10 values, 1,000 values, doesn't matter. And then you're also passing a target, what you want to search. Now you will go inside this, and then for the first thing you will do is you will want to find the length of the array, because of course you should know, right, till when you have to search. So you got a length which is stored in the n, and then we are going to basically going from 0 to n minus 1, because when you start with 0, you have to end with 1 less, right? So if you have 10 values, you will go till 0 to 9. So you will go from the first value to the last value, and then you will search if the target which you are searching is equal to the current element where you are searching. So when you're searching for the first element, that's the first element here, target is matching. If yes, you're good. You can simply return the value. But what if you're not match? It's not matching. It will go for the next iteration, next value. Is it matching? Yes, good, return. What if it's not matching? Next value. So basically you have to search each value till you're not finding it. So that's basically a pseudocode here. And what if there's no element? Example, you have 5 values and you're searching for a value which is not there. You can return -1 by specifying, hey, the value is not there. This is simple linear search. The code is small, but then the time complexity, which is the amount of time it takes, is huge. Okay. Now let's go for the second approach, which is your binary search. Now what happens in binary search is it's very simple. Basically, it's not that simple, but let's say. So what you do is you have an array, again a sorted array, and let's say we have multiple values here. I'm not sure how many lines I'm going to draw, so let's count it later. So let's say we got 5 here, again 6, 8, 9, 11, 13, 17. Okay, so maybe I love odd numbers, so it doesn't matter what values you have there. So we got 1, 2, 3, 4, 5, 6, 7. So we got 7 values, right? Now what you do is in binary search, now since this is sorted, if you're searching for a particular element, let's say I'm searching for 8 here, okay? And we know 8 is here, we know it, but computer has no idea where 8 is. So how it is going to search? Now in linear search, what we were doing is we were jumping basically from value to value, checking this, and then goes on. So now why this call is binary is because you divide your array into two parts. That's the binary is. Now how you do it? So basically what you do is you give a starting point and then you give a ending point. And of course, every element here will have an index value. So in total here we got 7 values, right? Which goes from 0 to 6. Now what you do is you first divide your array into two parts. And to do that, we have to find a mid value. Okay, so even before you divide, you find a mid value. So how do you find a mid value? So mid value is equal to the starting position plus ending position divided by 2. Okay, now this is 6 divided by 2, which is 3. Okay, so your mid now is 3. And this is your mid. Okay, now basically you check with the mid. Okay, so you always check with the mid. Is the value which you are searching for, which is here, is it matching with the mid value, which is 9? No, it's not matching. But is it less than or greater than? If the value which you're searching for is less than the value which you got as a mid value, then the values after the mid value is of no importance, right? So this values here has no importance. You can directly skip them. So you can divide your array into two parts. So you got the first section here, which is 5, 6, 8, 9. And then you got the second section here, which is 11, 13, 17. So what you can do is you can basically skip this part, or maybe I will just do that with a color. Now we can skip this part. We don't need this value. The value which you want to focus on is 5, 6, 8, 9. So what you do now is you make your mid as the end, okay? Because we have shifted to the left part of the array. Now, of course, when you shift to the right part of the array, in case, then you shift your starting value. Now here you got S and E again. And then what you do is you again check your ending, you will find your new mid value. So again, S plus E divided by 2. Now S is 0, 0 plus 3 is 3 by 2, which is 1. Of course, you can say 1.5, but let's say this is 1 equal to 1. We can apply a float function to get the nearest integer. Okay, so we got 1 here, right? So what you do is you check. So this is your mid. Again, you check. Is it matching with the value? No, it's not matching. So 8 is not matching with 6. Then what you do? Then you again divide your array into two parts. But then which one you have to skip now? Now we know that the mid is 6. So we have to jump to the next value. I mean, we have to look at the right side value. So 6 is less than 8, right? So we have to look at the right side. So now what we're going to do is, we have divided into two parts, right? So now we can skip this part and focus on the right side now. So your starting position has been moved here now. Now this is your S and you got E. So again, you will find a new mid, which is S plus E divided by 2, which is 1 plus 3 is 4. 4 divided by 2 is equal to 2. So your mid now is 8. Now is it matching? Yes. Okay. And that's how you got the value. Now, if you might be thinking we have done so many steps, right? Not exactly. Basically, at the start itself, we have removed half of the array, and which is very important, right? So let's say if you have an array size of 1000, at the start of the first operation, you have removed 500 values. For the next operation, when you do it, you remove 250 values. So the number of operations which you are doing with binary search is less, right? And that's how you know that this is better than the linear search. Of course, in linear search, if the value which you're searching for is the first value, it's very fast, right? It will take a lot of time for binary search. But in general, binary search works faster. But how do you do that? So with this theory, let's talk about the practical implementation here. So let's look at the code here very fast because we have already done the theory here. So what you do is you basically write a function, let's say binary search, and then you pass a list of values, right? And then you also pass a target, same thing we have done in the linear search. And here, then you go with the left and right. So basically we have mentioned the start and the end. Here in this, we are taking left and right. Left starts with 0, as we mentioned, the starting starts with 0. Ending ends at the last value. Okay, we have done that. And then you run a loop till you find the value, of course. Then what you do is you check the mid value. So this is the mid value. We have done that. Mid is the starting point, ending point divided by 2. And then you check, is the mid matching with the target? If yes, you're done. You can simply return the value. Otherwise, we have to do something more. Then you check if the value which you got, which is a mid value, and the target, if the mid value is less than the target, in this case, you will focus on the right hand side. Okay, so basically you have to shift to the right hand side. So your starting point will shift. And we have discussed that here, right? Your starting point will shift. And then what if the mid value is greater than the target value? In that case, you will shift to the left position. Okay. So that's what we have doing here. And then every time you do that, you run the loop again, you find a new mid value. And that's what we have done multiple times, right? We found the mid value 3 times. In the same way you're going to do here. And then at the end, you will get a value. If it is not if it is not there, you will simply return -1 as we have done before. So basically by doing this, what we are doing is we have seen 2 algorithms, right? Now we have to find the time complexity. Now what exactly time complexity is? It's not about number of seconds it takes to run your code. It's all about this. So time complexity simply means the measure of how the running time of an algorithm increases with the size of input data. So basically, let's say when you are testing a particular algorithm, you're testing for let's say 10 values or 20 values. But what if the values goes up? What if you have 1,000 values? How will it will affect your time? Will it increase the time in linear section? Let's say if it takes 5 seconds for 10 values, will it take 10 seconds for 20 values? Or will it take more? Or will it take less? Okay. Or let's say you have 1 million records. Will it take 1 million seconds? That's the question we have to answer. Okay. Now, how will you do that? And that's where we have something called big O notation. Now, what happens in big O notation is we use this particular concept to understand your time complexity of your algorithm. If someone says, hey, your algorithm is not fast enough, you have to first find the big O notation of it. So why big O is because it is represented with the help of O, the big O. In bracket, you mention the order of n or something. So basically, it is also called order of or big O notation. Anything will do. So how do you represent that? You represent that with something like this. So we have O of, and then the value which is 1 will keep changing. So there are multiple things here. You can say we have O, big O of log n. We got big O of n. We got big O of n log n. We say big O of n squared, which is quadratic time. We got 2 raised to n. We got n factorial. Okay, so we got all this notation. But how do you find this? Okay, now this is tricky. So of course, in this particular video, you will not understand everything, but let's start with the basic. Now let's talk about the linear search. Now, if you go back to linear search, what we were doing there. Now in linear search, when you have 5 values, you take 5 steps. When you have 10 values, you take 10 steps. When you have 100 values, you take 100 steps, right? But let's say that is for searching, right? What about reading? If you want to read a particular element from the linear search or from the array, it's very easy, right? You specify the index value. Let's say the index value is 0, 1, 2, 3, 4. And then you specify, hey, I want the value at index 2. So let's say you say nums, which is the name of the array. And when you say 2, basically what you get is 9. It's very fast. So it doesn't matter what is the size of your array. It can be 1 million records. The time taken to get a particular element with the help of index value is constant, right? Because computer knows where that memory is. So in that case, I can say the big O, the time complexity for this is 1 because it is constant. Okay. Now see, it's not about one step. If you're thinking just because I've mentioned that it is only 1 step, it can be 3 steps as well. So let's say if you are reading a particular element and maybe behind the scene it takes 3 steps. It doesn't matter. It's constant, right? It can be 1 step, 3 steps, 10 steps. It should be constant. If it is constant, you can say O of 1. But what if you are searching an element? So if you have an array size of let's say 10, it takes 10 steps. Now you'll be saying, hey, what if your element is at the start itself? Of course, it will take 1 step. But we have to go for the worst case scenario here. The worst case is, what if the element is at the end? What if the element is not even there? It will take 10 steps. And that's why we can say the order, the big O notation here will be n. What is n here? The number of elements in the array. As it increases, the time also increases, the time complexity. I'm not talking about the actual seconds. Okay. So that's your linear search. Now coming back to the binary search, what could be the big O notation for binary search? See, the thing is, as the number increases, it will not directly increase the number of steps. Reason for that is, let's say we have 7 values. How many steps it takes? Let's say 3 steps, because we have to find the mid value 3 times, right? What if the size increases to double? So let's say from 7, we got 14. So what do you think? How many steps will increase? What if I say only 1? Reason being, even if you have, let's say, 14 values here, let's say we have so many values, at the start itself, it will be half, right? You will get 7 values after one step. And then you basically increase one more step to find the mid. So that means when your value increases, it will also increase the number of steps taken, but not exactly n. Because in the linear search, if your number of values increases by 10, it will increase 10 steps. Here, as the number of value increases, it will not increase the steps in the same sequence. So what we can say is, we can say it is something between constant. It's not exactly constant, but it is between the O of 1 and O of n. So it is between these two. And what comes between these two is O of log n. Now what is log n basically? So log n basically means we have a base 2 here by default. Okay, so number of steps it takes. So what exactly this n here? So let's say we have 8 values here. So when you say log 2 of 8, it will give the value which is 3. Okay, now why it is 3 is because log of 8 is simply means it will take 2 multiply itself 3 times to get 8. Okay, so as the number increases, let's say now instead of 8 values, we got 16 values. It will give you 4 because it will take 2 to multiply itself 4 times to get 16, right? So it will give you 4. That means as your number of value increases from 8 to 16, it will only increase 1 step, right? And that's why the binary search is log n. So your linear search is O of n and your binary search is O of log n. So which will take less time, the log of n, okay? And you can see the graph here as well. So this is elements, the number of elements you have in the array, and this is the number of operation it takes. Okay, so number of steps. So if your algorithm is following the constant time, it means it's here. It doesn't matter how many values you increase, it will be constant time. Log n is similar to, it's almost same as constant, not exactly same as constant, but it will take less time. So you can see log n is mentioned here. It's there, the wave is there, you can't see it, it's there. So what if you go with big O of n? So as your value increases, your time also increases, right? But there can be some worse scenarios as well. There can be some other algorithms which you implement, which might take n log of n, which is worse than O of n. There might be some algorithm which will take O of n squared, which is worse than the O n log n. So basically, if you want to build an algorithm, try to make sure that you are here. If you are here, you're good, okay? If you are here, it's okay. If you are here, try to make it better. If you are here, that's the worst scenario. That means you're building an application which is not scalable. The moment you have 5 users on your server says, I'm good. The moment you have 1,000 users, it will struggle. Okay, so make sure that you, whichever algorithm you write, you follow this. Of course, in the upcoming videos, we'll work on some more algorithms. We'll see which one matches there, but you got the idea, right? So the time complexity simply means this definition, the measure of how the runtime of the algorithm increases with the size of the input data. And to represent that, we use big O notation. So I hope you got some idea. In the upcoming videos, we'll focus more on different algorithms and also find the big O notation for that. This video will talk about the practical implementation of linear search and binary search to understand the time complexity, which we can represent with the help of big O notation. Now, basically, we'll write 2 examples here. In fact, we will also do binary search in 2 ways, just to understand how thing works, and then how will you find the amount of time it takes, not in seconds, of course, but the number of steps, right? So we have discussed about big O notation, which is the big O of 1, big O of n, big O of log n, right? But we also have multiple options, but then at this point, let's focus only on 2 with the help of 2 algorithms. Linear search, which is big O of n, and binary search, which is big O of log n. Okay, so what I will do is I will write this code in Java, and of course, we'll not be doing very complex stuff in Java. If you know any other language, you can follow this. So I'm using an IDE, and again, you can use any IDE. I'm using IntelliJ IDEA. So in this, I have a project. I will simply create a file here, and we'll name this file as demo. So we got a file called demo.java. And this is where basically we'll also have our main method. So if you are coming from different languages, you know we also have main there. So we have a main. Now let's start with the actual work. Imagine this as just a template to run the code. We'll write our code here. Now what we want to achieve. Now basically, we will be having a list of elements and we want to search an element out of it. Okay. Now the size can be anything. It can be 5, it can be 10, it can be 20, 100, doesn't matter. Initially, we'll go for less number of values and then we'll also see how do you work with thousands of values and how do you find element. And then how much steps it takes to search a particular element there. So what I will do is, first of all, I will create a simple array here and we'll say this array name as nums. So let's say we got an array and then I will also specify the initial values to it. And since we are going for a sorted array, of course, when you talk about the linear search, we don't have to specify a sorted array. It can be applicable on any kind of array. But when it comes to the binary search, you need to pass a sorted element array or a list, you can say. So here, I will simply assign some values. Let's say we got 5 values here. And then I just want to keep it simple with those values. Of course, you can have any value, doesn't matter. I'm just trying to keep it simple. Or maybe if you want, I can say 7, 9, 11, 13. That's my love for odd numbers. Okay, and I want to search a value. So whatever value I want to search, we can also specify here. Now we can use any variable name, but we have already used target as a variable, right? When we were discussing the theory. So we'll say target equal to, and we'll mention the target. Let's say I want to search an element which is 11. Okay. So this is what I want to search from this particular list. We can do this with multiple algorithms. We can use linear search, binary search, or whatever you think about. But let's go for linear search initially, and then we'll look at the binary search. Now, how do we do that? So what we can do is we can say, I want to get the result. Okay. I want to find this 11 in this list and give me the index number. I don't want anything else, just the index number where it belongs to. Okay. So who will give me that? So what I can do is I can assign this star to someone else. Let's say linear search. Now this is another method which will give the value to us. So I don't want to populate everything in this particular main. Main will simply say, hey, I got these two things. I got the list. I got the target value. You tell me which index this value belongs to, or if you don't have this value in the list, also let me know. So linear search will say, okay, accepted the challenge. It will accept two things. First, nums and target. Why you have to pass nums? Of course, linear search will say, I will search, but tell me where to search. And target will say, this is a value you want to search. Now, the thing is, we don't have this method yet. So what I will do is I will just use my IDE to generate. Okay, so I will say more actions. Create this method, and you can see we got this method. I don't want this to be private. I want this to be public. And that's it. What you're doing is you are calling under the method. At this point, since we are returning a value, what we can say return -1. Okay, nothing fancy. I just want this to work, and that's why I'm returning -1. Okay, and what if you get the result? Of course, if this value is not there in the list, it will return -1. Otherwise, we can return the index value. So whatever value you get, you can simply print here and you can say element found at index, and then you can specify the index value here. So let me just give a space. So you can specify the result here. So whatever index is there. Okay. And let's run this code just to see. I just want to make sure that everything is working. Let me just run this code. And you can see we got the answer. And also I want to move this to right hand side. Okay, so it looks good. So you can see the output says element found at index -1. That's weird. It's just that we are returning -1. That's why it's printing -1. What we should be doing is we should be checking if the result is not equal to 1 or not equal to -1. So this statement, it should print only when the result is not -1. In case it is -1, that means the element was not there. So I can simply print element not found. Okay. And now if you run this code, it will print element not found because we are not even searching, right? But we'll search now. So how do you search? It's very simple. So what you can do is you can use a simple loop here. Okay. Nothing fancy. Again, a simple loop. And in this, you're going to iterate. So we have seen the linear search, right? So if you remember the theory, we have talked about this. So basically we'll search from the first element, right? So we are going to start from 5 and then we'll look for, is it matching? Is it matching? Is it matching? Of course, the values are different, but we'll basically search for each element. In the same way, in linear search, if you want to move, you have to use a loop. So it will start from 0 and will go till the nums of length. So basically, if the number of values you have 5, you have to reach 4. Okay, so that's why we have saying less than. and then I++. Now that's your for loop, right? So in this for loop, you don't have to do much. You simply have to check. So whatever element you got, the current element which you're focusing on. So in the list, we have 5 values. If you're focusing on 5, we'll check if 5, which is the first element, is it matching with the target? If it is matching with the target, our job is done. We can simply return the index, the current index. So let's say if you're searching for 5 and then you got 5, return 0. Your job is done. That's what you're doing here. Okay, and that's it. Okay, it should work. That's what we're expecting. Linear search is so simple. If you run this code, it says the element found at index 3. That's right. So this is 0, 1, 2, 3, and our job is done. Okay. What if you are searching for, let's say, 5 in this case? It will print at index 0, and that's what we got. So this is working. But what if you're searching for something, let's say 77, which is not there in the list? If you run this code, it will say element not found. So linear search is working, right? Now we can do the same thing with the help of binary search. Now let's see how binary search works. So what I will do is I will just write a code here, which is public. In fact, I will just copy paste the code, not a copy pasting, but reusing the code. I can simply copy this code and paste it here. Now, if you're coming from Java and if you're getting confused why I'm getting a static method, why not non-static methods, it's because I don't want to deal with objects here. Okay, just want to keep it simple. So we got a static method and a binary search. The thing is, only method name will change. The parameter will remain same. In binary search also, you pass a list and you pass a target. The algorithm will change. Of course, it will return -1. That is not something which is changing. But what we will do inside this. Now, if you go to the board here, what we have done is if you have a list of values, if you can see we have a list of values here. Now, initially you have to specify the starting point and then you have to specify the ending point as well, right? So starting and ending you have to specify. In this example, we'll say left and right, okay? Because that's how that makes much more sense, right? Left and right, starting point is left, ending point is right. And then you will find a mid. Every time you find a mid, if it is matching, that's great. Otherwise, you have to basically skip the number of elements, which is in the other section, okay? So how do we do that here? So what I can simply do here is, in fact, I will just, for my reference, I will also have those values here. So I will say 5, 7, 9, 11, and 13. Okay, and the value, let's say, which I'm searching for, this time let's have the value. So let's say I'm searching for 11. Okay, so what I will do is, when you're searching for 11, first of all, you have to specify the starting point. So I will say left, in fact, int left is equal to, now left is a starting point, right, which is 0. Then int right, which is the ending point, which could be 4, but then why to hard code it? What you can do is, you can say nums.length -1, because nums.length will give you 5. You have to say -1, which will give you 4. So now we got the starting point, ending point, and then our journey begins, right? So what are we going to do here? So we'll use a while loop here. Now inside this while loop, what I'm going to do is, I'm going to check if my left is less than equal to right. We'll check if left is less than right, because that's what we want, right? Left should be on the left hand side, which is smaller values. And then here, what we'll do is we'll find the mid. Okay, that's the journey we are going to start. So mid is basically your starting point, right? Which is left plus right. And we want this to be in the bracket so that we can divide. So left plus right divided by 2. Okay, that's how you find the mid, right? Now, once you got your mid, you can basically check if the nums of mid, is it matching with target? If it is matching, that's great. We can simply return the index, which is mid. Of course, right, mid is representing an index here. If it is not matching, then we have to change the value of left or right, depend upon what you got in the mid. So what we'll do is we'll say if, else if. Now, how do you check? So we can check if nums of mid is less than the target. So let me take this up as well. Yeah, so if nums of mid is less than the target. So let's say when you talk about this elements and then we are searching for 11, right? The mid which we got is 9. If the 9 is less than the 11, we have to shift our left, right? So this left, which was representing 5, will shift here now. I mean, not even 9. We don't have to even consider 9, right? So what we can do is we can say left will shift to mid plus 1. Okay, so basically now we have two values, 11 and 13, which we are going to focus in the next iteration. But what if you are searching for something else, which is in this side? Let's say we were searching for 7. In this case, we have to shift our right. So right is mid minus 1. So basically, let's say if you're searching for 7 here, you got a mid as 9, what you will do is you will say, okay, so the value is less than the mid, so we have to skip this too. The focus will be only on 5 and 7. That's what we have done here. If you're searching for 7, okay. I think this looks cool. Our job is done. Let's verify if things are working out. The only thing you have to do is, instead of searching for a linear search this time, we'll go for a binary search. Let's run. It works. You can see it says found index at 3. And what if you are searching for, let's say 17, which is not there? Run, it says not found. Let's search for 5 and it says it works. You can say index 0. So that means you can use linear search or binary search, both works. But what if you want to really see how many steps it is getting? So what I will do is, let me just say this is result 2, which is binary search. And let me also say result 1. Of course, I'm not going to use both the things. I just want to call both the methods. Okay. I'm just going to use result 1 because if linear search is able to find it, binary search will also able to find it. Okay, let's print result 1 here. So I just want to call both the methods. That's the reason I'm using result 2, but result 2, we are not using it anywhere else. Okay, so let's do this with both the algorithms and you can see both will print the same thing. Oh, we are not printing the second part. Okay, doesn't matter. Both will give the same result. But what I'm really concerned about is the number of steps. So what I'm going to do here is, let's calculate the number of steps it takes. So I will say for linear search, steps is equal to 0 initially. And every time the loop iterates, okay, I will simply say steps, number of steps taken. So steps plus, and then I'm going to print just before return, I'm going to print steps taken by linear colon, and I will print steps. The same thing I want to print here as well. What if there's no element found? So this will never be executed, right? Okay, we have to put this into a curly brackets. Cool. So we are printing the steps here. The same thing I think we should do for binary search as well. So here I will say int steps is equal to 0. And every time you iterate in this loop, you will say steps plus. And then basically here, you will print the same statement. So I will just copy this. So we'll print before returning the value. But here we'll say binary. And we'll also print this before returning, just to cover all the cases. Okay, and let's see what it does. Run this code, and you can see for 5 elements, linear search is searching in 1. Okay, reason being, we are searching for 5, right? I think we are searching for 5. Let's search for 11. Okay, in some cases, linear search works well. Run, and you can see the linear search takes 4 steps. The binary search takes 2 steps. That's crazy. Run again. Of course, you will get the same output. But what if the values are higher? Let's say I have more values here. Let me add 10. Let me add 1, 2, 3. So now we have more values, right? I don't know how many values we have, but let's say if I run this code, the linear search takes 8 steps. Binary search takes 3 steps. Okay. But what if you have 1,000 values? Now, how do you check 1,000 values? Now that will be tricky. So what I'm going to do is, let's add some random values here. Let me create an array of size 1,000. I don't want to specify my own values. Let's say 1,000. And the value which I'm searching for is, let's say 500. Okay, it's somewhere between, or maybe I will say 900. Let's see what happens. So I have a value which is 1 to 1,000. I'm searching for, I have 1,000 values in the array and I'm searching for 900. But by default, the value will be 0. Okay. Example, if you search this, it will say not found. But look at the number of steps. Linear search takes 1,000. Binary takes 10. And what if you have more values here? Run. Linear search takes 10,000. Binary takes 4. And look at the size. Example, let's say if the size is 8 and by default, all the values in the array is 0. So anyway, it is sorted by default. And you can see if I run this code, it says 8 for linear, 4 for binary. But the moment I double the values, look at the steps taken by binary is only 1 extra. Linear all is double. If I double the value again, 32. So every time you double the value, binary search will take only 1 extra step. And that's why we say it's a big O notation for this is log n. Okay. So in this case, the binary search works better than the linear search. Now the same code you can write with the help of binary search as well. Example, instead of using a loop here, I can simply comment the entire section and we can replace this with a recursive function. The only thing is in recursive that the changes we will be doing is, in recursive, you're going to call the same function again by changing the values. Let's say you have this big array, and then you're done your first search, you found the mid. Now, the moment you found this section, let's say this part or this part, whichever is matching, you will remove the other half. And again, you will run the same binary search on this list. And then again, you will break it down into two parts. You will remove one and you will run the binary search on the other one. So in binary search, basically, if you want to make it recursive, you have to pass two more things, which is int left and, okay, not int left. You have to specify the left and right. So you will say 0 and nums.length -1. So basically, you have to specify the start and the end. And every time you call binary, you will simply accept those two things. You will say left and right, so that you don't have to specify them here. In fact, instead of removing it, maybe you want to refer this later. I'll just comment this section. Now, since this is a recursive, you don't need a loop here, right? What you can do is you can check if the same step, left is less than equal to right. If this is a scenario, what you will do is, of course, you have to find the mid. I will just copy this code. This is where you're finding mid. And after finding the mid, you can basically also check the same logic. This is a logic you're going to use. The changes is, we are going to change in the else part, the if else part. Let me uncomment the entire section. The changes you're going to do, let's not print the steps. Now we know the steps, right? How many steps it takes, but I'm just trying to convert that into a recursive function. So you will return mid here. There's no problem with this. The changes happens in the else if. So in the else if, instead of doing this, we are going to basically call the binary search once again by passing the same nums, and then you will change the target value now. So you will pass target value. So you have to pass nums and target value. Then you have to pass the left value. Now, what is left? So in this case, we had to change the left, right? Left will become mid +1 and right will remain same. Right will remain right. But here, again, we have to make the changes. Else part, instead of this, left will remain left and right becomes mid -1. So basically what you're doing is you are changing the values like this. If you have this list of values, you break it down into two parts, again, after checking. And then you're again calling the same binary search with the new values. Okay, that's what we're doing here. So let me remove the extra curly brackets just to make the code look good or short, basically. And that's it. This is your binary search. Let's see if this works. Let's rerun. And it says not found because, yeah, of course, it's not found because we don't have that value. But yeah, this is the code for the binary search with the help of recursive. Now there's one more thing. You can try with different examples. What you can do is you can take a array of 1,000 values and add random values. So in Java, we have this random class. You can add the values and see how much time it takes. So yeah, that's it from this. So we understood the big O notation for linear and binary search. And if you have any more questions, let me know in the comment section. In this video, we'll talk about the sorting techniques. Now, basically, we have talked about the big O notation, right? And now we know that if you want to judge the algorithm which you are writing, you have to make sure that you are using an algorithm which is efficient in terms of time and space as well. We are focusing more on the time complexity where as your data increases, it should not increase your time exponentially. So we have seen different levels of time complexity, and we want to be into that lower zone, not on the upper zone, right? Now, when it comes to understanding different algorithms, we have to go for some inbuilt algorithms, right? Or some old algorithm which normally we use. So sorting, so we have talked about searching. Sorting is one of the way you can learn more about algorithms and how do you make it more efficient. Also, in the real world, we do use sorting a lot. So let's say when you say you want to search something on the internet, or maybe you want to buy something on the Amazon, you do that sort by price, sort by reviews, right? So you do that multiple times. So sorting is majorly used. So there are a lot of different sorting techniques available. So we'll try to understand them. Not everything or not every algorithm, but let's try to understand few of them. Now, if we talk about these algorithms, some algorithms are easy or simple to understand, but they are not time efficient. And then there are some algorithms which are good in terms of time. So they are time efficient, but they're not simple to understand. Okay. So we have to do a trade-off here. Now, which is the best one? That depends. If you have less number of elements and if you're learning for the education purpose or to understand how sorting works, then we can talk about those algorithms like bubble sort, selection sort. And then there are some algorithms which are a bit difficult and they are very efficient when you have huge amount of data. Now what algorithm I'm talking about? So when you talk about sorting, there are different options available. So we have bubble sort, selection sort, insertion sort, merge sort, quick sort, counting sort, radix, heap sort, bucket sort, and there are multiple sorting techniques. The famous one are bubble sort, quick sort, selection sort, insertion, and then merge sort, if I'm not repeated that multiple times. So let's start with the first one, which is bubble sort. Now bubble sort is not efficient, but it is simple to understand, so that gives us a starting point. When we talk about the bubble sort, why do we use it? So let's say if you want to sort different elements. So let's say we have this list in front of you. The numbers are 8, 6, 9, 2, 4, 5. Now, if you want to basically sort them, how will you do it? Now, of course, we don't have a magical way where you can find, hey, this is the first one, this is the second one. So what you do is you basically try to use some algorithm like bubble sort to sort it. In this, what you do is you basically create a bubble. Now, what exactly this bubble is? Take one element, put that into bubble and shift it to the end. Okay, now that sounds weird, right? So let's do step by step. Now, when you have this value, let's say you have 6 value in front of you, you can put them in an array like this, and then you have provided the index values. Now, if you want to do this sorting on this, of course, we want ascending sorting here. So basically we want 2 at the start, then 4, then 5, then 6, then 8, and then 9. That's the sequence we want. But how will you get it? So what you do is you compare 2 values at a time. So let's say if you put 6 people in front of you and you want to sort them according to their height. So what you do, of course, you will compare 2 people at a time, right? That's how you sort. And then you will try to swap them. So how exactly it works? So let's say we have these 2 values here, 8 and 6. And then what you do is you want to make sure that the biggest element from this particular array in the first iteration goes to the end. Okay, so the way you do that is first you compare the first 2 values. Now, these are your first 2 values. When you're comparing it, if the first value is greater than the second value, you basically need to swap. Okay, swapping is very important here. So you have to first compare the first 2 values. If the first value is greater than the second value, then you have to swap. And then you basically shift your pointer to the next 2 values. Okay, done. We are done with the 6. Now let's go for the next 2. The next 2 is 8 and 9. If the first value is greater than the second value, you have to swap. In this case, they are not. They are. So the first value is less than the second value. So what you do is you simply say skip because there's no swapping needed. Then you go for the next 2 values. The first value is greater than the second value. So of course we have to swap. And then again you shift your values. Next 2 values, again you will compare. The first value is greater than second, swap. Then again you will compare the next 2 value. The first value is greater than second, swap. So basically after the first iteration, you got the biggest value at the end. But is it sorted? Unfortunately not. You need to do this operation one more time. Actually, not one more time, multiple times till you get this sorted. Now, this also depends upon the size of your elements or array. Now, in this case, the first 5 values are still unsorted. The last one is done, so we don't have to touch the last element. So in the first iteration, if you're going for 6 times, the second iteration, you can go for 5 times. The third iteration, you can go for 4 times. So let's see how that works. Now, after the first iteration, we got the 9 value at the end. Now what you do is, again, you repeat the same steps. Compare the first 2 values. Is it required to swap? In this case, no, we can skip it. Next 2 values, is the first value greater than second value? Yes, swap it. Then again, you go for the next 2 values. Is 8 greater than 4? Yes, swap it. Is then again next 2 values, 8 greater than 5? Yes, swap it. Now in this case, what happened is, after the 2 iterations, you got the 2 biggest values, which is 8 and 9 at the end. Now we know that those 2 values are sorted, but what about the other values? Those are not sorted, so let's sort them. Again, you have to repeat the same steps. So you have to say 6, 2, which is 6 is greater than 2. Again, we have to swap it. 6 and 4, 6 is greater than 4, swap it. 6 and 5, again swap it. So now, after this iteration, you got 3 values, 6, 8, 9, which is sorted. But what about the other values? They're still unsorted. I mean, we know they're sorted now, but your algorithm has no idea if they're sorted. Okay, now this is tricky because your algorithm goes from start to end. Okay, it will not check for do the other values are sorted or not. So it will keep doing that. So it will compare the first 2 values, not swap not needed. Next two values, swap not needed, done. We have also confirmed 5. Still there's a confusion for 2 and 4. Your algorithm has no idea those two are already sorted, but still it will try to sort them. It will compare the two values. They are compared, swapping not needed. So by doing that, 4 is confirmed, and since you only have one element now, that itself is sorted, and by doing this, you got the entire sorted array. So yes, even if it is sorted, it will still check. We are reducing one step, which is swapping, but still you are checking, and that's why bubble sort is not an efficient algorithm. And the problem is the time complexity for this is O of n squared, because you have to use two loops, one for the iterations and the inner loop. For each iteration you have to compare the values. So that's your n squared. Not a good way of sorting the elements. Now think about 6 elements. So that's good. 6 squared is not a big number. It is actually, but what about if you have a very big array or very big list, let's say 20 values, 30 values. Imagine the number of steps it will take. So not an efficient algorithm, but easy to understand. Now it's time to convert this into a code. Okay, now let's try to implement the concept of bubble sort in the code. So we are going to use Java as a language. So if you want to sort, of course, you have to store the values somewhere first. So what I will do is I will create an array of integers, and let me just name this as nums. And then I will assign some values. Of course, I can go for this new array and then assign the value one by one, or we can give them the static values. So here, let's say we go with values 6, 5, 2, 8, 9, 4. I don't remember the sequence in the previous video which we talked about the theory, but let's go with these values. And I want to sort them. Okay, so what I will do is, even before sorting, let me print all the values. The way you can print the values of an array in Java is, of course, you can use a normal loop, or we can use enhanced for loop. So let me just use enhanced for loop here. So I will say for int num in nums, and then we can print the values, right? So I'm printing num here. So I will say this is before sorting, and then I will do the same thing. I will execute the same code, but after sorting here. So let's say this is after sorting. Okay, now if I run this code, of course you will get the same value 2 times. So and one more thing, I want to print this on the same line, because ln will print on a new line. I don't want it. And maybe after every printing, I want to give some space as well to differentiate the values. And let me do that here as well, so that it will print on the same line with spaces. Right click here and say run, and you can see we got before sorting, after sorting. I think this should be printed on a new line. So what I can do is, just before this, I will say out and run. Okay, so this is before sorting and this is after sorting. At this point, it is not getting sorted, of course, right? We have not written any logic here. Now, this is where in between you have to write the logic for sorting. Now in bubble sort, what you do is you compare the values, 2 values at a time, and then you swap. So you compare these 2 values. If the first one is greater than the second one, just swap. And then likewise you will do for all the elements. Now for sure, if you want to move to the iterations, now we have to do 2 loops here. The nested loop, basically. The outer loop is responsible for the number of iterations or the number of passes, and the inner loop is actually responsible for swapping. So what I mean by that is, I need a first variable I will start from 0, and where are we going to end it? So of course I can end it at less than 6. So you can say 6, or you can say nums.length. Okay, so basically we can use the array length. The better way would be to store this value somewhere. So I can say size nums.length. So I'm just storing that value in a variable called size. It will be easier to work with. So I will simply say size. And then I will say I++. So it will go from start to end. So this is only for passing, right? We have to do this multiple times. You have seen that in the animations. But now let's do the inner loop, which will do the actual swapping. So here I will say int j is equal to 0, because we're going to start from 0. The real question is, where are we going to end it? At this point, I will say size, and let's see what happens if we do with size. Okay, so both the loop, the outer loop and the inner loop, are starting from 0 and ending at size, the size of the array. And now we have to basically compare 2 values. Now, how will you compare 2 values? And how do we even swap them? So we will check if the first value. Now, how do you know the first value? So nums of 6, or nums of 0, basically 6 is nums of 0. So nums of 0 compared with nums of 1, That's how you compare. Again, you can compare nums of 1 with nums of 2, then nums of 2 with nums of 3, then nums of 3 with nums of 4. That means the current number, when you say 0, 1, 2, it is represented by j. So I can say nums of j, but this will be compared with the next value. And how do I know the next value? Which is your nums of j plus 1. As simple as that. So we are comparing two values. Now how we are comparing them? Which operator we are going to use here? So we are going to use greater than. If the first value is greater than the second value, then you have to swap. Simple technique, right? Now, how do you swap? There are different ways of which you can swap the values. I'm going to use a traditional way. Let me use a temp variable. In fact, you can also declare a temp variable here. So I can say int, it's better to have all the variables on top. So I will say int temp equal to 0 initially. And then using the third variable, I can simply swap them. So I can say temp is equal to nums of j, and then nums of j is equal to nums of j plus 1, and then nums of j plus 1 is equal to temp. So basically what we are doing is with these three lines, we are just swapping them. Nothing complex, just swapping the two values, okay? And that's what we have done here. So every time you find this, the first value greater than the second value, just swap them. And you do this multiple times because we are keeping this in a loop. And that's it. The sorting is done. Since it will be happening multiple times, it will make sure that you keep the values at the end, the bigger value at the end after each iteration. So if you run this, okay, we got an error. It says out of bound. Now there is one problem here. Don't you think when we are going for j plus 1, what about the last value? So we need to make sure that we don't go to the last value. So it should end -1, right? Because when you're comparing the last two values, the value for j will be here and this will be j plus 1. So we have to make sure that your j ends before the last value. That was the error, and run. And you can see sorting done and you got the sorted values. This is how basically you sort them. Again, we have seen this explanation in theory, how things are working out. But here we just try to sort it with the help of this logic. Now there is one problem here. Every time you do this, in the animation, if you remember, after every pass, we don't have to go for all the values because the last value is sorted. In the next pass, 2 values are sorted. In the next pass, 3 values are sorted. So we don't have to sort them again or even check them again. So here, j should be not going to size -1. In fact, it should go size -i -1. Is because after every iteration, so let's say we have the first iteration where I is 0, it will go till the second last value because we are saying -1. In the second iteration where the I value will be 1, it will go till the second last position or third last position because the last value is sorted. You don't have to check that. Again, it will not affect the output, but it will affect the speed because we are saving some time by not checking the same sorted value again and again. Okay, that's how you basically do it. In fact, if you want, what we can also do is we can print this in every iteration. So I can just copy this, and after every iteration of the outer loop, we can print the values and see what is happening there, right? So in fact, I will also print a new line here so that it will come on new line. Let's run this. So this is what basically is happening. Initially, you have this value, and then this is where the sorting starts. If you can see, after the first iteration, the biggest value, 9, just went till the end. Then for the next iteration, the biggest value, which is 8, is at the end, or second biggest value. Third iteration, we got 3 values sorted. Fourth iteration, we got 4 values sorted. Fifth iteration, we got 4 values sorted, or 5 values sorted. And last iteration, we got all the value sorted. So that's how basically it does. Of course, here too, we got at the start itself. We don't have to sort them again, but that's how algorithm works, right? How will you even check if the array is sorted even before you compare all the values? So that's the thing about the bubble sort, where you compare the values, swap them, and you're done. In this video, we'll talk about selection sort. So basically, we'll talk about the theory in this, and then in the next video, we'll talk about the practical of it. The thing is, when you talk about sorting, we have different techniques available. In the previous video, we have talked about bubble sort, and it was working, right? But also the amount of time it takes, basically the time complexity of the bubble sort is n squared. Now that's not the main issue. Of course, that's a main issue, but then in this video, we are not going to solve that quadratic time complexity, but at least we can reduce the number of steps. Now in bubble sort, we are going from start to end multiple times. That's not the big issue. The big issue is swapping. Because every time in the inner loop, we were doing this swapping multiple times and it consumes a lot of time and memory. So what if we can reduce that? And that's where selection sort comes into picture. Now what we do in selection sort is we don't actually swap every time when you compare two values, but what you do is from the entire array or the list, you find the minimum or the maximum value depending upon how you want to implement it. So let's say we are going for the minimum value. So what you do is from the entire array, you find the minimum value and then you make sure that the minimum value stays at the start. Now once that is done, now that is your sorted part. So from the entire list, you create two sections, the sorted section and the unsorted section. So once you find two, that goes into the sorted section, which is at the start. And then you scan more values. Now let's say when you scan, you find, hey, we have 3, which is the minimum value in the unsorted array. Then what you do is you pick up that 3 and replace it with the second location. Now what happens to the value of the second location? Now that will be swapped where the value of 3 was. So what you're doing here is you are swapping by selecting the minimum value. So when you say selecting, that's your selection sort. Now what it does is you're not basically swapping value inside the inner loop. You are doing that in the outer loop, which means the number of swapping in a code will reduce. Now to understand this more, let's look at an example. So let's say we have 6 values here, which is 6, 5, 2, 8, 3, 7, and we want to sort them. So how will you do it? First of all, going from all the values. Now, of course, as I mentioned before, you can go for the minimum value or you can go for the maximum value. So let's go for maximum value. Okay, so ultimately you will get the same output, but the way you do the code will be different. So let's say we are going for the maximum value. Now from all these values, we have to find the maximum value. Now, of course, at the start, we don't have any idea which value is the maximum. So let's say you make 6 as the maximum value because at this point we don't know, right? So let's assume that 6 is the biggest value from all these values. And then you start comparing 6 with all the other values. So you will compare 6 with 5. If 6 is still bigger, no issue, go with the next value. If 6 is still bigger, no issue, go with the next value. Now at this point, we are comparing 6 with 8 and we know now 8 is the biggest value. So now what you do is you change your variable or you change your biggest value from 6 to 8 and then you start comparing 8 with the other remaining value, which is 3 and 7. So you compare with 3, 8 is still the biggest. You compare it with 7, 8 is still the biggest. Now once you go through all the values, now you know the 8 is the biggest value. So what you do is you make sure that 8 goes at the end. Now if you're doing this for the minimum value, what you do is you take the value 2, which is a minimum value, and you put that at the start. But since we are going for a different approach where you're finding the biggest value, you will make sure that 8 goes at the end. Now when you move 8 to the end, what happens to 7? Now 7 will say, okay, I don't have a place. So 8 will say, don't worry, I will come to your place, you come to my place. That is swapping of the values. But if you remember, we are not doing it in every iteration of the inner loop. We are doing that in the outer loop. So once you complete one pass, that's where you do the swapping. So only once for the entire iteration. Okay, now by doing this, we have made sure that you have the biggest value at the end and you got a sorted at the end, which is the 8. And then the first 5 values are still unsorted. So what you do is you repeat the steps. Again, start with 6. Now we'll say, okay, 6 is the biggest value. Let's assume that. And then you start comparing 6 with 5. If it is the biggest value, 6 is still bigger, no need to change the value of biggest value. Then you compare it with 2, no need to change. But then when 7 comes into picture, 7 says, hey, you know, I'm bigger than you. So 6 says, okay, you're the biggest value. So now the current value will be 7. The biggest value is 7. Now again, we have to compare 7 with 3. Now 7 is still the biggest. So we have to make sure that after all this iteration, we move 7 at the place of 3. And that's what we are going to do. Now by doing the second iteration, so we have completed the second iteration in which you got 2 values, 7 and 8 at the end, and the first 4 values are same. So again, you do the same thing. Next iteration. So you have to do this till you complete all the sorting. So you again go with 6 and say, hey, you know, I'm the biggest now. Let's compare 6 with 5. So still the biggest. Compared with 2, still the biggest. Compared with 3, still the biggest. Now, once you complete that unsorted iteration, you will make sure that you move your 6 to the location of 3 because that's where the 6 should be. So it will swap with 3, and then the last 3 values, 6, 7, 8, are sorted. The first 3 values are not sorted. So again, if you observe, what we are doing is we are making sure that you got 2 different sections of sorted values and unsorted values. Now goes for the first 3 values. So 3, let's assume 3 is the biggest, and then compare it with 5. Now we know that 5 is the biggest of all, or at least bigger than 3. And then you compare, you make the bigger value as 5 now, 3 is gone. Then you compare 5 with 2, still 5 is biggest. And now we know that 5 need to go at the location of 2, so you have to swap it. Now comes the first 2 values, again the same thing. You will keep doing this till you reach to the end of your array. And you move to 3. And since we only have 1 value, you don't need to sort it. That's already sorted. And by doing this, you basically got a sorted array. Now again, compared to the bubble sort, we are still going from start to end. You have an outer loop, you have an inner loop, but we are doing swapping only once in every big iteration or in every pass. So that's the advantage of using selection sort over the bubble sort. About the overall, the time complexity is still O of n square, but at least it is better than the bubble sort in terms of swapping. Now it's time to implement selection sort in Java. So in the previous video, we have talked about the bubble sort, right? And this is how it works. Now, one thing to remember, in the inner loop, can you see this loop? In this loop, we are basically doing this swapping. So it increases the time as well. So in selection, what you do is you basically swap this. Of course, you do that swapping, but outside the inner loop, somewhere here. So it reduces the number of swap you're doing. How will you do it? So what I will do is I will just remove the entire code from here because this is the bubble sort. I don't need this. And what we have here is we have the array, which has 6 elements. We got a size variable where we are storing the length of an array. And then we also have a temp variable for swapping. Then we are printing the array before sorting, and we are printing the array after sorting. Okay. So if you run this, you will get the values before sorting, after sorting, but at this point they are same. Is because the main logic of sorting is missing here. So let's write the logic for selection sort here. The thing is, in the theory, we have said that we'll go for the maximum value, the biggest value to swap, or we'll put the biggest value at the end. Let's say in the practical, let's try to implement with the smallest value, and we have seen both the approach then. So what we're going to do is we'll look at the entire array, and then we'll find the smallest value, which is 2. Of course, you have to iterate between all the values. And then once you got the smallest value, you will swap this 6 with 2 because 2 should be the first value, and that's how we can start. And for doing that, we have to use 2 loops, the outer loop and inner loop. We'll start outer loop with 0, and then we'll say I less than size, right? Okay, so we'll say I plus plus. But also we can make it more efficient by saying that size minus 1 is because if you remember, when we were doing the sorting, and once you got all the values sorted except the first value or the last value, you don't basically sort the one value, right? So you can reduce the number of iterations you go for. So we can say size minus 1, and we'll see if that works or not. And if it works, then we are happy. We'll also go for the inner loop. Now for the inner loop, we'll go for j equal to. Now where do we going to start j? So basically, if you're putting the biggest value or the smallest value at the start, what it means is for every iteration, the inner loop, we can skip the first value, right? So for the second iteration, we can skip the first value. For the third iteration, we can skip the first 2 values because they are sorted, right? So we have 2 sections, right? Sorted array and unsorted array. So here we can start with j equal to I. Yeah, in fact, when your I value is 0, j should start from 0. So we can say j equal to I and j less than size and j plus plus. So basically we have to go till the end. Okay, so that's the for loop we have. Now what you do inside this? So we have to find the minimum value. To start with, we can take min value variable here. So I can say int min is equal to 0. In fact, we want the min index, not the min value, because we have to work with the index, right? And we'll say the index is by default -1. And here to start with, we'll start with min index equal to I. And then what you do, you basically check if the array which is nums of min index. Now we want this to be smallest value, right? So I assume that this is the smallest, but what if this is not the smallest compared to the value which we are considering. The value which is considering here is nums of j. So example, if this 6 is the smallest which we are thinking, in fact, we should be saying I plus 1. The reason being, when you are saying that 6 is the minimum value, we are assuming that, and then we are comparing with 5. Now, you will get 5 when you say j starts with I plus 1. Because in the first iteration, the value of I will be 0, and this 5 is 1, right? So we'll compare these two values. Okay, if 6 is smaller than 5, then everything works. But what if 6 is greater than 5? In that case, we have to swap. Now, okay, we don't have to swap. We basically have to change the min index to j, because the new index we will get is j. So the new index here is 1, okay? So that's the min index. So what we are doing by doing this is, after the entire iteration, you will get the minimum value from this array. Okay, so that means after this iteration, you will know that 2 is the minimum value. Now, once you know the minimum value, what you do is you swap 2 with 6. It's that simple. How do you swap 2 and 6? How do you know we have to swap 6? Because I is referring to 6 and the min index is referring to 2. So we can simply swap them. So we can use a temp variable here and we can put nums of min index, and we can say nums of min index is equal to nums of I, and nums of I is equal to temp. So basically we just have to swap them. So what we are doing is, in the inner loop, we are just finding the minimum value, and then once you find it, you simply swap it with the min value which you're considering, which is the first value. And as the I value goes up, first you will compare with this, then you compare with the 5, then you make 2 as the minimum after the swapping. And what I will do is, I will also print this values after each iteration. So I can just copy this and paste it here, and we also print a new line to get it on the new line. So now if you run this, let's see what happens. So you can see if this is okay. I will, after printing this also, I will just say new line. Or maybe I will just keep this new line before the for loop printing. Okay, let's run. And you can see this is before swapping, and this is after swapping. So let's compare the value. Is it properly sorted? Yes, 2, 4, 5, 6, 8, 9. Those are the values we have. And then see the steps. In the first iteration before swapping, so this is the first iteration. What you do is, you know that 2 is the minimum value, so you swap 6 with 2, and that's done. Then in the second iteration, you find the minimum value. So the minimum value from this is 4, so you swap 4 with 5, and that is done here. Then you consider 6. Then you say, you find the minimum value from this, which is 5. You will swap 5 with 6. So in this, you will say 6 is the minimum, so you will swap it with 8. Comparing this to, this is 8 and 9, so you will swap 8 with 9. And in last value, you don't have to even sort it because it's already sorted. And that's what we are doing here. And that's why we say it's size -1. We don't even sort here. In fact, if you don't put this -1, what will happen is, if you run this code, you will get one more iteration and there's no change there. It doesn't matter how many values you have. You're not going to have any change in the last iteration. So you simply save it by saying -1 here. So yeah, that's how we use selection sort. Basically, you find the minimum value and swap it with the location where it should be. So we have talked about different sorting techniques. We have talked about bubble sort and selection sort. In this video, we'll talk about insertion sort. So what you do in this technique is, basically you take the elements and then you put the elements at the right position. That is your insertion. So you have to put at the right location. Now in this, you don't normally do swapping. Yes, we do swapping, but we don't use word swapping. What you use is something called shifting. Okay. So example, if you're playing cards, so if you have a random cards on your table, so basically in this example, we are not going to use cards. We are going to use this characters. I found these characters in my drawer. I think I got it for my kid's birthday, but it doesn't matter. So I got this, and we'll try to sort these values here. So let's say if you randomly get these values, and if you want to sort them, what you do is you pick up the value, and then you imagine these are cards, playing cards. So what you do is you take the first value, you take the second value, and then you keep it like this. I don't know how many of you play cards. I used to love them, not for money, but I used to love them. Then you take a next card, and then you put it before this. Then you take a card. Then you know that this card goes between A and O. You put it here. So this is called insertion. But how exactly you're going to do that? That we'll see with the example on this table. and with this cards. So now let's sort these values. Now these are not values but characters. So let's try. So what we have here is we'll start with the first location. As you can see on the screen, we have different values here, and I'll pull this down a bit so that we can have some place to keep this. So the first value is O. Now I'm assuming the O goes here, the first location, because it's always sorted. And then you take the next value, which is E, let's say. Now we know that E comes before O. So what we need to do is, this need to go at the start. So you have to move this to the next location so that you will have some space for E. Now the point to remember here is it's all about shifting, okay? So we don't use a word swapping here. You will understand that in some time. Why don't we say swapping? Let's go for the next one, which is S. Now we know that S is greater than, so we'll compare S with all the values. So we'll compare S with E. Okay, it goes after that, it goes after O. So S goes here. Okay, I'm not promoting any camera model here, but that's the sequence. Then you go for the next one, which is D. Now D goes at the start. So what you do is, you basically have to move all the elements, right? So if you compare with S here, D is less than S. So you compare, so you have to shift S. You have to make some space for D. Then you take O and you move O here so that you can make some space for D. Then you compare D with E and you have to make some space. Of course, you have to swap, you have to move this. You will make some space for D, and D goes here, right? So now it is in sequence. Then what about the last value, which is A? Now A, we all know we have to, of course it goes at the start, but we have to compare from start or last. So this goes here, which is S. If it is less than that, we'll shift this to make space for A. But then we have to also check with O. This also have to shift. We check with E. This also have to shift. We compare with D. This also has to shift. And then A goes at the start. By doing this, what you're doing is you're basically inserting value at their location. So this is how you do the insertion sort. Now let's say this was randomly we were picking values, right? But what if you have things already in the array? So what we'll do is we'll keep it here. We'll keep this here. We'll keep this here. This goes here. And let's say this goes here. In fact, I will also move this. Okay, I'm not trying to make any city name, but let's say we have this sequence. We have these 5 values. And now you want to sort them. So what you do is, you don't start from the first value. You start with the second value. And then, because we are assuming that the first value is already sorted, okay? So what you do in this technique is, basically you divide your list or array into 2 segments, the sorted and unsorted. At this point, all are unsorted. Oh, so this is unsorted array. But when you start, you have to assume that your S is already sorted. Then you start with E. Then you see, hey, do we have E at the right position? The way you do that is you compare E with S. And you say, hey, you know, E is not at the right position. So you will take E out. In programming, what you do is you save the value of E in the temporary location. Okay? So exactly, you're not moving E. You're just making a copy of it. Maybe there will be a copy of E here as well, but you have extra copy with you saved in a temporary variable. So let's say this is a temporary space. Then you move your S here so that you can make space for E, and that's sorted now. Now if you see this too, it looks sorted. Now what you do is you check E before do we have any value. So of course we don't have any value before E. Now that is sorted. Then you go for the next value. So we started here. In the next iteration, you basically start with O. Now O will compare with the previous value, which is S. Now is it the right position? No. So we have to copy O in the temporary variable and move your S so that you can make some space for O. And O, of course you can move O here. You have to also check if O really goes here. You have to compare O with the previous value, which is E. And we know that O is greater than E, so you can keep O here. So that's how you basically sorted the third element. Then you go for the next element, which is D. So what you do is you compare D with S here, and then you know that D is smaller than S or S is greater than D. So what you do is you have to move. So you take it into temporary variable, move S here. Of course, you don't move D directly there. You have to compare D with the other elements, which is O. Is it smaller than that? Yes. We have to move this here. We have to make space for D, right? Again, before that also we have one more element, which is E. So you move E here. It's all about shifting values. and then your D goes here. And if you compare, it looks sorted, right, compared to the other values. So it looks sorted, but then we have to complete one more iteration. So you take A, you compare A with S. Now A here is compared with S, so again we have to shift. So what you do is you take A in the temporary location, then you move your S, you will check A with O, again you have to move O, then you check A with E, again you have to move E. So remember, you have to only move when you know that A will not be at the right position. And then you compare A with D, again D has to move so that you can make some space for A. So this is how basically you do this sorting technique. Now question arises, how will you do in programming? So what you need is you need two loops. One for the number of passes you are doing, right, moving from different element, and you need an inner loop which will be responsible to find the key and shift the values. And also you need a temporary variable so that you can store it somewhere. So you need a key which will go into a temporary variable on something. Now how do we do this? That implement in the code. So let's try to implement insertion sort using Java. Now basically, even before we implement that, before we write the code, let's write the algorithm on the board and then we'll try to convert that into code. So what we'll do is, first of all, let's get some values, okay? So we also need an array. So let's say I will name this as array itself, ARR, and then it will have some values. So let me create an array here and we'll take few values. Let's say we got 5 values. Of course, you can go for more values here. And then let me just say these values are 3, 6, 2, 1, 5. Okay, so we got these 5 values. Now, I want some variables as well. So as I mentioned before, we don't swap here, right? We do shifting of the values. So of course, to achieve that, we need inner loop and the outer loop. So let's say we got the outer loop, which will go for loop. So let's say we have a for loop here. And then we have to take a variable which is I for the outer loop counter. And then inside this, we are going to have a while loop, which will have, let's say, some condition. Of course, you can also go for and for, but then when you talk about insertion, using while loop inside makes much more sense, is because we want to run this based on the condition, not on the number of iterations. Okay, so this is your outer loop. Let's finish it here. This is your inner loop. Let's finish it here, and let's write the code there. Now we need 2 variables, as I mentioned. Of course, in the while loop, we are not going to create a variable. We are going to use one variable, but let's also go for J. So we need a I variable. Let me just write I here. We need a J variable and we need a key as well so that you can store this value somewhere. So at one point you will compare and you will save it. Now from where we are going to start this. Now if you want to understand what we are going to do, it's very simple. So initially you will take your 6 as a key. So when you write this variable, we'll say key is initially 6, okay? Now how you're going to get 6? So let's say we take a variable I here and then we'll keep the J here, okay? So we're not going to start I from the first one, we're going to start I from the second one, and then J will be the first value. Now I will represent the outer loop and J will change in the inner loop as well, okay? So that's why we are going for I and J. We could have gone for different variable name, but we got used to I and J for the outer loop and the inner loop. Okay, so now what you're going to do. So the idea is very simple. Once you got a key, which is 6 in this case, now how you got 6? Maybe we can do something like this. We'll say ARR of I. Whatever I represents, we'll save that in the variable K or key. And then we're going to start J by saying J is equal to I minus 1. So I is starting from 1. So J is I minus 1. That means the value for J initially will be 0 and I is 1. Now what you're going to do with this? It's very simple. You will simply compare the value of J, which is this, the first value. So you will compare J with the key. If this value is greater than the key, then you will do the shifting part. At this point, we don't need that, right? Because the value of J, where the J represents, is less than the key, then you don't have to do any shifting part. So this is already sorted, okay? But let's go for the next iteration. Now, when you send the next iteration, it's very simple. What you simply do is, so you shift your value of I here, and you shift your value of J here, because we know that the 3 and 6, if you compare this two, they are sorted. Let's go for the next one. Now in this, what you will do is you will check. Again, you will change certain things, right? If you can see, this will change because now ARR of I is not 6. ARR of I is basically 2. Okay, so key is 2 now. What about the value of I? Even I is changed. I is now 2. So index is 2. So let me also write index so that it will make much more sense, right? So that those are the index value. So I value is 2 now. What about j? So j is I minus 1. So j will start from 1. That's done. And now you will apply a condition. So what basically condition we are checking for? So of course, if you write the code here, so I is initially starting with 1. We are now starting with 0. And then we'll go till I less than n if the length of this array is n. And then we'll say I plus plus. Okay, and then we'll assign the value. Okay, let's not write the actual code. Let's write some dummy code. So let's say we got a key variable. The value for key is basically ARR, which is the array of I. And that's what we are doing here. That's one thing. Next, we also need j variable. So we'll say j is equal to I minus 1. Okay, that's how we're going to start. Now, what you're going to compare in the while loop. So in the while loop, it's very simple. You will check for the ARR. So ARR of j. Okay, let me just say, complete this here. So if this is greater than the key, because the shifting part will come only when whatever is represented by j is greater than the key. So if you can see, the key is 2 here. And in this case, yes, it is greater. So 6 is greater than 2. So what you do is you basically perform some operation. Now what operation I'm going to perform? So basically, first of all, I will take this key somewhere. Of course, we are storing that key 2 in the key variable. And then you do the shifting. Shifting of what? So you will first compare this 2 with 6. And now we know that we have to shift 6. So you will shift 6 here. Then that's one done, right? Can you put 2 here? We can put 2 here. But the problem is we also know that we have to compare 2 with the previous value, which is 3 in this case. So you will not shift 2 there, but we'll shift 3 here. But then to shift 3 here, what we have to also do is we have to first shift our j here on the first location. That means we are also going to perform j minus minus, right? So what I'm saying is the first option you're going to perform is shifting the values, right? So how do you shift? You simply take the next value. So initially j was here, right? So this value 6 is going here. So that means what we can do is we can say ARR of j plus 1, which is in this case 2, is ARR of j. By doing this, what you're doing is you're shifting. So the j initially was here, which is 1. So index of j was 1, or the value of j was 1. Then you're saying j of 2, j becomes 2. Then what we are saying is we are saying j plus 1, which is 2. So the value of 6, which was here, will move here. That's what we are doing on this line. That's a shifting part. And then you will say j minus minus. So you can say j minus minus, or you can say j minus 1. Even both works. So this is the entire logic you have, right? But this loop will repeat, right? Now, when it will repeat, look at the condition here. The condition is whatever j, so we are shifting j backwards, right? J is now here. So we'll check if ARR of j is greater than key. In this case, yes, you can see the key is 2, ARR of j is 3, so it is greater, so we'll shift. So how do you shift? Basically, you do the same operation which is there inside the while loop. So if you compare this operation, this is what it is doing, the shifting part, right? And then we know that, of course, if you can see here, we have one more step. You will do j minus 1, which means your j basically moves 1 here, because when you reduce the value of j, it became 0, right? And then again, you're doing it, so it will become j becomes minus 1. So we have to stop it here. Once the j becomes less than 0, we have to stop. But don't you think we have to also add that condition in the while loop? So we'll do that. We'll say, and j should be greater than or equal to 0. Okay, this is one condition we have to add. If this is false, if j is not less than or equal to 0, then you will do the last step. The last step is very simple. You move your 2 here. And the way you can do that is by saying ARR of j plus 1, because j became minus 1. We don't want minus 1. We want 0 is equal to k, is equal to key. So basically, this is where the value goes first. Now, by doing this, we were able to sort the first 3 values. Now, what next? Of course, you will increment the value of I. So when you say increment, that means the value of the I variable goes here. And again, for the next iteration, j goes I minus 1, right? Because of this, basically. For the outer loop, the I value is incrementing, but the j value is just before I. And again, you do the same things. What are the same things? You first check if the key, okay, we have to update the key as well. Now, how do you update the key? Now, the key value is ARR of I, which is in this case should be 1. So the new key is 1, and I is what? I is 3 and j is 2. Okay, new key value is 1. You will compare. If the ARR of j, this is the condition we're checking now. If ARR of j, which is in this case is 6, is greater than the key, in this case, yes, you perform this operation. What is the operation? It's very simple. Let's keep this value somewhere. You start shifting 6 here. 6 goes there. And then your j comes back. J comes here, right? Because of this step here, right? And then you again check if ARR of j is greater than key. Yes. 3 is greater than 1. Again, you will shift 3 here. Then you shift j here. Then again, you shift 2 here. Then you shift j here. And then now j becomes -1. Let's stop the loop and shift 1 here. You can just do the same thing for 5. Let's do that quickly. So what you will do is you will shift the value of I here, which means certain things are going to change. Now this I becomes 4. This j becomes 3. The key value now is 5, right? Again, you do the same things. You keep your j here because j is just I -1. Then you compare. If the ARR of j, which is 6 in this case, is greater than the key, yes. Let's do the shifting. Now, how do we do that? Let's move that here. And then we have to shift 6 here. J goes here. Now, again, you check. Is the ARR of j is greater than key? No. It's not there. So you will just simply come out of the loop and then you will keep 5 here. And if you can see, it's all sorted. So this is the logic. Let's implement this logic in the code now. So you have the logic in front of you. What you will do is you got the same values. In fact, we can go with the values which we have. So let's say, okay, I just rewritten the values. Let's go for these values and let's see if this works. Instead of array, we are going for nums. That perfectly works. I don't want a temp variable. So we can remove this portion here. This is basically the older code which we had for selection sort, if I'm not wrong. And this is the before sorting elements. This logic is going to change for sure. Okay, so let's write the logic. It's very simple. You create an array. So let's say this array is ARR is equal to, let's have some default values to it. Let's say 5, 6, 2, 3, 1. This time we are going for only 5 values. And this is an array. Okay, what next? Now, basically, as we have written in the board, let's take a for loop. Now, the for loop is going to start with I is equal to 1. And we can do that quickly now. It will finish at n, but we don't know what n is. So we can say array.length, and we can say I++, right? That's 1 done. And now, okay, let me just remove some space in between. Okay, now what are the extra variables we need? Basically, we need 2 variables, right? We need key. The value for key will be ARR of I, which we have done earlier. And then we also need j, and we know j is j -1. You know, this is what happens when you know the algorithm on the board, right? I have a board with me. So, okay, those are the things we need. Okay, not j -1, it should be I -1. And then you do a while loop because this is where you do the iteration. We have to make sure that j is greater than 0. That's one thing. And we need to also check if ARR of j is greater than key. In that case, you will execute the while loop. So you will do certain things here. Now, what you are going to do inside this while loop. So basically, you have to do the shifting, right? If it goes inside, you will say ARR if j plus 1 is equal to ARR of j, right? And also, you have to reduce the value of j. So you will say j, we can even say j minus minus. Syntactically, that works. And for the outer loop, you will assign the value for key for that particular empty location. And the empty location is defined by j itself. So j plus 1 is equal to key. And I think we are done. So the code is so short. Let me check if that works. What I will do is I will just print the values here. So I will take a for loop and I will say int num from array, and let's print the values. Let's say print num. I don't want the new line. I would just want a space here. And let's see if that works. Right click, run, and boom. You can see we got the output and the values are sorted. It doesn't matter what type of values you add here. Let's say 8, 4, and run. You can see this is sorted. Yeah, so that's your insertion sort. In this video, let's talk about another sorting algorithm which is called a quick sort. So the thing is, when you talk about sorting algorithms, the idea here is to explore different algorithms and we'll see how efficient it is. Now, when we talked about the other algorithms which we talked about till now, bubble sort, selection sort, they have a big O notation of n square, which we don't want, right? We want to make it faster or efficient. Now, in that case, we have to explore some other algorithms, and one of them is quick sort. Now, in the best case, the quick sort goes for n log n, which is much better compared to the n squared. But in the worst case, also it goes for n squared. So in the worst case, yes, it is almost there, but on average, it is n log n, or you can say the best case. So at least we are happy in the best case and in the average case. Now let's say, what is quicksort? So actually it uses multiple things. So let's talk about that first. The first thing is divide and conquer. So basically till this point when we talked about bubble sort or selection sort, we were doing the algorithm on the entire collection. So let's say if you have a list of values which is 6 values. So what you do is you perform the operation of bubble sort and all the sorting techniques which we have done before applied on the entire list. But what quicksort says, let's do divide and conquer, which simply means divide your problem into multiple things and solve the problem or sub-problems individually. So what you're doing is you're dividing it, you're solving it, and at the end you will combine it. So that's your divide and conquer. So in this case, if you have 6 values, let's divide the values into multiple sub-problems and then sort it and then combine it. So that is your divide and conquer. Next, it uses something called a recursion. Of course, you can also use recursion in the other algorithms, but here it works with recursion. Now, basically, what is recursion? So when you call the same function by itself. So example, let's say the function name or the method name is show. And if you're calling show inside show, that's your recursion. Right? And next we have to understand the concept of pivot. Now basically pivot is something called a central point of a problem. Okay, so let's say you have this entire list here or the array. Now you have to find a pivot and then based on that you will perform the operation. Of course it will make much more sense when we start, but remember we have to work with the pivot. So those are the things we have to remember: divide, conquer, recursion, and pivot. There is one more thing which is the tree. Now basically when you say you are dividing your entire list into subsections or sub-problems, what you're doing is you are creating a tree structure. Okay, so once we start with the diagrams, it will make much more sense, but these are the things we have to remember. So let's see how your quicksort works, and then we'll try to convert that into algorithm, and then we'll see how to write a code for it. Now the basic idea here is, let's say you have a list of values. So we are discussing about quicksort. So let's say we have a list of values. So let's go for 6 values here. And I will say this is 5, this is 3, 6, 1, 4, and 2. So let's say we have the 6 values. I'm not sure will it really make sense to use this example, but let's get started. Now with this 6 values, what you normally do is you do divide and conquer here. So the basic idea is break the entire list into sub-problems. Okay, something like this. Maybe we can create two different arrays. Here we'll be having 5, 3, 6. Here you can have 1, 4, 2, and then you can again divide this. Maybe you can have 1 and 4 here and divide this into 2. Here also we can have 5, and then we can have another array which is 3 and 6. So we got these 2 arrays from the big array, and then you create the shorter format of it. So at the end, what you're doing is you're creating the small chunks. Now this is what your tree structure is. So we have divide, we talked about divide, so we are dividing it. We'll sort the array and then we'll combine it. And then since we are performing the sorting on each section, each sub-problem, that is your recursion. But is it the real thing? No. So basically we talked about the idea, but how do you divide the array? Randomly I just divided the array, but that's not the main idea. But we have to divide, but not this way. So how we are going to divide this? That's the question. Let's remove this and let's go with the values here. The idea is you want to divide, for sure. You will divide this into 2 parts, but you need to find a point from where you will divide this. And that point is basically your pivot. Now, how do you find a pivot? Now, basically, the reason we get this partition or pivot to do the partitions of the array, right? Now, should we pick up 1? Now, that depends. So even before you divide, you have to do one more thing. So I'm saying pivot, but then that pivot should be a point which is at the right position. Let me repeat. The pivot is a point in this array which is at the right location. Now, if you see this, after this sorting, what the values you will get. So you will get values like, let's say, I will just write it in shorter format now. So you will get 1, 2, 3, 4, 5, 6. This is the output I want. Okay, just wait for the sequence of numbers here. But this is the output. So this is the output which we want from this input, which we have the bigger array here, or the big size which I mentioned. Okay, so if you talk about the value 1 here, so 1 should be at the first position, 2 should be at the second position, 3 on the third position, fourth position, fifth, and 6th, right? So they should be at that position. Now, since we have taken those values, and that's why it might be confusing, but you got the point, right? It doesn't matter what your values you have. It should be in the ascending order. So the first value, the smallest value should be first, and then a list goes on. Okay. Now we have to make sure that at least you find one point from here, or one value which is at the right position. Example, if I say, let me take 4. Now 4, is it at the right position? The answer is no. 4 should be here, right? So instead of 1, it should be 4. Then we can say 4 is at the right position. Now, if you want to understand this with an example, so let's say you're in a classroom and then you have multiple students there, okay? And then you want to sort them based on their height. There's one way, as a trainer, I can be there and I can say, okay, you go there. And that's what we have done in the bubble sort, right? I was controlling it. But what if student can sort themselves? So they can compare each other and they say, okay, I should be here or I should be here, and they will move. Now, one way is one person can sort them, but then we don't want it. So what we want is, what if the students themselves can get into the right position? That will solve the problem, right? Okay, but how we are going to do here, how they will reach to our right position. Now what you do is, initially we don't know the position, right? So you can take any value. Normally we can find the pivot. So for the first iteration, what we are trying to do is, we want to make sure at least one value is at the right position so that we can divide the array. Now which value should we take? Technically, if you take the average value, or if you take the middle value, example, if you go from 1 to 6, the mid value is 3 or 4, right? So if I can take 3 as my pivot, it will be much easier for me to divide the array. So what will happen is, if I take 3 as my pivot, then 3 should be coming here, right? So this is the right position for 3, right? But it's not. If you start with the array, this is not at the right position. But if you get to the right position, we can divide into 2 parts, right? Okay, so that's the main idea. How will you get that there? So normally what you do is, if you can find a good pivot, and that's very difficult to find, because how do you know the mid value? Since we know the values here, I can find the mid value. But as a program or as a software, they don't have any idea what are those values are. So what we do is, we randomly pick the pivot. Maybe you can pick up the pivot, let's say 1 in between, somewhere, anywhere if you want. So you can pick up this 1, you can pick up this 6, or you can pick up the first value, or you can pick up the last value, or what you can do is, you can just add all these values and divide by 6, whatever value you will get. So try to find the average of it. That's what we can do. But again, that's a lengthy process. Normally, which I have seen, is they go for the last value, not the biggest value, last value, because we don't have any idea what the biggest value is. So we will go for the last value. Okay, so this becomes your pivot. That means we need multiple variables here. Now what variables we need? So I will just write variables here. So the first variable we need is a pivot variable. So we'll say pi. Okay, and then you need few more variables. You need a variable I for the positioning. Again, we'll discuss what this positioning is. Then we'll need a j, which will go through each element. And we have done that in the sorting, right? So when you jump from each value, that will be done by j. And then of course, we also need array here. So let's say this is ARR, this is your array. Okay, and let's have the index value. So we'll say this is 0, 1, 2, 3, 4, 5. Those are the index values we have. Apart from this, we also need a low and a high variable. Okay, so we'll say L and H. So let's say this is L and this is H. Now, normally we can say H is the last value, or we can say it's a length minus 1. So we can say that. So we have a low and we have a high. So low starts from the first, and H is the last value. Now, how do you perform the operation? It's very simple. First, you find the pivot. Now we know that we are going for pivot, which is 2 in this case. So what you will do is, let's take this 2 as the pivot. So I will say this is P. So this is referring this 2. So Pi variable at this point is referring to. So I will say this is 2 in this case. And then we need 2 variables. So let's take variable I. Now by default, the value for I will be the lowest value minus 1. So let's say the I value is here at this point. You know what I will do? Let me just remove this portion at this point, because let's keep the slate clean. So we need an I variable, and then we need a j variable. So j will be here to start with. So I will be here at the -1 position, j will be here at the 0th position. And then what you do is, you basically run a loop where of course the I will also increment, but the main loop here we want is for j. Okay, so we'll take a for loop for j. Okay, so let me write the code here. So what we want is, of course, the rough code. So I will say for j will be starting with low. Okay, that's what we are doing here. And then j should go till n, but then we are not using n variable, right? We are using variable high. So let's say j less than high and j plus plus. Now what you are going to do inside this loop. So basically, you will first make sure that you get the pivot value, right? So you will, of course, you have a pivot value here, which is 2. And then you also got I is still -1. Now inside this loop, what you will do is you will check if the ARR, which is in this case, we have an array, if ARR of j, if it is less than the pivot, so pivot, we have a variable here. If it is less than pivot, you will perform some operation. Now, if you compare the values here, do you think the ARR of j, which is 5 in this case, is it less than the pivot? Because pivot value is 2. No, it is not less than pivot. So we'll not do anything. But we have to find a value which is less than 2, right? So if the value phi is less than 2, you will perform some operation. Since it is not true, we are not going to perform any operation here. So basically, you're going to shift your j here. Okay. Now, why we are doing it? Of course, we are running a loop, right? So j starts with low, and then we have to increment. So j goes there. It will compare itself with the pivot. Is it small? No. So again, you will shift your j. Then you compare 6 with 2. Then is it smaller? No. Then you shift your j here. Then you check. Is it smaller? Yes. What if it is smaller? Then what you will do? In this case, if it is smaller, you perform some operation. First thing you do is you increment the value of I. Basically, what you're doing is you are shifting your I here. Okay, that's done. Next, we have to make sure that you swap the value of I and j. Okay, so whatever value you have with I and j, you basically swap them. So what I'm saying is, take this value here, move this value 5 here, and move this 1 here. Okay, now how do we do that? Of course, we have used it before. So we can use a temp variable, or maybe at this point, I will simply say swap, and then we'll write the logic later. So I want to swap basically the value of ARR of I with ARR of j. Okay, so we need to do the swapping. That's it. These are the things we are doing inside the if condition. Now, once that is done, of course, you have to move your j again because we are in a loop. So j will go here. Now, again, you will compare. If the 4 is less than 2, no. And that's it. J will move here because if it is not less, then we are not doing any operation. Then your j goes to the last value because your j ends at high, right? So j reaches here. And of course, the pi and j is same. Then you don't have to, of course it is false. This condition will be false, which is ARR of j is not less than pivot. So in this case, it will not swap. But what happens after that? Even if you complete the entire loop, do you think 2 is at the right position? No, 2 should be here, right? So this 3 need to go there. So what you do is you perform one more operation after the loop. So after the loop, what you will do is you will basically swap the ARR of I plus 1 with the ARR of high. Okay, now this is the operation you have to perform. Now, what will be happening here? So what is the value of I? Value of I is 0, which is index. You're picking the next value, which is 3. So you have to swap this 3 with this 2 because that's what your ARR of high is. So you will move here and you will move this side. Now, by doing this, we made sure that the pivot value which you choose is at the right position. Can you confirm, is it the right position? Yes, it's the right position. Now what you do is you divide, if you observe the array, if you look at the pi, which is pivot here, now if you see the left-hand side of it, this is always lower than 2, and this value is always greater than the 2. So yes, 2 is the right position. Now what's the next step? The next step is very simple. You divide this array based on the pivot value. So what you do is you create another array here, and in this you will be having only one value, which is coming from here, right? In fact, we can also draw an arrow there. So this is coming here. 2 will remain there itself. Maybe I can write 2 here. We don't have to work with 2 because it's already sorted. And then you take this particular section into another array. Not another array, but let's say logical partition we are doing here. So we'll get another array here. So we are doing divide and conquer. So here you're going to have 6, 5, 4, 3. If you observe, they're not sorted, but at least we got the partition, right? Now what you do is you again perform the same operation which we have done here in the first example. Now you help me. Should we start with this? Yes, we can start, but don't you think we only have one value? And whenever you have one value, it is already sorted. Let's work with this. So what you do is you again take the same thing. So you take the low, you take the high, and then you, of course, you again have this all these values here. So all these variables are still exist because you are going to apply quicksort again on this particular values. So let's get started. Let's take pivot. Which pivot we are choosing? Of course, we are choosing always the last value. So this is your PI, pivot. Then you got I here, you got J here. Then what you do is you start running your algorithm, which is first you compare the value of J, which is 6 in this case. Is 6 smaller than 3? Look at the algorithm which we have done. Is 6 smaller than the pivot? The answer is no. So you will simply move your J here. Again, check, is it small? No. Shift, is it small? No. Is it, then again goes here, is it small? No. Then what you do is you have not done any swapping, but at the end we got one more logic, right? So once you complete this for loop, you will do something with this, which is swapping the I plus 1. So I is at -1. So you have to basically swap the 6 with the array of high, which is 3. So this goes here and this goes here. Now if you look at the pivot, this is sorted, right? So now what you do is you write 3 here, which is your pivot value, and then you divide your array into 2 parts. But since the pivot was the first value, what you will do is you will get the new array now from this, which is 5, 4, 6, and then you start performing operation here. Now what operation? The same operation which we have done. Again, you will apply quick sort. So this is L, this is H. So PI is referring 6 here. And then you start. So you got I here, you got J. Then you start comparing. Is the first value, the value of J, is it smaller than the pivot? Yes. Now when you say yes, what you will simply do is you will increment the value of I first. If you look at the code, that's what the logic we have. And then you swap the value of I and J. Now in this case, I and J are referring to the same value. So swapping doesn't make sense. Of course, they will get the same value. Then you increment the value of J. J goes here. Check, is 4 less than 6? Yes. In that case, you will move I here. And then you will swap the value of I and J. Again, it remains same. So nothing to do here. Then you shift your J here. Of course, the array of J is not less than pivot because they're the same value. Then this loop's end, the for loop ends. Then you perform this operation, which is ARR, which is +1. This will be replaced by high, and that remains same, right? So there's no swapping. I know it all depends upon the value, type of values you're getting. So at this point, there's no swapping happened. So this remain as it is, 6. But then you will get a new array here, which only has 5 and 4. And then you start applying the same operation. Let's get started. In fact, I will just write this bit up so that I will have some space. And this is coming from this particular section. Then what you do is you will take the same value, you say, and if you observe, we are doing recursion, right? The same steps we are repeating multiple times. So LH, we got PI here, we got the variable I referring to -1 position, or in fact, not -1 position. It is 1 less than the low. So in this case, the low is this position, right? Now, what is this position? This is, in fact, we should have maintained the index value, right? So this is 0, this is 1, this is 2, 3, 4, 5. Then we got 3 here, which is this one. This is 3, 4, 5. What we got here is 3, 4. So these are the index values for them. Okay, so we got I referring to the index value 2 and J is here. Then what you do is you simply compare the same steps which we have done. So the array of J, is it less than 4? No. So all this operation, this swapping is not needed. You will simply move your J here. Again, do we need to swap? Of course not, because the array of J is not less than pivot, so it will remain same. But then you will perform the last operation, which is this one. What it says swap this value with the high value. So this will be swapped. So 5 goes here, this goes here, and this goes here. Now, if you observe, we divided and we conquered. So if you merge this, in fact, we are not merging physically, we are merging logically. Right? Because nowhere we were breaking the array. But if you see, if you try to merge logically, what you will get? So you will get this 1 first, which is 1 goes here, then 2 goes here, then by sequence 3 goes here, then by sequence this 4 to 5 goes here, and then this 6 goes at the end. So if I want to write this, this will go here. So let me write 1. Then this goes here, that's 2. Then 3 goes here. That's 3. Then if you can see in the binary tree, we always goes from the left to right. So if you see the left, because 6 is there on the right hand side, you will say 4 and 5 and at the end you will get 6. Now this is sorted. So after all this explanation, this is how basically you sort them. Now this logic which we have written here is actually a part of a partition method. So this is a partition method. So the entire thing goes there. But we also need to return the pivot value, right? So which is the pivot value? So we'll say return I plus 1 because that's what the pivot is. But this particular function will be called by whom? So we have a concept of quicksort here. So quicksort is going to call this partition. How? That we're going to say in the code itself. So you got the idea. Basically you divide, sort each values, and you will get the output. Now this will make much more sense once we start coding, and I hope it will get clear. So let's try to implement the quicksort logic. So what we're going to do here is we got these values here. So this is the logic for the insertion. So what I will do is I will just remove the entire part here. We got this array and we are going to perform the operation. Now, of course, you can write the entire logic here, but then remember quicksort goes for recursion. So when you say recursion, you have to create a function or a method which will get called. So what I will do is I will create a function here and let's call them. So we'll say a quicksort as a function name or the method name, which will take 3 parameters. Now, what are the 3 parameters? The first one is the array itself on which you want to perform the operation. Next is the starting point and the ending point of each section. Example, at the start, it will be the entire array. But remember when we have to break it down, so that is your each section. Okay, so we have to specify the low and then you have to specify the high. Now, in this case, what is low? So low is 0 and the high is basically the array dot length minus 1, right? That's the value you have to send. Now, basically, we don't have this function, so we can just right click here and say, okay, I want the IDE to create this method for me. Maybe just using some inbuilt methods. Okay, let's create our own. So what I will do here is I will create a method called public. I don't want to get the object, so I will say static void quicksort, and it will take these 3 values. So first it will take a int array. In fact, one of the syntax of array, you can write it on this side because it will make much more sense. You got array and then you got int low, then you got int high. So these are the variables you need. And then you can start performing the operation. So basically from the main, you're calling quicksort only once, but quicksort will be calling itself. Okay, but based on what? Now, basically I want quicksort to call itself only till when your low is less than high. We don't want it, right? So that's what it makes sense, right? Low should be low, high should be high. And if it is true, then keep calling the quicksort. So I will keep calling the quicksort, but the question is, what values I have to pass? Now think about this. If you have one big array and then you're saying that we'll be breaking this into 2 parts. So don't you think you have to call quicksort 2 times for 2 different arrays? That's right, so you have to call 2 times. But the question is, what are the values? For sure, the first variable will be array because that's what we are sending, right? We have to sort the array. The question is, what will be the low, what will be the high? Because when you divide your array into 2 parts, what should be the starting point of the second array and the ending point of the second array? That's what you have to mention. But how will you know the starting point? It is easy actually. Here, the starting is always low for the first array and the ending is always high for the second array. Okay, even that is solved. The problem is with the ending of the first array and the starting of the second array. That's what we need to find. Now, how do you find this? For this, we have to run a partition. Okay, so this is the logic which we have to refer to. So what I will do is I will just reduce the IDE size so that I can see those values. I mean, this logic. So this is what we have to implement in the partition. So basically to get this value, the pivot value, what you will do is you will say int pi equal to, and you will create a method called partition in which you will pass 3 values, the same 3 values, array, low and high. So basically in the logic I have not mentioned it, but we want this value as well. Okay, so we need to create this method. So what I will do is I will just go back here, more actions, create a method. Okay, so we got the method. Let's perform operation on this method. We can make it private because we're not going to use partition outside this class. So private works. But what should be the logic here? And we have to return something. Remember, we have to return the PI value. Okay, so we can write the same logic which we have written here. And once you get this PI, you can basically pass the PI, and we don't want to include the PI. So we can say PI minus 1. And here we have to pass PI plus 1 because every partition when you create, you don't consider the PI, right? PI stays there. You create 2 parts and then those are your 2 partitions. But we have to find this PI, that's the main task. And for that, we have to write this logic which is mentioned here. So we need some variables. The first one is temporary pivot variable. And we have to assume pivot for the first time. So the pivot here is always high. So that's the algorithm we are using, but we can pick up the starting value or randomly pick any value that works. So let's say we got pivot high, and then we also need one more variable, which is I. Remember, we have to use this I, which will return. So I is basically your low minus 1. Remember, if the array starts with 0, the I will be at -1. Next, we need a loop, so we can get the entire loop from here, or maybe you can type. So we can say for int j is equal to 0. In fact, not 0, right? It should be always low, because when you create different partitions, not every partition will start with 0, but they will start with low. So j less than equal to high and j plus plus. I'm just referring to my algorithm which I mentioned here. And then the logic we have to write is if ARR of j, if it is less than pivot, then you start doing some operation. What operation? First you increment the value of I, and then you swap. But how will you swap? We don't have a swap function. Actually, we can create one. But instead of that, what we can also do is we can write the logic. So I can say int temp is equal to ARR of I. Then ARR of I will be replaced by ARR of j. And then ARR of j will be replaced by the temp. Okay, that's the values we have to swap. And that's it. This will run and you will do the partitioning part. But once you complete the for loop, again, we have to swap the value of I plus 1 with high. So you can actually use the same logic here, or same statements. So I'm not copy pasting, I'm just reusing the code. Sounds better, right? So here we can say this will be replaced by I plus 1, and I plus 1 will be replaced by high, and this high is going to be replaced by temp. Swapping done. And at the end, we need to return I plus 1, because that's what is referring to the pivot. Okay, looks like a right logic. We just converted that into here. So by doing the partition, we are saying replace 1. In fact, once you get this algorithm, also try out the same thing which I've done on the board. Okay, then it will make much more sense. Okay, I hope this will work. What do you think? Let's run and let's see. Run, and yes, looks like sorted. 1, 2, 3, 4, 5, 6, 8. Let's change some values. Let's say this is 81, this is 62, and this is 111. Let's try with these values and let's see if they're sorted. So 2, 3, 4, 5, 62, 81, 111. So it works. So this is your quick sort. Now, why we are saying this is n log of n is because we only have one loop here, which is for loop, plus we are doing the partitions of it, right? So they can run parallelly. Yeah, so this is n log n, but in the worst case, it can go for n squared, but better than the other sorting techniques. In this video, we'll talk about divide and conquer technique. The thing is, in the upcoming algorithms which you're going to learn, we are going to use this technique. So it makes sense to talk about this technique separately. The thing is, when you talk about any algorithm, what we are trying to do is we are trying to solve a particular problem. Now, of course, when you learn a particular algorithm, we normally work with limited set of values, right? Let's say 5 values, 6 values, or maybe 10 values. But still, these are small numbers. What if you are working with huge amount of data? Now that's where one of the issue which comes, which is your time complexity, right? So basically, whatever algorithm we are learning, we are trying to understand which algorithm goes for what time complexity. So basically, when we talk about bubble sort, when we talk about selection sort, they have a different time complexity, which is much higher. And on the other hand, when you talk about quick sort, it is much more time efficient. So how exactly they work? So what they do is they basically take a big task. Now it can be for small numbers as well. You take a task, you take a problem, and you try to find a solution of it. Of course, every algorithm does that. So we have a problem and we find a solution for it. Now in divide and conquer, as the name suggests, what you do is you divide first and then you conquer and then you combine. Now what it means, let's say we have a big problem called P. Now what you will do is you will break it down into subsections. So you will say P1, P2, and list goes on. And then what you will do is you will apply the algorithm on each subsection. So on P1, P2, P3. And then what you will get is a solution for that particular subproblem. So by doing this, you're trying to solve a big problem by breaking it down into small parts. And then what you will do is you will simply solve it, each subproblem, and then you will merge, you will combine them. And that's where you will get a solution or a big solution for a big problem, right? Now, what if the subsection itself is huge? So let's say when you say P, that's a big problem. P1, P2, what if even they are huge? Now, in that case, what you will do is you will again divide them into subparts. Something like P11 and P21 Or maybe you can have P1 goes for P11, P12. So those are the sub-problems. And then you try to solve them so that it will be easier to solve. Now that's what we call divide. And of course, when you divide and conquer, don't forget to combine. And we have to also make sure that after dividing this problem, after solving them, when you combine, you get a desired result. Maybe when you solve a particular problem, the subsection, they are working. You got the output which is desired for a sub-problem. But what about when you combine it, you got some different answer? Even that will not work. So you have to make sure that when you combine the work, you will get your desired results. Now, most of the people have this confusion when you talk about divide and conquer, that we can divide the task the way we want, right? No. So basically, whatever algorithm you're going to apply on the big problem, the same algorithm should work on the each subsection. So let's take an example. Let's say if I want to paint the entire house, let's say we have 4 rooms there and I want to paint each room. So basically painting the entire house is a big problem. So what you will do is you will divide the task. Now, if you're thinking dividing tasks simply means that someone will buy the paint, someone will apply the paint, someone will clean the floors. Now, that's not the task. What we can do is, instead of painting the entire house, of course you have to paint the entire house, but you can divide the problem. You can say, okay, we have 4 houses. Let's divide the 4 rooms into 4 separate parts. Paint each room. Of course, in each room, you will buy the paint, you will apply the paint, you will clean the floor. I only remember those 3 steps. So basically, you will do it for each room. So what you have done is you have divided the big problem, solved it, and then you combine. Of course, you have to also combine those 4 rooms to get a house, right? That's what divide and conquer is. Now let's talk about tree structure. Of course, we'll be having a separate section for trees because it's a huge topic, but I just want to introduce it. Now, basically, when you talk about list or arrays, those are your linear structure because you store data one by one. Now, in the upcoming algorithm, somewhere we are going to use something like a tree structure. Now, what exactly tree is? In English term, what is tree? Basically, you have a root and then you have branches. In the same way, what we are going to have here is we'll be having a root element. So we can say, let's say we have a list of values. So these values are your root. And then what you do is you do certain things with these values and you get some new branches. Okay, so those, maybe you get some subsections or maybe you clone it. Doesn't matter. The logic doesn't matter here. Understand the structure. So what you do is you got a root element and then from that you create a branch. Maybe you can create 1 branch, 2 branch, 3 branch, 10 branch, doesn't matter. You create the branches. So from that particular branch, maybe you can create more branches. And when you do that, you get a tree structure. Of course, we have different type of tree structure. We also have something called a binary tree where the number of branches for each node or the element will be only 2. Okay, so when you have multiple branches, that's normal tree, but when you have 2 branches, that's your binary tree. So don't get surprised when we see this type of structure in the upcoming algorithms. And don't even worry if you are not understood the entire tree concept, is because we'll be having a separate section on it. So yeah, just wanted to introduce tree. So when you see a structure where you see branches and different nodes, that's your tree structure. And then we are going to use binary tree somewhere where each node, so the branches ends, that's what your node is, or you can say leaf, but that will be having only 2 branches. So that's the binary tree. In this video, let's talk about recursion. Now, when you talk about different programming language, we use methods or functions, right? Irrespective of the programming language, we do have this concept. Of course, in some languages, we do call them methods, but calling them functions is not a crime. So let's talk about functions here. Now, why do we write functions? If you want to achieve a particular task, you write a function. Maybe you want to print something. Maybe you want to add 2 numbers. Maybe you want to find a factorial. Maybe you want to process the payment. Maybe you want to search something on Google. Everything happens with the help of functions. Most of the time, we call a function from a function. Let's say we got 2 functions here. Let's call them F1 and F2. So F1 is calling F2. Yes, we can call the functions. Even F2 can call some other function. Let's say F3. F3 is calling some other function. Now let's say you're calling F2 from F1. Now what happens is F1 cannot complete its execution before you complete the execution of F2. Because if F1 is not calling anyone, F1 will complete its work and then that's done. But then what if F1 is calling F2? In that case, F1 cannot be completed till you complete F2. So F2 will complete and then you can complete F1. But what if F2 is calling F3? In that case, F2 has to wait for F3. And mind you, F1 is still waiting for F2 to complete. What if F3 is calling F4? Now, of course, everything goes into stack. So F1 is waiting for F2, F2 is waiting for F3, F3 is waiting for F4. Once you complete F4, the pointer goes back to F3. F3 says, okay, I can complete my work now. Once F3 is complete, you can complete the F2. Once F2 is complete, you can complete the F1. And if everything is done, you can stop the execution. But mind you, when F1 is calling F2, F2 is calling F3, F3 is calling F4, there is a dependency. So you have to wait for F4 to complete so that F3 can complete, so that F2 can complete, and then F1 can complete. Now here we are calling some other functions, right? What if a function is calling itself? Example, let's say we have function F1, and F1 is not calling F2. What is F1 is calling itself? F1 is calling F1 now. Now in that case, F1 is calling F1 and it can go multiple times. So we don't have a different name, but you can imagine a stack. So F1 is calling F1, F1 is calling F1, F1 is calling F1, F1 is calling F1. The last F1 need to complete first for the second last F1 to complete. The second last F1 need to complete, then only we can complete the third last F1. In fact, if you want to complete the F1, the first F1, you have to make sure that you complete the entire stack. So when you say a function is calling itself, that is called recursion. But why you will do that? Because if you don't apply a condition, it is never ending process, right? It's like F1 is calling itself, and then ultimately when your stack is full, your computer will give you an error. Most of the time they're called Stack Overflow error. And that's why you got this famous website, right? Stack Overflow. So we have to apply some condition as well. Now, where it will be useful. So let me show you that with an example. So let's say this is a very simple Java code where you got a main function, we got demo. And from this main, let me call a function. But before you call a function, you have to first define a function, right? So I will say public, static. I don't want to create functions, so I will go for static. And this function is basically calling, let's say F1. Let's call this function F1 because we are going with that now. And then here, I want to print something. So what I will say, I will print the value of I. But what is I? So what we can do is we can create a variable I here. And initially, let's say the value of I is 0. Okay. And then we are printing I here. But of course, you have to call this function. So let me call F1 here. Okay. Simple task. We're just calling a function F1. Nothing fancy. In F1, we are saying int I equal to 0. And then we are printing it. Let's run this code to see what happens. When you run this code, you will get 0. Of course, that is what we're expecting. But what happens after printing I? Let me call F1 once again. Now, what do you think? What will happen? I'm not sure if my system will crash, but let's try. The moment I run this code, okay, we got an error. So if you can go up and up and up, okay, where? Okay, so we got somewhere here. So I got a huge stack here. So you can see we got an error which says stack overflow error. So basically there's a stack and it has a limited memory, right? And that's why you can see we got all this printing of 0 because that's what they are doing. And then once they complete their work, they are coming back. So that's what is happening here. Okay, but then there should be a condition as well. So what I will do is I will simply pass this I here. And let's say the value of I is 1. And then I'm also passing I here. So you have to accept I. And what if you don't declare the variable inside? Okay, let's not declare that inside. Let's say I'm passing the value from here, or maybe I can say 10, even that makes sense. So let's say we are passing 10, which goes here. And then if I run this code now, it will not be printing 0 because we are passing a value. It is printing 10. But of course, we have to apply some condition as well. So what I can do is, before calling I, what I want to do is, I want to check if the value of I is greater than 0, then only I will call F1. So that means the value of I should decrease somewhere, but we are not decreasing it. But what if you do this? Instead of passing I when you're calling for the next time, let's pass I minus 1. Now by doing this, what we will be doing is we got all these values. Now, if you're thinking what we have done is basically when you're calling F1 for the first time, you're passing 10. The F1, the first F which got called here, it is calling F1 itself, but not with the same value 10. It is passing with the value 9. So next time it is executed, it is passing the value which is 8, then 7, then 6. Till where we are going? The moment you say I is not greater than 0, then you stop. So basically there will be a point where it goes into minus or negative values. Now that's where you have to stop. And that's why you're stopping at 0. If you change this condition, it will change of course. Example, let's say if I say it is 1, now in this case, it will stop at 1. Okay, this is what is happening. You can do the same thing with the for loop, right? So you can start the for loop by 10 with the same condition, and then you can say I minus minus. Even that works. So instead of using a loop, we are using recursion here. That means there are certain things you can do with for loop, which you can also do with recursion. Example, finding a factorial. Normally what you do is if you want to find a factorial with recursion, let's say I want to change this. I want to find the fact of 5, which is 120, if I'm not wrong, or 6 is 120, doesn't matter. So let's say I'm finding the factorial of 5. So what will be the logic of factorial? Basically, let's say it gives you a result. We'll store it in result, and then I will simply print the result. So let me print result. Now, since we are expecting a value, it should also return something. So it will return int. But what will be the actual logic here? Now, what if I'm finding a factorial of 0? So for 0 and 1, the factorial value is 1, right? So factorial of 0 is 1. So I can simply return here 1. Okay, at least we can get this code running. Let's run this code. Oh, we got an error is because we have not changed the function name. It should be fact. Let's run this, and you can see we got 1. So this is working. Let me minimize this. Okay. But what if I want to find the factorial of 1? Even for 1, it will return 1. That actually makes sense. But what if you say this is 2? Now, in this case, it should print 2, which is 2 into 1. We all know what is factorial is, right? So example, if I say factorial of 5, or 5 factorial is actually equal to 5 into 4 into 3 into 2 into 1. This is actually the logic of factorial. So it should give you 5 into 4 is 20, 20 into 3 is 60, 60 into 2 is 120. So the output I'm expecting is 120. How will I do this? So don't you think this is matching with the previous example which we have done? We are just lowering the number, right? So first, if you can find the factorial of, okay, can we do this? When someone is asking for factorial of 5, can I say 5 into 4 factorial? Because if I can get 4 factorial, and you know what is 4 factorial? 4 factorial is 4 into 3 into 2 into 1. Okay, so if I can get this, I can simply multiply it by 5 and our job is done. So here what we can do is, we can call the same function by passing the value 1 less than the actual value. So what I'm saying is, if I got the factorial of 5, I can simply return I into fact of I minus 1. Don't you think that's what we are doing here? So when I say I want 5 factorial, we are saying 5, which is I in this case, into 4 factorial, which is fact of I minus 1. But the question is, it will call itself, but till how many times it will call? And that's why we have to put a condition. So we have to reach till I is equal to 0. So if I is not equal to 0, you do this. Otherwise, it will return 1. Yeah. So by doing this, you are returning the factorial. Let's try if this works. And you can see we got 2 because that's the value is 2. Let's say I'm finding a factorial of 5, run, and you can see we got 120. When you say 6, we got 720. And if you can go for 10, there is a limit for integer as well. Okay, we got some value, but what if you go for a bigger value? This is where it will fail, I think. You can say we got negative value because integer has its own range. But you got the idea, right? What is recursion? So the idea is not about factorial here, okay? The idea is about recursion. So when a function is calling itself, that is recursion. In this video, we'll talk about merge sort. Now basically, let's talk about the theory first and then we'll focus on the implementation. Now when we talk about sorting techniques, we have worked with multiple sorting technique. And when we talked about the quick sort, which was going for a time complexity of n log n, now we have one more there which is called a merge sort, which also has a time complexity of n log n. Now, both quicksort and merge sort follows a technique called divide and conquer. So basically what you do is, you break down the problem into subproblems and apply the algorithm on those particular subproblems. And once you get the solution for each subproblem, then you combine the solutions or sub-solutions to get a final solution. That's what we are going to do here, which is divide and conquer. Okay, so how we are going to do this? Now, basically, it is actually easier to understand. So if you can be with me, it will make much more sense. So what we're going to do is we'll take an array initially. Okay, so let's say I'm taking a list of values here. So let's say we are going for 6 values here. And what are these 6 values? So let's say I have a value which is 8, 5, 9, 1, 6, 7, let's say. So we got these values here and then I want to sort them. So what you do is you will apply a merge sort. Now basically here, as I mentioned before, you will do 2 things. You will, in fact, 3 things. First, you will divide this problem into subproblems and then you will conquer them and then you will simply merge them. Now, since it is called a merge sort, the important step here is merging. So when I say important, I'm also saying it is complex part. The easier part is to break down this into small parts. Merging will be time consuming, so let's understand this. So when you have these values here, what you will do is, first of all, you will break down into 2 parts. Now the question is, how will you break it down? In different sorting algorithm, we have a different way of breaking the entire list. In fact, in quicksort, we use a pivot. But here, let's make it very simple. We use something called a median. Now, what is a median, or maybe a midpoint? So here what we can do is, as we know that if you talk about this particular array here, the mid is here, right? We can see and we can tell that. But how an algorithm will know that this is a mid? And that's why we will do some calculation. Now, what kind of calculation? It's very easy. So what we can do is, let's say this is your left and this is your right. So what we will do is we'll simply use index values. So the index values for this is 0, 1, 2, 3, 4, 5. So that depends upon the values you have. And then if you want to find a median, so basically L represents the first index value and R represents the last index value. So you have to find a median. And the formula for median is very simple. So what you will simply do is you will say median is equal to left plus right divided by 2. That's how you get the median, right? Now in this case, the median is, what is L? L is 0, R is 5, and this divided by 2 is equal to 5 by 2. Now since in different languages we get different outputs, so let's say this is 2 in this case, because in most of the languages we go for the float value. So we got 2 here. Now 2 is your median. So this is your median. So whatever is there on this side will go into a different array, and whatever is there in this side will go into a different array. So when I say array, I'm talking about the list. So what we can do is we can divide into 2 parts, and then we can create a different section. So we got a section here which has 3 values. We got a section here which get 3 values. And then the values will be 8, 5, 9 here, and 1, 6, 7 here. Okay, and again, the job is not done. Again, you have to divide into 2 parts. Now, how we are going to do that? It's very simple. The same steps which you have followed. Again, you will take L and R here, L and R here. Let's find the median of the first point here, or the first array. Now, how do you get the median? Again, you will say M is equal to L plus R divided by 2. So now we can do it quickly. So what is L in this case? So if you go with the index value is 0, 1, 2 in this case, and 3, 4, 5. Now if you talk about the first array, the L is 0, R is 2. So you will say 0 plus 2 is 2, and 2 divided by 2 is 1. So M for this is 1, so M is here. Now if you want to calculate for the next array or the next values, so again the same value. So what is L? L is 3, R is 5, so 3 plus 5 is 8, 8 divided by 2 is 4. So 4 is here, so median is here. Of course, when you look at the values, you will find the median just by looking at it. But let's talk about the algorithm, and we don't have a limited set of values. What if you have 500 values? You will not simply search for the median, right? So that's how we can get the median. Again, you will divide into 2 parts. So we can divide something like this. You will get 2 sections here for this and 2 sections for this. We can say the first section will have 2 values, which is 8 and 5. The second section will have a value which is 9. Here, the first section, since we only have one value here, 9, we got 9. But let's say here we got 1 and 6, and here we got 7. So basically that's how you divide. Again, the job is not done. So you have to go till the end. So what we're going to do, again, you will divide the first one. So can we divide the second one? The 9, we don't need to divide this part, right? Because when you get one value, you cannot divide that. So let's divide the first part here. So if you divide this, you will get again 2 values, which is 8 and 5. And again, you will divide this, you will get 2 values, which is 1 and 6. So that's how you can divide, and at the end you will get the individual values. Now still we can persist the index value because we are not physically dividing them, we are just virtually dividing it, right? So index value for this is 0, 1, 2, 3, 4, 5. The index number remains same, and if you compare with the actual list we got, the index value and the values are same, right? So till this point we have not done any sorting part, we just did the divide part. And now it's time for the conquer. Now when you say conquer, it simply means that you need to sort this value. So whatever value you got at the end, sort them. But if you observe, they are already sorted. Because each element, if you compare, if you say 8, this list is sorted. When you have only one value, it is by default sorted. Okay, so sorting is done. So conquering is done basically. The next step is to merge them, and the actual fun starts here. Now when you say merge, what it means? So basically what you do is you start with the first 2 values and then you merge them. Now merging is important. So when you say we are merging 8 and 5, of course you will get a list and you can again say 8 and 5, but no, this is not how you will merge it. So the way you will merge it is this. So you will take these two values and merge them into another block. You will get two values. But when you're merging it, you will compare these two values. So which is less here? So if 5 is less, you will put 5 here and then you will put 8 here because that's the only remaining element. Then you think about merging. So you will merge this two. Now when you're merging this two, of course you will get three values, right? So you will take three values here. And this is coming from here. So these two values and this one value. Now how will you merge? Now since we have two different lists or two different values here, or two different arrays we can say, when you want to merge, that's where the actual algorithm starts, because when you're merging two values, you can simply compare smaller or get greater. But now we have three values. In first we have two, in second we have only one. So what you do here is you basically compare these values before adding them. So what should be the first value? Now we know that the previous array is sorted, right? And then, in fact, both the values are sorted, both the arrays are sorted. When you combine them, what you can do is you can compare the first two values, only the first two values, not 8, only 5 and 9. So which is smaller? 5. So you will put 5 here. Now, since 5 is done, you can simply say, okay, I'm done with 5. Now let me focus on 8 and 9. So which is smaller? 8. And then the only thing remaining here is 9. So we'll put 9 here. Now that's done. Now let's combine this 3, which is 1, 6, and 7. Now, first you have to combine this two. So you will get another box here, which is 1 and 6. So we will compare. So it is 1 and 6 because they are sorted. So now we will combine the next part. You will get three values here. Now, when you get three values, what we are doing is we are basically combining this section and this section. Same steps. You will compare the first two values. So 1 compared with 7. So 1 will come here. This is done. Then compare 6 and 7. 6 will come here. This is done. Then 7 will come here. Okay, and then now the major work starts. We have to combine this two. Now when you're combining these two, you will get a bigger array of 6 elements. So 1, 2, 3, 4, 5, 6. So we got 6 blocks. Now what you will do is you got two arrays, and we know that those two arrays are actually sorted. When you combine them, again you will start with the first two values. So when I say first two values, let's compare 5 and 1. So what you will do is you will compare. Okay, 5 and 1, which will come here. So it is 1. So this is done. Then you compare 6 and 5 because 5 is still remaining, right? So 5 and 6, it is 5. Then 8 and 6, which is 6. So 5 done, 6 done. Then 8 and 7, so which is 7. So 7 done. Then 8 again. Now we don't have anything to compare from the next array. So you can simply take these two values as it is here. This is merge sort. Okay, so you get the sorted value, I hope. Yeah, you got the sorted value. So this is how basically the merge sort works. That's how you basically divide and you combine. But if you want to do this in programming, how will you do it? And we'll keep this as a reference. So we can divide, we can write this section here. So we can compare with this. Now, if you want to write an algorithm for this, first of all, you will get an array, of course. Now in this array, you will have some values. And we can take the same values which we have here, right? So let's say we have an array with some values here, the same values which we have. And then the next step is you basically need to create a function, let's say merge sort, and this is where you will do the sorting part. So when I say merge sort, the first thing you will do is you will say divide. Now when you say divide, you have to pass three things. First, you have to pass the array, then you have to pass the L value, R value, right? And then if you observe, we are dividing, again you're dividing, again you're dividing. So don't you think this is a concept of recursion when you do the same thing multiple times? So we have to do recursion here. So basically here, we have to pass three values, right? So you will pass an array, you will pass the left value and right value for each array. Now, as this will be called multiple times in recursion, every time you have to pass the array, the left and the right. Remember one thing, we are not dividing the array physically, we are dividing it logically. So even if you divide this array, ultimately the values will remain same. Okay, now when I say divide, what it means, the first thing you will do is you have to find the median or the mid value. So I can say mid, but then since this, okay, so let's find mid here. So we got mid is equal to, we know the formula L plus R divided by 2. Now once we got the median, what we're going to do is, once you got the median, you will break down into two parts and you will apply the merge sort in each section. So what I'm saying is, when I'm calling this for the first time, I'm passing the entire array with the L value as 0 and R value as 5, which is the last index. But again, I'm going to call the merge sort by passing different values. So I'm going to pass ARR. Next, I need to pass the first array index value. So the first array here starts from 0 to 2, which is the median. So starting is L, ending is median or middle value or mid value we can say. Again, I will call merge sort for this second array. Again, I have to pass ARR, but this time you have to pass, if you look at the values, we have to pass 3 and 5. Now, where do we have 3? We don't have 3 anywhere, so we can say mid plus 1. So mid is 2, so mid plus 1 is 3, and the ending is right. Okay, so that's how you call the merge sort. We have to remember one more thing. After doing merge sort, which will break it, we have to merge them as well. So when you say merge, you have to pass 4 things here. First, the array, the left value, the mid value, and you have to also pass the right value. Again, we'll see the logic later, but this is the merge you have to pass. But if you call the function by itself, you can see merge sort is calling itself, but don't you think there should be a limit when it should end? So of course there should be a condition as well. When your left is less than right, then only you do this, otherwise stop. Okay, this is your merge sort. So by doing this, what you will get is you will get the values divided. But where's the concept of merge? We are calling merge, but we are not defined the merge function yet. Now this is where things gets complicated. Not exactly complicated, but it's a lengthy process. So what we need to do is, when you say merge, of course you have to pass all these values here. Now in this merge, what we are going to do. Now basically the first thing is you need to create 2 arrays. So I will not write the exact logic here, but let me just draw something. What we need is, we basically need 2 arrays here. When you say merge, at one time you need 2 arrays. Example, so when we are combining these two, we got 1 array. So at one point you need 2 arrays to combine so that you will get one big array. Same goes here. When you got 2 arrays here, we need to combine them to get a big array. So that means every time I call merge, I need 2 arrays. We'll call them, let's say, left array and right array. Okay, so we got 2 arrays here. The next thing we need to do is we need to copy the elements of the left array and the right array. This is empty at this point. So we need to copy these values from the actual array. Okay. Now, so we need to write a for loop which will copy data from the array. So basically it will copy data from the array and put them in this list. Okay. So maybe I will just write copy values. Again, we'll see the actual logic in the code itself. Okay. Next thing we have to do is, once we have done with the copying part, you will simply use these 2 arrays to combine to get a bigger array. Now, how will you do this? So of course there should be partition here, there should be some values. So what we will do is let's work with the last values here. So we got the last value as 5, 8, 9 and 1, 6, 7. So the logic of combining this is, you will need multiple variables here. You need a variable I, you need a variable j. Now why we need these 2 variables? One to represent this particular array and one to represent this particular array to iterate. Then we also need a k, which will be used for the big array which you're going to create. So from these 3 values or 3 values, you're going to create an array of 6, right? So k will be handling this part. Now every time you copy one element, so let's say when you compare 5 and 1 and you know that you're going to copy 1 here, so basically the j value will shift here, right? Because this is done. The same thing goes here. So once you got 1, next time you will get 5 here. Then you have to increment this here. So I goes here. And of course, every time you copy element in the bigger array, you will increment the value of k. That's the logic. Okay. So this is how you are going to complete the merge sort. Now, how exactly you have to write the code, that we'll see in the practical video. So I hope merge sort makes sense, where you basically break down the entire array into small chunks and then you combine them to get the sorted values. So now let's implement this logic with the help of Java. Now, the thing is, first we need an array, right? So let's create an array here. So I will say int ARR, and this will have certain values. So let's have some values here. We'll say 3, 5, 1, 4, 6, 2. So we got these values here. And let's apply the sorting techniques on this. So before sorting, I will print some values. I'll say for in n in array, and let's print these values. So I will say print n, but I will also make sure that I will put a space. I will not print on new line. And once it is done, I'll print a new line. And then after sorting also, so I will say this, I will just write it here. After sorting. So here let's do the same thing. And let's say after sorting, it should print some value. But at this point, if you run this code, let's run this, and you can see in the output, they both are unsorted. So because that's why we have to do some sorting here, right? So let's apply the sorting logic. So what I will do is I will simply call a merge sort method, which will basically accept three values, the ARR, the L, now L here is 0, and then you have to also pass the array.length minus 1. Basically, you have to pass the R value as well. Remember, we have to pass three variables. Now, since we don't have this method, I will simply say more action, create this method, and you can see we got this method here. And let me just put this method not here, but on top. Now, this is where the actual logic is going to happen. So you can see we got two variables. This should be L and this should be R. So left and right. Okay. Now, as per the logic, if you can see in our logic, we have already mentioned this logic. So basically what we have to do is we have to first check if the L value is less than R, then only you do certain things. And what are the things you have to do? Basically, you have to find the middle value. So I will say int mid is equal to L plus R divided by 2. And then you have to call merge sort 2 times. Again, I'm just going with the logic which I've written in the code or in the board here. So you have to pass ARR, and then you have to pass the L, and then you have to pass mid. That's how you create two different arrays. So mid plus 1 and R. Okay, and then you will simply say merge. Of course, right after doing this sorting, after breaking it down, you have to also merge. But while doing merge, you have to pass three values. ARR, you have to pass the left, mid, and right. You have to pass these three values. So this is the only logic you have to write inside merge sort method. But then we have to also complete merging because dividing is very easy. This is how basically you are dividing the values. The difficult part is merging them. So let's implement merge here. So I will just go back here, more actions, create a method merge. Yes, so I got a method. At this point, there are private methods is because I'm going to call from the same class, but depending upon your requirement, you can just change them. And now the actual logic goes here, the merge. Okay, now as I mentioned, you need to create two arrays here, right? So if you can see the logic, we need two arrays. Let's name this as LRR, which is the left array. And this will be an array. But the question is, what will be size of it? Because when I create this array, I have to mention the size. I don't know what is the size here. Now, based on when it is getting called, it will be different size. But the question is how we are going to know the size. And that's where this L, M, all this thing comes, or L, R comes into picture. So let's use that and let's get the size. So if you want the size of the first array, the first section, basically you can simply say mid minus L, because for the first array, it starts with L. If you can see here, it starts with L and ends with mid. So if you say mid minus L, you will get the length, right? But the problem is, since this is zero indexing, we have to also add plus 1 because mid is not representing the size of the array. It represents the index value. So you have to say plus 1. Then you will get the second array length with the help of R minus mid. So we'll just put some space here so that it will be much more visible. Okay, so you can see we got these two values and this is the size you have to mention here. The first array will be of size n1, the second array will be of size n2. That's done. The next step is actually to copy the values. If you can see, we are mentioning the copy values here, right, in the notes. Now, how do you copy value? We can use a for loop, and let's use two different variables. I will say x and y this time. X is equal to 0, and depending on the size of the array. So for the first array, the size is n1 and x plus plus. Not used to using x and y inside a for loop, but let's try. So how do you copy? So ARR, this values, which is x. Now, how will you get the values? So from ARR, from the main array, we have to start from the left. So you have to say left plus x. That's how you get the values. So whatever value of the L is. Example, if you look at here, for the first array, the index is 0, 1, 2. But let's say if you are merging the second array, this one, the index value is 3, 4, 5, right? So whatever value of L is, which is the left, which is 3 in this case, it is 3 plus x. That's how you will copy. And none. So this is for the first one. Let's do the same thing, but a different values. So I will just copy this for the second array. Okay, we can also use x here, no problem. We can say n2, and this will go into the right array. But the question is, what will be the value here? Now, any guess? So when you say on the right hand side, it is your mid plus 1, because we are not considering the mid value for the next array. Example, if you go up, the mid here was 2, but we started with 3. So you have to say 2 plus 1, mid plus 1, so that you will get 3. Okay, so we copied was the next step. And now the actual work starts of merging. And already mentioned we need two variables. One is I equal to 0. We also need j for the second array. So first array will be counted with I, and second array will be handled by j. But we also need one more counter which will represent the main array, right? And this value will start with L, because we have to start from the left hand side. Now once we get these three values, let's start merging them. So we have to do multiple times, right? When you say merge, you have to take value from here. Example, when we were doing this, we would compare the first two values, compare the next two values. That's how we were doing, right? So when to end this? If your I value is less than n1 and not this and j value is less than n2, we'll continue till this point. If they are not true, then we'll have to stop, because that means we have actually reached the end. But now question arises, how will you merge? And that's where you have to start comparing values. Now when you say compare, what it means? Compare 5 and 1. So basically the first element of this array and the first element of this array, let's compare them. How will you do that? So we'll simply check if the L array of I, because that's what is representing the L array, which is the I variable. If it is less than, and we can also say equal to, what if they're equal? Then we have to compare this with the R array of j. If the left one is smaller, in this case the R one is smaller, not the left one, but let's say if the left one is smaller, in that case you will put that into the main array. So array k is equal to L array, not length, L array of I. Now since we have used, so let's say this was a smaller value, and once we have used this, we have to cancel this, right? I mean, this is done. So we can shift our pointer to the next element. How do you shift your, not the pointer, but the reference? You will simply say I plus plus here in this case. But what if it is not same, or what if it is not true? In that case, you will go to else part. You will do the same thing, but not with the left array. This time you will do with the right array, and then the j variable, and you will say j plus plus. And every time you run this loop, because see, after one iteration of this loop, basically you will get the first value of the array, right? Main array, you will simply say k plus plus, because you have to also increment this. So once I is done, because k is here, once I is done, you have to move k here. Okay, and that's why we're doing k plus plus. And that's it. This is your merge sort. Let's see if that works. Let's refresh this, or this rerun, and we got an error. Something went wrong. You can see everything was going well, but this 4 is not at the right place. We got 1 there. Because sometimes what may happen is, when you're copying two arrays, what if the values are left in one of the array? Example, if you look at our example, when we were copying this, remember when we were completing the entire task, these two elements were remaining from the first array, which goes at the end. So that thing is not covered yet. So what you do is, for the remaining elements of the particular array, you will again run a while loop here. So you will say, if I is still not equal or still not less than n1, you will simply copy the remaining elements, whatever is left. Because after this loop, at least one array will be ended, okay? So we have to work for the second, the remaining element of one of the array, maybe left hand side or right hand side. First, we'll try to understand left hand side. Let's see what happens on the left hand side. Simply copy all the values. So you will say ARR of k is equal to, we have to copy from the left array, and let's use I here. Now every time you do this, you will increment both the elements, I and k both. So this is for the left hand side left out values. The same thing should be done for the right hand side. So this time I will say j is less than n2. In that case you will copy, but not from the left hand side, you will do it from the right hand side. The variable is j, and the increment you will do for j plus plus. Okay, and let's run this. And you can see now it is sorted. And now it doesn't matter what values you have. Let's take the values which we have written on the board, which was 8, what was the value? 8, 5, 9, 1, 6, 7. And if you run this, you can see we got sorted values. Let's add some more values here just to remove the confusion with different values. Let's say 111. This is 57. And now let's see 6, 7, 8, 9, 57, 75, 111. So this is your merge sort. So the steps, basically you have to first do the breakdown of, you have to break the array down into small chunks, and then you have to also merge them. The only thing you have to remember is, when we were drawing this, we were going in two sections, right? Something like this. We were saying, okay, we will create two different sections, and then first section will break into two parts and second section will break into two parts. No, that's not how it is working. If you observe, what it will do is, It will break down the entire section into two parts, yes, but then first only you will get the first part. Then you're not going to the second part, okay? You're not looking at here. This is not there yet. You're still into the first part. Then this will divide into a section. You will get this 8.5. Then you're dividing into two sections, which you will get 8.5. And then you will merge them. Then you will start breaking down the second part, which is 9. Okay, 9 was still not there. Then once this is also merged, once you get this, it will start working on the next part. Then it will work on this. It will work on this, merge, and merge. Break down, then you get 7, then you merge this two, and then once you have merged, then it will go for the next two. So it's not exactly breaking down the entire section equally. It's basically going from left to right. So yeah, that's how things are working out, and this is your merge sort with the help of Java code, and I hope this makes sense. Let me know in the comment section. In this video, we'll talk about linked list. But then why do we need to go for another data structure? Now, till this point, we have talked about arrays, right? So whatever examples we did with the array concept. Now, array is great. So basically, what is array, just to reiterate? If you have a sequence of values which you want to store together, we can basically use an array. So this here is an array. So basically, array will have different values. And then every value here will have an index number as well. So basically this is index 0, index 1, index 2, index 3. And inside this you can have any value. Let's say if the value is 5, 8, 1, 6. So these are the values you have there, right? Now, if you want to search or if you want to get any element from this, it is very easy, right? Example, if you want a third value, you can simply say, okay, I have an array and I want the third value. That means you have to use the index value 2. So basically getting an element from an array is very easy. You just have to specify the index number and you will get the value. And if you want to understand the time complexity for this will be big O of 1 is because you simply specify an index number, you will get the value. It is so fast. But there's some problems as well. The problem with arrays, the size of the array is fixed. That's the basic property of an array. Now, once you create the array of 4 elements, you can maximum have 4 elements. You can't go beyond it. So let's say if I want to add one more value here, it is not possible. It's because the size is fixed. The solution could be, there are two solutions here actually. One, what if you can create another big array, something like this, and store all the 4 variables here. So you have to basically copy all the variables and then you have to copy all the values and then you can add the extra value. Let's say you want to add 7. So basically you'll be having 5, 8, 1 and 6, and then you can have 7. So what we did is create a new array, copy all the elements and then add a new value. What if you want to add more values? The same process goes on. One more thing you can do is when you created the new array, let's not have a size of 5. Maybe the new array which you create will be of size 8 so that you can accommodate 4 more values. But again, the problem is if you go beyond it, again, you have to create a new array. Again, you have to copy the elements and then save it. I know what you're thinking. You might be thinking, okay, what if you can create an array, a big array of size 1000? Okay, two problems. The first one is, what if you don't have that much of amount of values to store? Maybe you just have 5 to 6 values or 10 values, and the size of the array is 1000. Basically, you are wasting the memory. That's one issue. The second issue is, what if the value goes beyond 1000? Again, you have to create a new array. So array is good in terms of searching, in terms of, fetching the value, but it's not good in terms of if you want to insert the value and if you want to expand it. Also, there's one more problem which I want to point out is, let's say if I want to insert a value in between. Of course, adding the value at the end is very easy. Let's do that with this particular second array here. So let's work with this. What if you want to insert a value somewhere here? So I want to say 5, 8, and maybe I want to insert 2 in between. Now, when I insert a value 2 in between, what we have to do is we have to move all this value on the right hand side. Again, a complex process. And also it will take a lot of time. So basically doing anything, updating with the array is a headache. Yes, if you add the value at the end, not a problem. But if you want to add a value at the start or in between, it creates issue. And that's where we can look at something called a linked list. Now, what we do in linked list is we don't store the value in sequence. It has a different data structure altogether. So you don't store the values in sequence. So how do we do it? So what I will do is I will just use another page here to talk about it. So when you talk about a concept like linked list, in this what you do is you do a very simple thing. If you want to store values, let's say I want to store 5, 813. Let's say I have these values here. I want to store this values somewhere. One way you can use array, but we have talked about the problem with it. So what we can do is we can store the values in something called node. So when you talk about linked list, we have certain terms which you have to remember. The terms are node, the terms are reference, or you can also say address. In some of the languages we call them as address. Let's start with this two. So basically what you do is you create the value. So you store the values in a node. So this is how the node looks like. Okay, this will be a node, and in this node you will store the value 5. You will take another node, and in this you will store 8. You will take another node where you will store 1. You will take another node where you will store 3. So basically what we are doing is we are storing all the values in the node. So these are nodes. But the problem is, how will you maintain the sequence? Because these are stored somewhere. They are not a sequenced memory. Because in array what you do is you use index values, right? So example, if I name this array as n, basically the address of n represents the first value, which is 5 in this case. Now, if you want the next value, what you can do is you will take the address of n, let's say 101. If you want the first value, you can say, okay, I want something which is at the address 101. But if you want the next value, you can say, okay, the next value will be at the address 101 plus 1. The next value will be available at 101 plus 2. And that's why we have this index value, something like this. But in linked list, we don't have that scenario. Of course, these nodes will be having some address to it. Let's say the address for this is 105, the address for this is 206, and the address for this is 512. This address for this is 68. Now, all these are addresses, okay? Nothing fancy, just simple addresses. Now, if I want to fetch a value, let's say 5, then of course I should know the address of 5, which is 105. If you know it, that's great, you will get the value. If you want the second value for linked list, now we have no idea what is the second value. But if you know the address, you can find it. But if you say, hey, I got a linked list, I want the second value. Where is the second value? So what you have to do is, if you want to chain them, if you want to specify the sequence, in a node, basically you can have two things. The first thing you will have is data. And the second thing you will have is reference, or maybe you can say address. So here, a node will have one more section. Every node will have one extra section here. Let me draw it here. And then what you will be having in this section, it's very simple. In this section, basically you will have the address or the reference of the next node. So for the first node, when you talk about this node should have the reference of this particular node. Now, how will you do it? It's very simple. The second box in the node will have the address, which is 206. Okay. Now, by doing this, what you're doing is you are creating a logical linking between these two. Then what about this next element? So we are saying that this 1 here is the third element. So of course, what you will do is you will say 512 here. By doing this, you are creating a link here. Again, what about the next value? So of course, it should be 68 so that you can create a link here. And what about the last value? Nothing. We don't have any elements after that. So you will simply say null because we don't have anything after it. Now this is your linked list. Okay. Now why it is called a linked list? Because we have a list of values and they are linked. They are linked with the address or the reference. Okay. So the first section here is called the data, or you can say the info. The second section here is basically called the reference. And same goes for the each node which you have. Okay. That's how you can basically add the values. Now you'll be saying, okay, what if I want to insert a value in between? Or maybe let's add the value at the end first. What if you want to insert a new value? Very simple. What you will do is, the moment you say you want to insert a new value, every time you want to say insert new value, you have to create a node. A node will have two things as we know now. The first thing, it will have the data. Let's say the new value you want to insert is maybe 3. 3 is already there. Let's say 6. You want to insert 6, create a new node. And in this node, you will assign the value which is 6. And by default, the reference will be null. Okay. But then we want to make sure that this element is the last element in your list. In that case, you have to make some changes. Now, what are the changes? Basically, we have to create a link between these two. How will you create the link? The way you do that is by changing this value of null. So you will simply remove this null from here and change the value to the address. Now we don't have the address yet. So let's say the address for this is 126. So basically you will insert 126 here. And that's how you can create a list and you can append the values. So the first value is this. So this is your first value, second value, third value, fourth value, and fifth value. Now, how do we know the sequence? It's because you start from the first element and then you would jump to the next element, the next. So basically you go from here to here, third element, fourth element, and fifth element. It's that simple. But again, the question is, how do you know that this is a first element? So basically we need to have one more concept here, which is called the head. Okay, so every linked list will have a head as well. So head is just a reference which is pointing to the first location. Okay, so you'll be having an extra variable which will point to the first location. It's that simple. Okay, now what if you want to insert more nodes, but not at the end this time? Maybe you want to insert in between. What you do in array is you basically shift all the values. Time consuming process, right? So here, what you do is, again, when I say you want to insert a new value in between, or maybe let's say in between later, you want to insert a new value. You want to have a new node. So what you basically do is you create a new node. So maybe I want to insert the value in between these two. Okay, so after 8, I want to have another value. Or maybe I will just write the value here. So let me just shift all these values on this side. And the value I want to insert here in between is, let's say, 2. Okay, so I want to insert 2 in between. So between 8 and 1, so the steps are very simple. You create a new node. That's what we always do, create new node, and assign the value which is 2, but we have no idea what should be the reference. So by default, the reference will be null, as always. But now we are saying that we got a new node, and this should be coming between 8 and 1. So what you do is you make some changes. The changes which you will make is this. First, you will remove this part because this should be now referring not to one value, it should refer to this particular location. And for that, you have to change this address from whatever value initially it was, maybe 512. You have to change this to a new location. So new address for this, it should be having some address, let's say 136. So now this is a new address. So you will insert this address here. Okay, now by doing this, what we have also done is now this particular arrow is not pointing here. So this needs to be removed. So there's no more arrow here. The arrow will be pointing to this location. And then we have to also make sure that this 2, next location is this 1. So again, you will make some changes. You have to make this particular link. And to do that, the same step which you have to follow, change this address from this value to 512. By doing this, we have added a new value or new node in between the list. Okay, so we have added new value which is 2. It's that simple. This is how basically linked list works. Now, can we remove a value? So I want to remove this 1. Now, how do we remove 1? So you think about this, pause the video, think about this, and then we can continue. Okay, so I hope you have paused, you have thought about this for some time. Now let's understand. Now, when I say you want to remove this 1, it's very simple. The only change you have to make is this address. Okay, if you can change that, your job is done, right? So you can simply change this address from 512 to 68. By doing this, what we are doing is we are referring this here. So basically we'll be referring this here. So that is referred. What happens to this one? This will get garbage collected if you are using a garbage collected values, because there's nothing which is referring it, right? So now we are referring this. That means we have to remove this arrow and this arrow. This will be deleted. There will be a link here, but it doesn't make sense, right? It will not be used. So if you want, you can delete this reference also. And in fact, this will be garbage collected. So this values is gone. Now, if you see the list, we only have 1, 2, 3, 4, 5 values. So this is how basically linked list works. So now this type of linked list is called the singly linked list. Reason being, you can only go one way. So if you know the first value, which is this, so by using this, you can go to the next value, you can go to the next value, you can go to the next value and next value. But the question is, can you come back? Let's say we are here. It is easier to go forward because you know the next value. But can you go back? Can you traverse in the reverse direction? No, you can't do that. And that's why if you want to achieve it, we have to use something called a doubly linked list. Now what it means is doubly linked list will not just have one address, it will have 2 addresses. So every node will have 2 addresses. So something like this. So this will have one more address here. This will have one more address. This will have one more address. This will have one more address and one more address. Now in this new address or reference, what you will have is Let me just remove this particular arrow from here. So what you will have in the first one is null because you don't have anything before this. So before 5, you don't have anything. In the 8, in this particular value, you will have 206. By doing this, what we are doing is we are specifying that the previous value for this 8 is 5. So that is in 206. Now what you will mention here is 105 is because the previous value for this 8 is 5, which is the address is 105. Now what will happen here? This will have 206, the previous address. What will have this? It will have 136, the previous address. Now, it doesn't matter where you are. Okay, we have to make changes here as well, which is 68. Now, it doesn't matter where you are. You can actually trace back. So if you want to go forward, you will use this particular address for going forward. If you want to come back, you have to use this particular address. Okay, and that's how basically you use linked list, which you have singular linked list, double linked list, and that's how you traverse. What if you want to print values? It's very simple. You traverse between the elements and print the values. Now let's try to implement linked list using Java. So what we will do is, first of all, let's open the IDE, and you can see we have an IDE here. And then here, let me create a file, and we'll name this file as, let's say, main.java. This is where we'll write our Java code. I mean the main code. So let's have a main method here. Now the thing is, when you talk about linked list, of course, we'll try to implement linked list by ourselves, but then in Java, we have an inbuilt class called linked list. So if I say linked list of Java, which is inbuilt, so let me just use this class. You can see this class belongs to a package called util. And if I jump to this class, there are a lot of methods inside this already present. So if you can see, we got link first, which will give you the first element. Then we got link before, link last. There are different methods available. But if I want to explore it, let me create object of linked list first. And I will say the linked list is nums. So let's say we are going creating a list of numbers here. And then, of course, it is giving you a warning because when you use collection, basically it belongs to a package called collections or a concept of collection. And when you work with collection, we have to also specify the type of elements we are working with. But at this point, let's keep it very simple. Let's say numbers. If you want to remove this warning, and if you know collection API on generics, we can specify integer. You can see the warning is gone. But just to simplify stuff, let's not do that. Ignore this error or warning till this point. Now, if I want to use this nums, I can add some values here. So let's say if I want to insert a value, I can insert value which is 5. So that's my first value. Add one more element, let's say 9. And all this actually, we are creating the elements, and then every element will have the reference as well. So basically when you create 5, it will have a reference of 9 as well. Okay, can we print all the values here? So if I say nums dot, I think it should print, nums should print all the values, run, and you can see we got 5 and 9. And the sequence also, you can see they are in sequence. Basically, they are following the concept which we have done here. So there's an element and there is also a reference. So every element will have a data and the reference as well for the next element. Okay, do we have some other methods here? Can I add AddFirst? You can see we have a method for that, which is AddFirst. And we can have an element which is 9. So now, or not 9, 9 is already there. Let's just 6. So now what will happen is it will add 5 and 9, and then we are adding 6 later. But then the method which we are using is AddFirst, which means this 6 will go at the start. Read on this, and you can see we got 6, 5, 9. Other methods will say nums dot. What else we can use? We can also get an element with the help of index value. Now, when I say index 2, it should return 9. So in fact, I need to print this first. So printing it here and run. And you can see it is printing 9. So that's the element at the last, and it's an index value 2. Now, the funny part is linked list data structure, which is an abstract data structure, does not work with index values. Now, so even if you mention 2 here, what is happening is it is basically tracking between the elements. And this can be time consuming, okay? So when you talk about ArrayList or array, they are fastest because they follow index numbers. Here we don't have index value. Basically, we are jumping between the elements. So it goes to head first, head is pointing to 5. Then it goes, head is pointing to 6 because that's the first element. And then 5, then 9, it finds 9 and it was printing 9. Do we have a way to print the header? So basically we have a method called peek first, which should give you the head. But when you say peek will give you the head element. Okay, so we can also use this. to get the head element. Okay, so this is how the inbuilt linked list works. But then we don't want to use inbuilt. We want to do this by using our own code. And I don't want to use this name, which is add. Of course, we can actually use add and AddFirst, or maybe let's use this. So what I will do is I will remove this package from here. The moment you remove this package, now we have no idea where this linked list is. So for our Java code, this linked list does not exist. So let's create one. Of course, you can use the inbuilt one, but let's create our own linked list. So I will click on more action and I will create a class called linked list. I want this to be in the same package. So you can see linked list class is created now. And if you try to see the code side by side, so this is how the code looks like side by side. Or maybe I will also put this in the bottom. So to move this to left bottom. So now you can see it is in the bottom. So we can actually have the view of two screens here, two code. So basically what we're doing is we are calling linked list, right? So class is created and you can see there is no error on this line now. But there is an error on this line. So what we need is, we basically need a method which will add. So I will say public void add, which will take a number. So I will say integer I. And we are only working with numbers, so let's stick to it. And you can see there's no problem now. So these two lines are clear. But the question is, how will you add? Now, if you remember, every time you add an element, basically we have to create a node. Or you can say element, but let's be specific, node. And we don't have a node yet. So what I will do is I will create a node. So I will say class node, that's the class I want, which will represent two things. So every node, as I mentioned before, so this was the example for W linked list. Let's create one more again. So basically every time you create a node will have two things. So this is your node. Node will have two things, the value and the address. Let's say the address for the next one is 216, but at this point we don't know the address. So initially it will be null here. So this is your data and this is your reference, or we can say address here. So how do we do that in Java? So of course, if you want to store data, we can directly say data. But what about the reference? How will you get the reference? Now in Java, if you want to refer something, we basically create a reference of it. Now reference of what? The reference of the next node. So whatever next node you are going to create, of course, this is also a node, right? So type of this particular element here is node. So when you say you're getting a reference, you have to get a reference of node and we'll say next. Just name for it. So what we are doing is, instead of using a name reference, we are going to say this as next. Okay. So we got data and we got next. Okay. So those are two things. And maybe just to simplify this more, every time I create a node, maybe I want to assign data as well. So maybe we can do that with the help of constructor, or maybe not. Let's try that next time or after some time. Now let's add a value. How will you add the value? Now what exactly adding value means? And first of all, let me just change this to data itself. It makes much more sense to use data as a variable name. Now, what I will do is I will create a new node. Basically, every time you say you want to add an element, we have to create new node, right? Example, if I say I want to add 8, I have to create a new node basically, right? So let's create a node here and I will call this as new node equal to new node. Okay, so we're getting a new node here and I want to assign a value to it. So of course you can say new node dot data is equal to data. So whatever data you're receiving from here is getting assigned to this new node data. So data is there, but what about the next element? So by default, the next element will be null. So instead of specifying that two things here, we can do one more thing, So we can create a constructor here for this node, and this constructor will take the data as the parameter. And then we can say this, and I hope you know the concept of this now at this point. So this dot data is equal to data, and next is equal to null by default. So every time I create a node, the next will be null. So by doing this, the advantage you will get is you can directly pass your data here, so you don't have to write one more line. Okay, so if you're thinking this is done, yes, we got a new node. So let's say, let's keep this empty. So let me just clear the entire stuff from here. Let's say the entire linked list is empty. Now, when you say linked list, of course, there should be a variable called header, right? So every time you create a node, and if this node is your first element, then you have to make sure that your head is pointing to that element, okay? Also, what if this is not your first element? In that case, you have to make sure that this new node gets added at the end. Okay, so when you're saying nums.add5, basically it is creating a new node. But we're not pointing it to head. How do we refer that head? It's very simple. You come back here. And don't you think the head itself is a node? So you will say node head is equal to, node head, which will be by default equal to null because it's not pointing to anything. And now what you can do is, now when you are adding 5, of course it will create a new node for you, which will have two things. It will be having a value which is 5. That's what you're adding here. And then the by default value for reference is null. But you have to also make sure that your head is referring to this particular node. We're not doing that yet. Head is still referring to null. Now, if you want to make sure that your head refers there, what we can do is we can say head is equal to new node. Okay, our job is done. Now your head is actually referring to new node. But what if, here if you say line number 9, what we are doing, we are adding a new element which is 9. So that means we are creating a new node here, which will be 9. And by default, the value for reference is null, which is next is null. But you have to also make sure that when you add 9, so 5 should refer here. But looking at our code, even if you add 9, even we are making 9 as a header. Don't you think that is wrong? 9 is not head, right? So that means we need to do this only when your head is null. If your head is null, then only you will write this line of code. Otherwise, what if your head is not null? That means you have to make sure that your next element, which is 9 in this case, is the next part of 5, is the next element of 5. But how do you know which is the last element? So in this case, 5 is the last element. But we have no idea 5 is the last element. How do we know in the code? So what we can do here is, we have to basically track. We have to basically track from the first element till the last element. And when you say you want to track, basically we need one more variable here, which we call as current. It is referring to something, that's what we are saying. By default is null, or maybe by default we can say this is head. But if the head is null, okay, so we can say by default is head. So what we can do is we can traverse. And the way you traverse is with the help of while loop. So we can say while current.next is not equal to null. So what we are doing is, if current is referring to head by default, so current is here initially, and we want to know which is the last element. So null. So in this case, 5 is the last element, right? So that's what we are checking. If the current next, which is here, is not null. So basically, just to change the value for 5, the reference for 5, what you can do is you can say current.next is equal to new node. The moment you do that, what we are doing is, the new node here is this 9, right? 9 has the address, let's say 121, and 5 has the address, let's say 101. So what we are doing is, we are replacing the value of null here with 121. That's what we are doing in else block here, okay? So current.next, next is this particular value, or this particular box, and we are replacing that with 121. But then what if you are adding one more element here? In the code, are we doing that? No. So let me add one more element, not add first. Let's say add 6. So now this is 6. By default, the value here will be null. And let's say the address is 212. Now we have to make sure that the 212 address is specified here. Now how will you do this? How will you create this link? So basically, the code which we have written, by doing this code, every time you create a new node, basically it will change the address of the first node. We don't want to change that, because in the else block, that's what we are doing. We are not traversing to the last element. Now, how do you traverse to the last element? So to traverse, you will simply say, if current.next is not equal to null, you will simply change your current value. Now, how do you change the current value? So you will say current.next. By doing this, what we are doing is, initially current will be here, right? And then we are saying this current is referring to the head next. That means it is referring here. So this is what we are doing here. So current equal to current.next. So it will refer to the next element. Okay. And then again, if this is not null, it will go for the next one. So that's how we are traversing. And by doing this, basically we have done with the adding part. Let's see if this works. Let me just rerun this. Okay, so we will get the error because we have not done get and peek. At this point, let's comment it and run this once again. And you can see it is printing the address of linked list. Okay, so the thing is, linked list is our own class. So instead of saying nums, printing nums, what we should do is we say nums.print values. So basically it should call print values. But how will you print? So what we need is we need a method which will print the values. Okay, so it should print all the values of this list. Now, how do you print the values? Now, that's a tricky point. Now, when you say print, it's actually easy. What you have to do is you have to start from the first element, print the value, then move to the next element, print the value, move to the next element and print the value. That means you need a counter. Okay, not counter is because this is not an array. You basically need a reference of node, and let's say again current, because at one point you're referring to only one node, right? So let's say current, and current will start from head. And the only thing you have to do is, since we are jumping between the elements multiple times, we'll use a while loop, and we just have to verify if current is not equal to null, then only of course you have to print. What if the linked list is empty? In that case, the head will be null. So we'll say while current is not equal to null, you will simply print current.data. And then you have to move your current. So basically, once you print data of the first element, which is this, then you will say next. And we know how to do next now. So you have to say current is equal to current dot next. And that's it. It will print all the values. The only thing is it will print on new line. I want to print on the same line. So I will give a space here. And once the while loop is over, I'll print a new line. And let's run this. And you can see we got 5, 9, 6, and we got all the values in sequence. So yeah, this is how basically we use linked list to add the values. But we have more things to do, right? What if you want to add the value at the start? What if you want to delete a value from between? Now that we'll see in the upcoming video. So till this point, we were able to add the elements in the linked list, right? So basically what we did is we have added 3 values. If you can see here, we got 5, 9, 6. Those are the values we have added. Let's not work with this too. Okay, so you can see we have added these 3 values, and then when you run this code, this is the output which we were getting, right? So we got 5, 9, 6, and it's working. Now basically we have to do in fact 2 more operations. One is to add the element at the start, and then the second one is basically to delete an element. So whatever we have done in the practical is basically we have created 3 nodes. So when the first node was created, so this was basically your first node, which has 2 sections, the data. Of course, the data is 5 here. And of course, there is some value here, some reference, which will be by default null, but we'll change this later. And this will also have the address. Let's say this is 121. And then we got another element here. So this is another element in a box, and let's say the values we have is 9, and this will be null by default. And then we have one more element here. Let's say, let me just draw that here. And then the value we got is 6, and it will be null. And everything will be having an address. Let's say this is 301, this is 101. But what we are doing is, since they are in a link, and with the help of this code, which is add, we have also made sure that every time you add the element, you basically get the address of the new element and add it in the previous one, right? So basically, the value which was null here will be replaced by the new value, which is 301, which is referring this. And then this will refer here. The way it will do that is by removing this null, and this will have 101. This is what we have done, right? The last element will be null because we don't have any element after that. Now, we also have one more variable, which is your head. And head is basically pointing to the first element, right? That's what we have done when we created this linked list. So every time you add the value, it will check if the head is null, it will assign the new node there. But for other elements, it will simply add the element by tracing where is the last element. Now what I want to do is I want to also have a function here. Let's say if I say nums.add, I want to say add first, so that it will add at the start. So that the element I want to add here is, let's say 7. So I want the 7 to be the first element here. Now, how do we do that? First of all, we don't have this method. So what I can do is I can just click here. Now, based on which ID you use, you will get this option. So create a method, and that's the method we have. So this is responsible to add the element. And let's say this is not I, this is data. Now, how do you add the element at the first? Now, this is tricky. So when I say I want to add the element at the first thing you do is you need a node. So we have to get a node, and this node will have 2 things. The data which we are adding is 7. So that's pretty clear. But what about the address, which will be, or reference, which will be null, which is the next value basically. And then of course, this will also have some address. Let's say this is 206. That's the address we have. Now, when you say this is your first element, don't you think the only thing you have to do is first create the node and just shift your head here. So instead of having your head here, let's shift it. So the way you do that is first to create a node. So I will say new node. In fact, you can just reuse the code, right? So whenever you add the element, this is something you will be doing for sure. So not cut, I don't want to cut that. So let's reuse the code. So copy paste. Now that's done. So we have created the new node. The next thing you have to do is you have to change your head. I mean, not your head, the head from the linked list. Now there's one problem. If you directly change your head here, we also want to know that if this is the first element, then if you move your head here, this element should be the second element, right? So we have to make this a second element. That also means that this should know the first element. So basically we are moving our head here and then we have to refer this. Okay, so how do we do this? So one thing you can do here is, so this new node dot next will be referring to the first element. But how do we know the first element? The first element is actually referring to the head as well, right? So if you want to create this link here, basically we have to get this address, which is 102, and that's what we are doing here. So we are saying new node dot next is equal to head. That's where head was pointing. And now once you got it, you just have to shift your head. So you have to say head is equal to new node, and that's it. We are just shifting the things here. So head is referring here, and this is referring to this the first element, which was previous element. And now we got a new element, which is at the start. Let's see if this works, and I will just run this code. We should see 7 at the start, and you can see we got 7 at the start. So adding the element at the start is done. What's next? Maybe I want to delete an element. So here, let's say I want to delete nums.delete. I want to delete, let's say 9. Okay, this is the element I want to delete. How do we delete 9? So basically we need a method, first of all, which will do this. So I will say create delete method. And in this, I want to delete a particular data. Now first of all, we don't have any idea that where is the element, because this element can be anywhere. So basically we have to travel to that particular node, right? And we have to start from head. So basically we'll start searching for head. So we'll go here. Is it 9? No. Is it 9? No. Is it 9? Yes. So once we get 9, we'll delete it. Now, when you say you want to delete, the only thing you have to do is, okay, first of all, let's go to that 9, okay? So the way you can go to the 9, first you have to take a reference, let's say current, and current will start with head. So that's how you're starting now, from head. So how do we basically travel between the nodes? So we can use a while loop because we want to travel, and we can simply say current.next. We have to verify, is the next element empty? Because of course you have to stop, right? We have to stop somewhere. So the moment you get null, we'll stop it. Otherwise we'll continue. And also we have to check one more condition, that the data which you are searching for is not there. Because once you get the data, you will stop. But when I have to stop? So basically the moment I go here, then, so initially we are at the head. So we'll check is this element we are searching for? If no, then we'll shift here and we'll check for this data. When we reach here, we'll check for this data. That means when you are here, then you are checking the data which is 9. But when you are here, how will you check the data of the next node? So we can say current.next.data, right? So currently we are at 5, and then we are checking for the next element data. So the way you can do that is by saying current.next.data should not be equal to data which you're searching for. Because if it is equal, then you have to stop. That's where you're stopping. But if it is not there, then you have to keep going. The way you keep going is by saying current is equal to current.next. So what we are doing in this step is basically we are shifting. So if you are here, then we are shifting here. How do we are shifting here? So we have to say current is equal to current.next, which is this element. Oh, I forgot to change this data here. So this should not be null. This should be 121, right? Yeah. So let's say we have reached here. Now, once you reach here, when you know that the next element is 9, what is a step you will do? So the only step which you have to do is, if you want to delete this, what if you can simply change your next element to this element? Don't you think 9 will be removed? So how do we do that? So first of all, we have to check if current.next is not equal to null. You have to make sure that the next value is not null, and then you can perform the operation. So the only thing you have to do is, if you are here, so this dot next should not be this element. This dot next should be this element. How do we do that? So we have to say current dot next is equal to current dot next dot next, because current dot next will give you, so if you are here, current dot next will give you this. I mean, this value will be referring to this element. We just have to say this value should be 101. So the only thing you have to do is change this value from 301 to 101. And the way you're doing that is with the help of this line. And that's deleted. Okay, let's see if this works. Let's run this, and you can see 9 gone. Okay, this is that simple. It's just that traveling to that point and changing the node of the previous one, because the moment you change this value, you're done. You don't have to actually delete the value or delete the node, because it is now we don't have a reference for this one. This will be garbage collected. Especially in Java, we do garbage collection. So yeah, that's about linked list, where we were able to add element at the end, at the start, and also delete. In this video, we'll talk about stack. Now, stack is basically a linear data structure, so we can use it to store data. Now, the question arises why it is different. The thing is, stack follows something called last in, first out. So as you have seen, basically we were able to stack data on top of other. So here we were using devices, but we can also store data in the same format. So basically what happens is, you can create a stack, but then stack looks something like this. Basically you have this type of memory where you only have one entry point, and the same entry point is also an exit point. So let's say if you have some list of values which you want to store. So maybe I want to store 5, 8, 6, 3. So I want to store these 4 values. Now what happens is, when you want to store this 5 basically goes into the stack, but the question is where it will be stored. So it will be stored somewhere here. So 5 will be here, okay? And now, once you stored 5, now you want to store 8, it goes on top of 5. So 8 goes here. Now, what happens here is, it follows, as I mentioned, it follows LIFO, which is last in, first out. Basically, the last element which you have entered will be the first element which will come out, just like stack of books or stack of devices or stack of plates. So the last thing which went inside, which is 8, is the first thing to come out. Okay, so we use a concept called push and pop. So when you want to insert data, we use push. When you want to get data out, we use pop. So at this point, if I say, hey, this is my stack, let's say stack is nums. And if I say, hey, nums, pop. So what nums will do is, it will give you the last element entered, which is 8 in this case. But let's say you enter some more data. You want to insert 6 as well. So 6 goes here. Now, when 6 goes there, basically when you say, hey, I want to pop now, so it will give you 6. So if you want to insert data, you will say push. When you want to get data out, we use pop. Basically, we have certain terms here to remember. What if the stack is full? So let's say the size of this stack is 4, or maybe 3 itself. Let's say the size of this stack is 3. And now you have entered 3 values. But what if you are entering a new value? So instead of 3, let's have some other value so that you will not get confused with the size of the stack and the values. Let's say the value is 9 here. So when you are inserting 9 now we don't have a space, right? So 9, when you try to push 9, it will give you an error called overflow. And you might have seen this error, right, which is called Stack Overflow, the website. It came from this word, which is overflow. So the stack overflowing. So 9 is not able to save there. Also, there is one more term called underflow. Now, what is underflow? Let's say you have a stack which is empty. So we are getting a new stack here, which is empty in this case. And when you say, hey, I have an empty stack here, I want to pop. Now, we can only pop the elements when they are there. It's not there. So we don't have an element there. So it will give you an error which is underflow. So overflow, when you have a stack full, but still you're trying to insert data. And underflow is basically where you don't have any elements there, but you still try to fetch data or remove data. So one thing to remember with pop is basically a function or a way to get the element out. So of course it will give you the element. That also means that the element is coming out. So example, let's say at this point, I want to do a pop on this stack. Basically what I'm also doing is I'm popping this 6 out. So now if you say how many elements I have in the stack, only 2, okay? And again, if you say pop on this particular nums, it will take this 8 out, which came with the underscore, but that's not how it works. Let me just do that again. So 8 will come out. Again, when you say pop, the 5 will come out. Again, when you say pop, it will give you an error, which is the underflow error or underflow exception. So basically, pop means getting the data out. But let's say you don't want to get the data out. You just want to see what is the last element. So we use one more thing for that, which is called peak. Now peak will give you the last value, but it will not remove the value from the stack. So if you just want to check, you want to peek, you can use peek. But if you want to get the element out, you use a pop. When you want to insert data, you say push. So this is your last in, first out inside stack. Now question arises how we are going to implement this. So there are two ways of implementing this. One, you can use normal array. In fact, in array itself, we can use fixed size array, or we can use dynamic array. Now in fixed size, basically by default in most of the languages, when you say array, it's of fixed size. But you can make it dynamic, so you can expand the stack or the array the way you want. So overall, stack is a concept, okay? So if you want to implement that, we have to use array. The another way you can do that is with linked list. We have already seen linked list, so we can also implement stack with the help of linked list. The advantage would be there's no problem of the size there, because in linked list you can expand the linked list. The drawback is it will be a bit slow, but that's fine. Anyway, you are going to remove the data from the last. Right, so you can implement stack with the help of linked list as well. So yeah, that's about stack and how we are going to implement that. So we are going to write a code for array, using array for stack. Okay, so let's try to implement the stack in Java. So what you do is basically, we have talked about the theory, right? Now, if you want to use stack in Java, basically we can simply say stack, and it's an inbuilt class available in Java. So I can simply say stack, and if you can see, this is the package where you find stack. So if I click on stack, you can see it's a class, and basically it provides you the methods which we have talked about. We have talked about push, we also have a pop here, then we can see also peek. So everything is there, right? But then I don't want to use inbuilt, but even if you're using inbuilt, let's see what happens. So if I say stack nums is equal to new stack, I don't want to use any specific type of data which we want. Let's go for objects. And if I want to add data, I can simply say push. And when I say push data, let's say 10. Now what happens is in this stack, we only have one value, which is 10. Okay. So if I try to print the stack, which is nums, let's see what happens. I right click this and I say run. And in the output, you can see it says 10. So you have one data. But what happens when you push more data here? So I can just simply copy paste this one more time. So we got 4 values now. And let's say this is 30, this is 70, this is 20. And when you add all the values here, if you run this, you will get the output of all the values. You got 10, 30, 70, 20. Now, yes, it looks like sequence the way you have added, but in stack it goes in, first out. Basically, the 10 got insert first, 30 get insert later, then 70, then 20. Let me prove my point. What I will do is I will simply say nums.pop. Now what pop will do is it will remove the last element, or maybe I can also do this not here, but after 30. So when I say pop will remove the element, the first element. Okay, so when I say first element, not exactly first element, it will remove the last element which got added. So the first element which you can access is the last element. I know that sounds weird, but that's how it works. So if I run this again, it will remove 30. So that's where it got popped. In fact, pop will give you the value if you want. So you can store that value somewhere. Maybe you can print that value somewhere if you want. Let me just print it here. So I'm printing that value which we popped out of this, and you can see the value is 30. So we can do these things. In fact, we can also use peek, but I don't want to use the inbuilt class. Let's create our own. So the what thing you have to do is, when you see the stack, let's create our own stack. So if I say, okay, give me a suggestion. Okay, so more action, depending upon which IDE you are using, it will have the same thing. Click here. I want to go for the default package, and you can see we got a stack class. So we have 2 stack on the top, but one is coming from the util package, which is inbuilt. I don't want to use it. This is the stack I want to use. Let me separate the code somewhere so that you can see both. Okay, so right hand side, we have our own class, and on this side, we have the main. Okay, so I want to achieve the same thing, but at this point, let me just comment the pop part. Let me also only work with push. Unfortunately, we don't have push here. So let me create one method which is public, void push, and this will take a value from you. So I will say int data, let's say, and okay, not declaring it, defining it. Okay, but then when you will push it, of course you need an array here, right? So as I mentioned, there are different ways of implementing stack. One of the way is you can use array. So let me use an array here. So I will use a private int array. So let's name this as array itself. Of course, you can use any variable name, doesn't matter. And then I can assign some size to it. So let's say the size of this array is only 5. So the max value you can have is 5. Okay. Now, apart from this, if you remember the theory, we have talked about some variables. One of the variables you have to remember is top. Now, top will refer to which is the last element which you have added. I mean the index value. So let's say you have inserted 3 values, so the top will be representing 3. Okay, but then by default, the value for top would be -1 because I want to start from -1 because we don't have any values yet. So it's -1. We can take one more variable here which will define the size of the array. So I can say int size, but then I can't assign the value here. We should take the value of the size of the array. So we can take that in a stack constructor. So I can say stack, and inside this I can say size is equal to the size of the array dot length. So that's my size. That's the maximum size I can have. In fact, let's also define the size of top inside the constructor, and that's done. If you want, you can also define this array creation inside the constructor. Okay, so you can have a declaration here. Assignment, you can do it in the constructor. But again, that's your implementation way. Okay, so once we got that, how do you push element there? So pushing is actually very easy. You take your array and say, okay, I want to insert at the first location, which is 0, because array starts with 0, and you can save the data. The job is done. You are able to push it. Okay, let's see how it works. But also we can't say nums here because we are creating our own class. So if you want this to work, you have to implement toString method. But instead of doing that, I will say public void print string, or print stack, not print string, print stack. So it will print the entire stack for me. And the way you can do that, you can use enhanced for loop here, which is int n in array, and we can print all the values. So we can say without ln, I want to print all the values. We can print n, and I can give a space in between. And at the end, I will print the new line so that it will come on the new line after printing. Okay, so here I cannot say nums. I can say nums dot print. Okay, let's see if this works. We have added 2 values, 10 and 30, and then I'm trying to say print stack. Let's run this code. And you can see it is printing only one value, which is 30, not the other values. Why? The reason is, every time you say push, don't you think you're pushing at the same location, 0? It should change, right? So the first value should go at the first location, the second value should go at second location. So how do we know where to push? So we can use something called top here. So every time you basically push a value, we have to increment the value of top. But also there's one more problem. The top initial value is -1. That means we need to do the increment before we assign the value. So once you do this, the top value, which is by default -1, will go to 0, and then you are assigning it here. Next time when you do that, when you insert 30 here, what it will do is it will again increment the value of top, which is 0, which will become 1, and then you're inserting at the second location. Let's see if this works, and yes, it works. You can see we got 10, 30. We can have some more values here. In fact, I can just uncomment this section and maybe add 2 more values, or maybe let's try 1 more value. Let's say this is 50. With 50, it also works. You can see we got all these values. I can have 1 more here, and let's say this is 90. And the moment I do that, you can see we will get an error, which is array index out of bound exception. So this is not what we wanted, right? Basically, this is going out of the box because we only have 5 values. We're inserting 6 values, not good. So that means when you're pushing data, we have to also check if the stack is full. How do we do that? So here we can actually check if, so before doing all this operation, we can check if the size of the stack. Now, how do we know the size of the stack? I mean, the values which I've inserted. We know the size, but the values inserted will be stored in top. So we can simply check with top. If top is greater than or equal to size, we should not be doing this. Or we should do this only when the top is less than the size. Then it makes sense, right? So this to section should be a part of this if condition. Now I think there's no issue. Let's run this. Okay, we still have an issue. That means we are not, okay, because we are incrementing, this should be outside. Because how it will check if it is not incrementing. And since we only have 1 statement, we can remove this curly brackets. Let's try. And yeah, it worked. You can see the last element which I've added is not inserted. But also you can do one more thing here in the else part. You can check, maybe you can print stack overflow. okay, the famous website. Run, and you can see it is printing Stack Overflow for the last element. Okay, so you can see now we are getting Stack Overflow. Okay, so that means this is working. So push is working. What about pop and peek? Let's see that. So we are done with push. Now it's time for pop and peek. So let's write a method for push. Let's say at this point I want to say pop, so that when you push the last element. So in total, what do you think when I say pop here, and if it works, how many elements will be getting added? Of course, we'll add 6 elements, but then ultimately we'll be having 5. Is because after pushing 10 and 30, so basically at this point you are removing 30, right? The last element. Then you only have 10 and then you're inserting 4. So in total you will be having 5. How we are going to implement pop? So think, remember, when you say pop, it returns a value, right? So I have to say public int pop. We don't have to pass any parameter, we just have to implement. Now we have to return something, right? Now what we have to return? Remember, when you talk about the stack, there is one variable which is pointing to the last element, and that is your top. So if you can simply get the value from the array of top, your job is done, don't you think? Okay, so this is how it works. You can simply return the pop, and when you run this code, and we are printing pop as well, let's run this, and you can see it is printing 30. So that's right, we are getting the value. What it is not doing is removing the element, because see, in the output 30 is still there. So that means we have to remove as well. So how do we remove? So we can do one thing. We can say minus minus. What it will do is it will return the value of top, and then it will decrement. This is post decrement, right? So post decrement means it will give you the value first, then it will decrement. And let's see if that works. Run, and yes, it worked. You can see it is giving you 30. That's the right output, but in the entire stack, we don't have 30 now. So pop is working. Don't you think the same thing can be done in push as well? So instead of incrementing it here, what if you increment here? I think that should work. Let's run, and yeah, push is still working. So we can also reduce one line here. Now here we have to do pre-increment is because first we have incrementing, then we are assigning a value. So this was pop. Now since we have worked with pop, we can also work with peek here. So here if I say it's peek, the only thing you have to do is don't remove the value, okay? So now if I, at any given point, let's say at this point, if I say system.out.print nums.peek, it will basically give the value, but it will not remove that value. So you can see that the value it is giving you is 20. It is not removing 20. So that's the main difference between pop and peek. You can do some more things here. Example, we are checking for the size here. We still have something to do with pop. So let me just talk about that. But you can modify this and you can create another method called is full, is empty. That also makes sense because then you don't have to compare in this. You can simply say is full, then you don't do this. Otherwise, you can do this. So you can have another method. Okay, so now why I'm saying that this pop is not complete. Let me show you something. What if I just uncomment everything, and here, now since we don't have any value, what if I say nums.pop? What will happen is, it will give you an error. It is again saying index out of bound exceptions because by default, the top is -1. Okay, so we don't want to do that. So when should we return? So what you can do is if the top is more than -1, then only return. Otherwise, don't return. That's what we're going to say. But then we cannot put return inside if. I can simply say return here as well. Let's return with some value. Say 0. Okay. What if it is the stack is empty? In that case, I can print stack underflow. So at this point, it should print stack underflow. So run, you can see there's no problem. It is printing stack underflow. Okay, so that's how we can add this. Again, if you can simplify this, you can also use isEmpty method. That should also work. So this is all about stack in Java. In this video, we'll talk about queue. The thing is, we have talked about stack, right? Which is last in, first out. But what if you don't want to do that? You don't want to do last in, first out, because in the real world, when you go to shopping, when you have a checkout counter, basically the first person who goes there is the first person to go out, right? You don't want to have stack in that situation. And that's where we also have a word called queue in English. So we use a concept called queue there, which simply means that it will not follow last in, first out. It will follow first in, first out. Something like this. So let's say you got an array here, and this array has multiple values. Let's say 4 values in this case. So 1, 2, 3, 4. And then if you want to insert some value, basically it will go from one end and it will come out from the other end. So what I want is, let's say I have different values here, which is 5, 8, 2, and 3. So let's say I have these 4 values which I want to insert. So basically it will go from one end, it will come out from the other end. So we can say this is my front and this is my rare. So basically the values will get inside from the rare. So example, if I want to insert 5, 5 will come from here, but then it will check where we can place it. Basically, it will always try to paste at the other end. So 5 basically goes here. What about the next value? So 8 comes and 8 goes here, 2 comes and 2 goes here, and 3 comes and 3 goes here. It makes sense, right? Of course, that's how we'll paste the value. What makes this different from stack is first in, first out. Basically, which is the first value which we have entered? Of course, 5, right? Now, if I want to remove the value or take out the value, which should be the first one? It is your 5. So 5 will come out from here. So first in, first out. So this is how basically queue works. Okay, but there are certain terms which you have to remember. So when you say you are inserting the data, we normally call that as Enqueue. So Enqueue means you are inserting data. Then we have a word called Dequeue. Dequeue means removing the data. So example, whenever you insert the value, that's your Enqueue. Whenever you remove the value, that's your Dequeue. So what happens in Dequeue is, the first element basically comes out. So the first element comes out. That's your Dequeue. And when you insert the next value, that is your Enqueue. But then the problem is the size of this queue. Of course, we can implement that with multiple things. You can use array or linked list. But let's say if you're using array, the size of this is 4, right? Which means you cannot insert another value. So let's say someone says, hey, I want to insert one more value, which is, let's say, 9. Now, you cannot insert 9 there because we don't have a space. But logically, we do have a space, right? We have a space at the start. But unfortunately, we can only insert from the rare end. Now, that's one of the tricky points. How do you do that? So one solution could be move all the elements, move 8 on this side, 2 on this side, and 3 on this side, so that you can have a space there. But don't you think that will consume a lot of computation? Because shifting values is a time-consuming process. But yeah, that's a problem we are trying to face, and let's try to solve that in some time. But important thing is there's a concept of Enqueue, which is inserting. Dequeue is removing the elements. So let's say we have removed 5. Now 5 is gone. Now again, when I say Dequeue on this queue, what happens is it will go for the next element. So the first element from that queue, so 8 will come out. Now remaining is only 2 and 3. So basically every time you say Dequeue, you are reducing the size of your queue. Every time you say Enqueue, you are increasing the size of your queue. Now, apart from these two methods, we can also use something called a peek. Now, we have talked about peek before. So peek, what it does is it gives you the value, but it will not remove the value from the queue. So example, let's say if I want to do peek now on this particular queue, it will give you 2, which is the value here, but it will not remove the value. So difference between Dequeue and peek is both will give you the value, but Dequeue will remove the value and peek will just give you the value, okay, not remove it. Okay, let's get back this value inside because I want to use them. So let's get 5 and 8. So let's say we have a scenario where you have all the 4 values. How you are going to implement this? How you are going to implement queue? So what we do is we take 2 variables. We have already used those 2 variables. We have front and we have rare. So basically every time you insert the value, you increase your rare value, which means initially the value of rare will not be at the end. So how do we implement this? Let's take an example here. So let's say again, I want to insert the same values, which is 5, 8, 2, and 3. So I want to insert these values. So what you do is you take a queue, basically this is your queue here, which will have 4 values. Let me create box and let's insert the values here. But before inserting, we have to take those variables, right? So the 2 variables we have is we have front and we have rare. The value for them by default, the front will make it 0 and rare will be -1. So that means rare is basically pointing somewhere here and front is here. In fact, just to simplify this, I will not be using rare or front. I will be using R and F. So R will be here and F will be here, right? Now, when you insert the first value, so let's say if you want to insert 5, now 5 basically comes here. We got the value 5. Now what you do is you move your rare here, okay? And then let's say you want to insert 8. So 8 goes here. But don't you think even before you insert 5, you should move your rare? So what I meant to say is we try to make sense, but then even before you insert 5, because we have no idea from where to put this. So what you do is you basically move your rare here first, and then okay, wherever you have R, basically you put your value there. So 5 goes here. Then when you want to insert 8, again you move your R next. Let's put it here. And then you say, okay, 8 goes here now. Again, when you want to insert 2, you basically move your rare once again here. So whenever you want to insert value, you move your rare there. So basically you have to just increment rare every time you insert the value. Okay, this makes sense, right? But what about the front? Now, basically when you say front, it will be used for dequeuing. So let's say now when you're dequeuing it, how will you do it? So when you say dequeue, basically first you will remove the value, and then you have to make sure that you move your front here. Why we have to move is because now 8 is the first element, right? So which one to remove is done with the help of front. Where to insert, that will be handled by the rare. Now, do you want to move rare first before? That depends upon your implementation. We need one more variable here, which is called size. So to know where we are. Okay, now there's one problem, as I mentioned. Let's say if I want to insert 3, so 3 will come here, no problem. But let's say after that, if I want to insert 9, where will 9 go? We do have a space here at the start. We can insert 9 here. But then don't you think till this point, when you inserted your 3, your R is here, how will you make sure that R goes back here? The only way you can do that, because first of all, why we cannot do that? Because we are using index number, right? We have 1, 2, 3. These are the index numbers we have. So every time you can increment, you can say from 1 to 2 to 3, but you cannot say 3 to 0 again. But if you can do that, the problem will be solved. So what I want is after R goes to 3, maybe I just want to make sure that this comes back here, okay? And the way you can do that, provided you should know that there's a box empty here that can be handled with the size variable. This will solve that problem. But if you can move this, if you can come back from 3 to 0, don't you think that is we are going in a circle? And that's why there's one special type of queue which is called a circular queue. Now, what is circular queue? Again, the same thing we have done before. So R moves basically from the last element to the first element. And if you want to imagine this, maybe you can imagine a circle. So you can say we have 2 circles here and we have 4 values. Okay, so we got 4 values now. So basically what we will do is, let's have an index number here. So this is index 0, index 1, index 2, and index 3. Same index which we have used for the array on the top. And now when you want to insert, basically we need those variables, right? The rear and the front. So what we can do is I can make this as front and this is rear. Both are pointing to the same value now. So let's say, okay, actually I'm pointing to the wrong point. So this variable basically should point here. So this is your front and this is your rear, right? And now when you want to insert the value, the first value you will insert is at the rear. So let's say we have 5 here, and then let's say again you're inserting 8, 3, and then now let's say you have also inserted 1. I think those are the values, doesn't matter actually, 2 or 3, but let's say we have this value here. And now when I say dequeue, now from where you will remove the value? So you will remove the value from, okay, so when you're inserting all the value, you have to make sure one more thing, your rear goes here when you inserted all the values. And now when you say you want to dequeue, basically what we can do is we can remove this particular 5 value from here. That goes out. Now this is empty, right? And of course you will move your front to the next location. Front is here. Ignore this arrow. I can't change the location of it. Doesn't matter. So your front is here. But then we have an empty space here. So we just have to make this circular. So when you insert a new value, which is 9, your rear goes here. And that's how we can achieve a circular queue. Now basically to do this, of course, if you want to increment the value of rear, we can do that, right? So we can say rear plus 1, it will increment the value. But if you want to go in circle, what we can do is we can use something called mod of 5, or sorry, mod of size of your array, which is 4. So we can say mod of 4. Now what it will do is, let's say your rear value is initially 0. So we know that 0 mod 4 is 0. Mod is basically remainder. 1 mod 4 is 1. 2 mod 4 is 2. And then let me just write it here. 3 mod 4 is 3. 4 mod 4 is 0. So after 3, it will come back to 0. That's how we can perform this thing. We can use this thing to achieve that, the circular thing. Now, how we are going to do in the code, that we'll see in the next video. But point to remember, queue is first in, first out, and it is getting used in most of the places. Example, let's say if you want to schedule a task. So which task should happen first? You maintain that to-do list. So the first task you mentioned that should be the first one to complete. But there's multiple types as well for the queue. There's one more thing called priority queue, where Even if you mention the task in sequence, you can mention the priority for it. So the highest priority element or the task will be the first to pick it up. But then we'll not be talking about priority queue. Let's say we have a simple queue and a circular queue. So now let's try to implement queue in Java. Now basically we do have the inbuilt interface of queue. We'll not be using that. We can directly create a queue class for us. And let's say this is queue equal to new queue. But as you can see, we don't have the class. So what we can do is we can just go back here and say more action. I want to create my own class called queue in the same package, which should go somewhere here. Okay. So this is your main method, and on the right hand side you can see we have a queue. So in queue basically what we can do, so we want to insert value, we want to delete value. So let's try with inserting first. So with the help of queue, I should be able to add value. So let's say I want to enqueue a value. So of course we can use add or other methods, but let's stick to the convention. So we have enqueue. Enqueue basically means inserting the value. Let's say I want to insert 10, but as you can see it's not working. The reason, we don't have that method. So let's create that. So I will say public void enqueue, and it should take a parameter. So I will say int data, and that's how we are inserting it. So let's see how do we define this. Now we know that whenever you work with the queue, we need to use certain variables. We have talked about that in theory as well. So the first variable we need here is, let's say private int front. That's what we need. And then private int var. That's the variable we need. And also we need to know the current size of the array or the queue. So I will say size, and of course the array itself. So I will say private int array. This should be an array. So I will say specify type as array. So we got 4 variables, and let's try to use it. Initially, the value of front which I want is 0. I mean, there are different ways of defining these values. We can also use constructor, but let me just do that here itself. Size by default will be 0 because that's a size, default size is 0. And then I want to create the array of size, let's say 4. So the size, maximum size, I have 4. And yeah, let's try to use it now. So every time you want to insert data, the only thing you will do is you will insert data in the queue, right? So you will say, I'm in the array. So you will say array. Okay, what should be the variable? So should I insert at the 0? Yes, we can do that. So I can, whatever data I receive, I will insert that at 0 position. But don't you think every time I add a new value, it will go to the same location? So this is not a correct way. I will use a variable called var. So var will define where to insert data, okay? Because you insert data from the var end. But initially, var will be at -1. We don't want it. We want to insert at the 0th location. So before you do that, before you assign the value, you will simply say var++. Our job is done, okay? And let's see if that works. Even if it works, how will we know? So what we will do is, let me also create a method called print all values. So I will say private, or maybe I can say public void show. It should print all the values, nothing much. Not an ideal way of printing the size, but let's do that. So I will say int n from array. I want to print, but not here on the same line basically. So I will just print the value and give a space. And at the end, I want a new line. So I will do that. And from this, let me print, not this. I want to call the show method. So it's a queue.show. It will print all the values. Right click and run. And you can see we got 10, 0, 0, 0. This is 0, 0 because the size of this array is 4. So basically it will print all the values. So maybe this is not a correct way of doing this. What if we can use int I? I will start with 0. And I less than size. Okay, so basically we want to print till the size of the queue. And then I will say I++, okay. And then I'm going to print ARR of I. So what it will do is, it will only print those elements which are there in the list. If I run this code, it's printing nothing. Reason, when you inserted the data in the queue, don't you think we have to also increment the size? So now, initially before running the enqueue, the size of this queue is 0. But then when you insert the value, we got a new element which is 1. I mean, we got one element which is 10. And now if you run this, you will only see one element. Yes, if you do this 2 times now, let's try to do enqueue again with a different value, let's say 20 in this case. Now what will happen is, it will print 2 values. So even if your array size is 4, the queue in that array is still 2. So the size of the queue is 2. So that's how we can basically use the enqueue. But what about dequeue? Let's try to do that. So what I will do is I will say public void. Okay, the Dequeue will not be void. Dequeue will be int because you are getting the value as well. So I will say Dequeue of int. Okay, when you say Dequeue, you don't specify the value. You just get the first element, right? Now question arises, what you will return? It's very simple actually. What you return is the value from the array, but the variable will be front, which will be referring it. Our job is done. We are returning the front. And if you want to see that, what we can do is we can print by saying queue Dequeue. So Dequeue will give you the value, the first value from this queue. Now if you run this, you will see it is printing 10. Reason? Because that's the first value we have inserted. But also, when you say Dequeue, don't you think we have to remove this 20 or remove this 10, sorry? So the output of this show should be only 20. It's not working. Okay. Reason? We have not done that code in Dequeue. So when you say you want to reduce it, so how do we reduce it? It's very simple. You simply say front plus plus. Now when you do front plus plus, what we are doing is, when you have this array, let me just draw that here. So this is your basically a queue which you have created with 4 values. And in fact, the array size is 4, but by default, the queue size is 0. But when you insert 10, the queue size becomes 1. When you insert 20, the queue size becomes 2. Now what we are doing is here at this point, we are saying Dequeue, which means we have to take this 10 out. So if you take this 10 out, the size should be only 20. Size should be only 1. The value should be 20. How do we remove this 10? See, initially the front was here, right? Front was here. What if instead of removing the value, just move your front? If you do that, your job is done, right? And so that's what we're doing. We are saying front plus plus. But then where should we do it? Should we do front plus plus before? Of course, it should be after this, right? But then there will be a confusion. So what we can do is we can take a temporary variable called data. And in this data, you store your value first. So you simply say cut and paste. So you store your value in data, then you front plus plus and return data, not the array or the array element. Because the array element is stored inside data, then you do front plus plus so that you will get data. Now if you run this code, you can see 10 is here. Okay, but there's one problem. It is printing 10 as well. Actually in queue we only have 1, but still it is printing 10 as well. Reason, we are printing all the values of the array. It should not start with 0, it should start with front. Then it will make sense, right? So run, and you can see we only got 20. So this 10 is actually Dequeue printing. So this Dequeue is printing 10. This 20 is actually printed because of the queue. Let me insert some more values here, then it will make much more sense. Let's say I'm inserting 5 and 99. So we got 4 values now. And when you say run this, you got 4 values. But now when you say Dequeue, it will remove the first value, which is 10. Remaining value is 20, 5, and 9. So that's how basically it works, right? So we are able to Dequeue as well. But the problem is, what happens when you do Enqueue not 4 times, or maybe something like this? You are inserting 4 values, and then you're saying Dequeue. After Dequeue, how many elements are there in the queue? Only 3, right? You can see here. But then that also means that if I do Enqueue once again, after doing the Dequeue, let's say the element which I'm adding here is 12, it should work, right? It should print 20, 5, and 99, and 12. But it's not working. It has given you the error, which is array index out of bounds exception. That means we have not implemented the circular queue. So let's try to solve this problem of array index out of bounds exception. So why we are getting is because even if your size of your queue is less than the size of the array, it is still giving you that problem, right? So we have inserted 4 values, that's right, but then we have also done the Dequeue. So when you say Dequeue, the size of the queue is only 3 now. I should be able to add this. And it can only be added in the circular way, right? So it should be added at the end. How will you do that? So what we can do is, when you're doing the Enqueue, instead of using array plus plus, we can say rar is equal to rar plus 1. But you will say that's the same thing, right? But by doing this, what we can also do is we can do a mod operation. Remember in the theory we have talked about, if I do a mod of 4, our job will be done, I think. Let's try. Let me just rerun this. And okay, now again we got the problem. But this time I think the problem is with this show. Because in show, we are not doing the mod operation. So what I will do is, I will start from front. I can't go till sizes because size is higher now. When I do Dequeue, I have to also decrease the size, right? So let's run. And this is actually not a good way of printing. It will not print the way we should be getting the output, but at least we will get the output. Okay, we are adding 12. It's going one less than the size. Okay, this is not actually the right way of printing it. So let's ignore the printing part at this point. Let's skip this show and let's run this. So now you can see there's no problem, it is working. Basically, I can do Dequeue multiple times now. Let me just do the Dequeue here. So after inserting these 4 values, when you say Dequeue, the 10 goes, right? But then we have 20, 5, 99, and 12. Let's try to do Dequeue here. So then we will know what are the elements we have. So 1, 2, 3, and 4. So again, I'm doing Dequeue 4 times, run this, and we got an error. Okay, anyway, so we got 10, we got 20, because that was the first element, then 5, then 99, and then Dequeue is giving a problem because what we have done is in the Enqueue, right, this thing. The same thing need to be done in the front. So I have to say front is equal to front plus 1. And then what if I just mod it by 4? Again, I'm using a hard-coded values because I know the size of the array. But if you want to make it dynamic, if you want this value to be changed, maybe you can just take one more variable called max size and you can put it here. Okay, let's see if this works. Restart or rerun. And now it is working. You can see we were able to add the values and we were able to delete the values. Yeah, so let me just make it floating so that I can see all the outputs. Yeah, so you can see we got 10, 20, 5, 99, and 12. So we were able to go into that circular way. And it's not like when we have added 12, so it will be first. Once you remove 10, then 20 becomes the first element. And you are able to do that here. We can actually use 2 more methods here for full and empty. If you want to check if your queue is full or it is empty. So I can create a boolean method or a method which returns a boolean value. I will say is full, is it full? Let's check. How do you know if it is full or not? It's very simple. If your size is equal to 4, it is full, right? And how do you know if it is empty? In fact, you know why we should use this method? Let me show you something. What if I want to add one more value here? So I'm inserting 6 times and removing only once. It should give a problem. But unfortunately, if I rerun this, look at this. It's not working the way I wanted. Okay, let's have a different value because it is giving 12, 12, 2 times. Let's rerun. And you can see this is not what expected. Where is 20? 20 just went off. So we have some bugs here. So don't you think this should not work? 32 should not be added because the queue was full. So we can implement this method is full. And before you do this Enqueue, we can check if is full. In fact, if it is not full, then do this. Otherwise, don't do these things. Else, if you want to do something, you can throw the exception or you can print if you want. Maybe you can say queue is full. Okay. So now what will happen with this is if you run this now, it will not add the last value. You can say it says queue is full. So you cannot add 32. And that's why the only elements you have is 25, 99, and 12. The same thing should be done for Dequeue. What if your array itself is empty? Now let's say if I want to Dequeue once again here, it should give you a problem. You can see it will, okay, it's not doing anything. It's just that it's printing 20 again. I don't want to do that. I want to say the queue is empty. So what we can do is we can have one more method here, which is public boolean is empty. We can check if the size is equal to 0, that means it is empty. And then that means before doing the Dequeue part, we can check if it's not empty, then only you have to do this part. I should return this data. I will take this data variable outside. There's one more way you can do that instead of sending dummy data, because if I do this, it will send dummy data. What I can also do is, if it is empty, I can simply throw an exception, or maybe you can also print something, but throwing exception will also make sure that it will stop the execution, right? So I can print queue is empty. Okay, let me just move it down. So queue is empty. Now if you run this, it will give you an error, but error which we have created, and it says queue is empty. Yeah, that's how basically we can do this. We can also use the exception part here for the queue is full if you want. Again, that's the way we can implement. One more, you can also use something called peek, but peek matches with Dequeue. So let me write it here. Now in peek, what you do is you only return the value, but you don't decrement the value or increment the front value. So what you will do is you will have the same code here. The difference is you don't remove the size and you don't do plus plus. This is not there. It's just that get the data and return. In fact, you're not performing the operation. You can simply write the array here so that you can reduce one line of code. And since in the if condition we have only one statement, we can remove that curly brackets. This code looks shorter. So that's how we can use peek. Let's see if I can use peek here. So maybe I want to print peek plus q dot peek. And let's see if this works. Run. And yeah, peek was 20. So yeah, it is not removing the value, but it gives you the value. So this is your queue. So the logic which we have implemented here is actually circular queue. Okay, so that's it from queue. I hope you enjoyed this entire queue concept. See you in the next topic. In this video, we'll talk about tree data structure. The thing is, we have talked about linked list, right? And now we know that how do you connect different nodes. So basically node is somewhere you will put your data, and also it will have a reference for the next element. So basically you can create a linked list, something like this. So this is a linear structure, right? Just because we have everything in one line. I mean, of course, you can change the shape of it, but ultimately it will be a line, right? Referring to the next point. The other type we have is hierarchical structure. Now, basically, there's a concept of tree. I mean, something like a real life tree, which we have. So in this, you have a root, you have a branch, and you have leaf, right? Or leaves. So we can do the same thing in data structure. So basically what we have is concept of tree. So what we do is we basically create different nodes or nodes with tree structure. So something like this, we have a node here. Let's say this is node A, and then this particular node will have sub nodes, or we can say child nodes. So here we can have another node, here we can have another node, again a node, and even this can have different nodes, one or many or zero, doesn't matter. So this is how tree structure looks like. So you can have values as well. So let's say instead of A, I have value which is 5, 6, 8, 2, 1, 8 again, and 3. Now this is a tree structure, okay? So it is not linear, it is hierarchical because we are creating an hierarchy here. To understand this more, first we have to understand different terms which we are going to use. So if you see here, we have different terms which you have to remember. The first term here is node. So what exactly node is? So every element or a part where you save data, these are your nodes, okay? And the same thing we have done in linked list as well. Next, we have something called root. Now, every tree, in real life also we have a root. So in this structure, the node which is on the top level is your root node. So we have one more concept or two more concepts here, which is parent and child. So example, we have a node here. Now this B is actually a child of A, okay? Same goes for C, C is also child of A. And of course, by doing this, we are saying A is a parent. I mean, it's almost similar to your family tree which you create. We have grandparents, then we have our parents, and then the list goes on, right? So same goes here. We have a parent and then we have a child here. So every node will have a parent, of course, and a node can have a child as well. Again, it's not compulsory, but a node can have a child. So if you talk about B, the parent of B is A, but what about A? Where's the parent for A? So there's no parent for A, right? So the nodes which has no parent, that becomes your root node because that's where this thing starts. So that's your root. Next we have is edge. What is edge? So a line which connects your parent and a child is your edge. So this line here is edge. So we have talked about node. So node is something where you save data. Root is the topmost parent node. We have edge which connects different nodes. We have talked about parent and child as well, which is A is a parent node here because it has two nodes here, B and C, which are child nodes. Then we have something called a leaf node. Now what is leaf node? A child node which will be only child, it's not a parent. Example, if you talk about B here, B is child of course of A, but it's also a parent of D and E, right? If you talk about D here, D is not having any child, right? So there's no child here. So this is called a leaf node. Now this is not the only leaf node we have. So we got D, E, G. These are your leaf nodes. Next, we have a concept of depth. So now what is depth? So let's say if you talk about any particular node, so let's talk about E here. Now to reach E from the root node, how many edges we have to pass? Okay, so example, if you want to reach E, basically from A we have to go to B, from B we have to go to E. So we have to do 2 passing. So we have different levels here. Okay, so the root node is at 0 level, then B becomes 1 and E becomes 2. Okay, so that's your depth. So depth for this E node is 2. Next we have is height. So now when we talk about height, we're talking about the height of a tree. Okay, so what's the height of this tree? So we have to go till the last leaf node, which has the highest depth. Example, if we talk about this D, the depth for D is 2, right? So from A to B, B to D. What about G here? So for G, it is from A to C, which is, so this is depth is 0, 1, 2, and 3. So the height of this tree is 3. So we have to go till the highest depth of a node in the entire tree, which is 3 in this case. So that's your height. What about this subtree? So we have a concept of subtree. Now, of course, this entire is one tree, right? So the root of this entire tree is A. But then we can also have subtrees. Example, if we talk about A, we have 2 child nodes, right? We have B and C. So let's talk about B here. Now, if you consider this as your tree, of course, right? This is a subtree. Now, in this subtree, if you're focusing only on this subtree, B becomes your root node. Okay, so B here is a root node. And then these are your child, of course. So when you look at the entire tree, of course, A is a root node. But if we talk about this tree, subtree, which is B is a root node. If we talk about this subtree, C is a root node. If we talk about this subtree, F is a root node. So basically, if you create subtrees or if you consider subtrees, then we have a different root node compared to the entire tree. Okay, so those are the terms which we have to remember. Now, if you observe one more thing here, when you look at this tree, so maximum number of child nodes we have for each node is only 2. So it's either 0, 1, or 2. So when you have a tree something like this, where you only have maximum 2 child nodes for each node, we call this type of tree as a binary tree. So it's a type of tree where the maximum number of elements or maximum number of child nodes for a particular node is 2. So of course, a child can be 0, 1, or 2. Example, if we talk about this A, the number of child nodes it has is B and C, which are 2. If we talk about F, we only have 1 child node. Even for C, we have only 1 child node. But if we talk about D and E, they don't have any child nodes here, even G. So still it's a binary tree because the maximum number of child nodes we have is only 2. So basically, when you talk about binary tree, there are different types of it. And one type which we're going to talk about, which is called a binary search tree, because the example which we're going to code is based on this. Okay, let's talk about the binary search tree. The thing is, when you want to search a particular element from the entire tree, it is better if you can save that in a binary search tree. Now, how it is different from binary tree? The thing is, in binary tree, there is one thing we have discussed, which is every node will have maximum 2 childs, right? But in binary search tree, we have the same thing, but additional condition is, in this tree, the left subtree will have the values less than the root node. And on the right subtree, you'll be having the values greater than the root node. Something like this. So let's say if I want to draw a tree here, so let's say we have 5, and then on the left hand side we can have a smaller value, right hand side we can have a bigger value. Let's say we have 5 again, let's say we have a new value which is 3, and then we can have 6, and then 8. Now this is a binary tree, but it's also a binary search tree. Okay, so this is how it looks like. So the left subtree here, as you can see here, these values are smaller than the root node, and right subtree, the values are bigger than the root node. But if you consider a subtree itself, then again, if you can see, the left subtree of this, which is 6, is smaller than the 7, and 8 is greater than the 7. So let's try to understand this more by drawing something or by taking some values. Okay, so let's say we have values something like this. We have 8, 7, 12, 15, 2, and 5. So let's say we have these values. And I want to store this in a tree structure. So how will you do it? Initially, we'll start with the root node. Now we are going for 8. So let's start with 8 here. So 8 becomes a root node. The next is 7. Now 7 is less than 8 or greater than 8. It is less than, right? So 7 goes on this side. So 7 goes here. Okay. What about 12? Now 12 is greater than 8. So 12 will go here. Next element 15. 15 is greater than 8. Let's go on right hand side. 15 is also greater than 12. So again, it will go on the right hand side of 12, which is 15 will come here. Next we have 2. So 2 is less than 8. Let's go to 7. 2 is also less than 7. So we can put 2 here. Next we have is 5. So 5 is less than 8. Let's go on 7. 5 is also less than 7. Let's go to 2. And 5 is greater than 2. So 5 goes on the right hand side, okay? So when you have the element greater than the particular element, so if we talk about 2, it goes on the right hand side. So this is how you draw a binary search tree. But the question is how you're going to write a code for this. So let's implement the binary search tree in Java. Now the thing is, we have talked about different data structure. One of it is linked list. So in linked list, we have something called nodes, right? So we connect different nodes and each node will be having data and a reference for the next element. Now in the same way, in tree, what we have is we have a node, of course, and then each node will have two child nodes. Now, when you talk about tree, sometimes it is difficult to imagine how will you code in Java. Do we have something like one root and multiple elements to it? Now, first of all, we don't have any Java syntax which will create a tree. There might be some external classes, but then internally, we know that you can create a variable or object, but then how will you create a tree structure? Now, to break it down, if you try to understand this, every node, so if you talk about this particular node here, yes, that's a root node. So do we have anything special about root node? Not exactly. So root node is also a node. The difference is the root node is not having any parent, right? So that's one thing we have to remember. Next, when you want to imagine tree, don't imagine the entire tree in one go. Imagine root node, and root node has two child nodes. That's it. Your job is done here. So as for the root node job is done by saying, hey, I got two child nodes. I don't know what is there after it. Then if we talk about the left node or left child node of a root node, it has one more node and that's it. We don't have to worry about 5 or 7. 7 only concerned about 2. Then on this side, 12 is only concerned about 15. And then 2 is concerned about 5. That's it. So we have to focus on one node at a time, and each node, maximum, they can have 2 child nodes. Our job is done. So what happens to those nodes which don't have any child? In that case, both of these are null. In this case too, we have only one child node on the right hand side. What about the left one? This is empty. This is null, right? And that's how, if you can implement this thing, if you can only imagine about one node at a time, your job is done. So that means if I want to code that, first of all, we need a class called node, right? In fact, I will not be writing this here. Let me just remove it. What I want is, from my main method, basically I want to create a binary tree. There are some inbuilt classes, but we're not going to use it. So let's say binary tree, and we'll call this as a tree equal to new binary tree. So we want to build a binary tree. Okay, you can see we have some inbuilt methods. We don't want to use them. So let's use a binary tree. We don't have this class yet. So what I will do is, I will just go back here, and you can see it is importing this package. We don't want any inbuilt things. So if I go back here, and if I say, hey, give me suggestions. More actions, I want to create this class, binary tree in the same package, and you can see we got it. I will just move this on this side. I don't want to see the project structure. So you can see on the left hand side, we have a main. On the right hand side, we have a binary tree. So basically in this binary tree, I want to do all those stuff. Now when I say I want to do stuff, basically we have to say tree dot. I want to insert value in this tree. So I can say insert, and I can pass a value, let's say 10. I don't know what values I'm passing here. Or maybe I can for the same value which we have in our node. So we have 8, 7, 12, 15, 2, and 5. Let's add that. Okay, but then unfortunately, we don't have this insert. Okay, so what we need to do is we need to create this method called insert inside this binary tree. And you can see we got insert method. Okay, but when you say insert, that means we have to make sure that you're inserting a node. Of course, you're passing data here, but it should be added to a node, right? And we don't have a node implementation yet. So I can create a node implementation by saying class node. Now what every node will have. Now if you go back to linked list, a node will have two things, the data and the next value. Now in terms of this node here, which is a tree node, it will have three things, data, the left node and the right node. So I can say int data, then we have to say a node, because when you say right node, left node, they are itself nodes, right? Let's first write left and then right. So yeah, so we got data, we got left node, and we got right node. I think the only problem is in some of the class, I think in linked list, we already have a node here. That's the problem. So what I will do is, let me just move binary tree and this main to some other package. I will just move the binary tree to other package. Let's say package com.telusko.tree. So sometimes you have to solve the problems in a go. You need to import the package from here now. Importing done. Okay, so problem resolved. The problem was I was having two classes with the same name in the same package. I just moved it to different package. Okay, so now you don't have to do that if you're just writing the binary code. You can just skip this line. Anyway, so we got a node, and then we are referring to left node and right node. So that's node done. But also what I want to do is, maybe when I create a node, I want to have a constructor here, which will take the data from me, and I will assign that data. So I can say this dot data to data, and that's it. So we are basically done with the node concept. But how will you implement this tree? So every time you want to insert the data in a tree, how will you do it? So if you say this is a tree, of course let's say we don't have a tree here, and let's go with the same value. I don't know what values we have. I can just use this copy. Okay, so we got this value. So if I want to draw a tree, so let's say someone is giving you the value 8 initially. So what you do is you create a root node. Now we know that we don't have a node in the tree. So basically the tree is empty. In that case, you will make this as a root node. Okay, so how do we do that? So when you say insert, basically we have to create a root node. That means every tree need to know about only one thing, which is a root node, right? As I mentioned before, for a tree, the most important thing is root, and then tree don't have to worry about other nodes. The root node will take care of the next 2 nodes. So what I can do is I can say node root, and then every time I create insert, and then imagine that this is the first time. So what you will do is you will create your root node here. So you can simply say root is equal to new node. That's how you create a node. Just create the object and pass the data. And that's it. You got your root node. In fact, instead of using this variable as I, it should be data. It will make much more sense. So now if you can see our code, this is the thing we have done. So we created a root node called 8, and that's your root node, which looks good. But then what about if I insert one more data here? So if I say tree insert, I want to insert the next record. What's the next record? It is 7. So when I insert 7, where the 7 should go? Now, don't you think the 7 should go on this side is because we are implementing binary search tree. 7 is less than 8, so it should be on the left-hand side. So when I say 7, it should create a new node, and we are doing it. You can see every time you say insert, it creates a new node. But don't you think this time is not a root node? It's a left node of the root node. How will you do that? And how do we even know that this is not a root node? So in that case, we need to do is, we need to check if the root is null. Then you create a new node. Then you create a root node. Otherwise, you don't create root node every time. So root node will be created only once if the root is null. What else if it is not null? Then we can check for something else. Now see, if we talk about 8, yes, this satisfies us because root is null till this point before executing 8. But when you insert 7, we already have a root node, right? Then we have to go for if else. Now the question is, now we know that this is not a root node. We have to either go for left or right. So what you do is, you basically check for data. If the data is less than root.data, then you go on the left-hand side. So when you say you go for left-hand side, what you simply do is, you say root.left.data is equal to data. That's what you do. But then we have one little problem here. Because see, this will work for this data. Okay, so we will get new thing. But we're not even creating a new node. Okay, so the problem is we need to modify this to something else. Why something else? Let's say we have adding one more, which is 12 goes here. And then you add 15. Now, by our logic, if the value is greater than root node, just add it to the right hand side. But 12 is already there, right? Then we have to move to 12 and it becomes a right hand side of 12. That means we have to jump from root to the next element and then the next element. Oh, that's a recursive process now. So that means we have to add a recursion here. That's one thing. Second problem is, every time you insert data, we need to get a hold on root. Writing the logic here is not efficient way. What we should be doing is create another method which is called, let's say, insert rec, and we'll say this will take 2 things, because when you want to do recursion, we have to get a hold on root element or root node. So that means we cannot do that in this insert, because the moment you say recursion, every time you call the method, we need to get the hold on the node where you're calling this. So this will not work, but that doesn't mean we have to remove this. I will tell you in some time why. So basically we have to say node root comma data. And here, okay, this should return a node because we are going for recursion, so it should return something. And now here, instead of doing all this logic should be a part of this, not this. So here, we can simply say root is equal to insert record. So every time you call insert, it will call insert rec, in which you are passing the root node and the data. So when you say recursion, it will go into recursion. We will be using recursion on insert rec, not on insert. So we have to change some logic here. So this is correct when you say root. I'm only concerned about this part. So how do we implement this one? So when I say I want to add element on the left hand side, so if you have, let's say 2, now we know that 2 should go here, but then we have to jump from 8 to 7, 7 to 2. That's a recursive process, right? So what you will do is, let me uncomment this now. This is not how you do it. So basically you say root.left, and then you call the function once again by passing the root.left, because now we need to follow the tree, right? As I mentioned before, when you talk about the subtrees, if it is not 8 left, then we have to consider this subtree. Now this 7 becomes your root. So how will you send this as a root? So you have to say root.left. Now this becomes a new root. So when you call this function, which is insert rec here, this becomes your new root. And then you have to pass data as well. So you're passing data. But what if this is not smaller? Then you have to go on the right hand side. So I have to say root.data. If data is greater than root.data, then you do the same thing but for the right hand side. So I will say paste here. So this should be right and this should be right. And then at the end, you know your root node. So just return root. That's it. So this is the recursion call which we are getting here. So that's how basically you create a tree. Now this tree is created. But how will we know that this tree is created? We want to print also, right? And the way you can print it is like this. So if you want to print this tree, so let's say we have this tree here, and this tree is created by the way we have defined this example here. How will you print this? Now to print, we basically have to traverse, or we have to travel to different elements here. The way you do that is we have different traversal for tree. So when you talk about tree traversal, we have to follow certain things. First, there are three options here. We have in order traversal, we have pre-order traversal, and we have post order. The difference between these three is the way you print your root node. Okay, so when you talk about in order, basically what you do is you first go to the left, then you go to the root, then you go to the right, so which is 7, 8, 12. When you talk about pre-order, here you first go to root, which is 8, so it will print 8, then 7, which is left, and then 12, which is right. When you talk about post, it means first it will go for left, then right, then root, which is 7, 12, and 8. Okay, that's your post order traversal. Here we are going to go for in order. So in order simply means first you print the left one, then you print the, also not exactly printing, but you go to the left one, then you go to the root node, and then you go for the right one. So that's your in order. Now the way you can do that, of course, this is also recursive, right? So in order to do that, what I will do is I will create a function called public void in order. Then you can work here. But then since we know that in order is actually, or traversal is basically a recursive operation where you go to each subtree and print it or do some operations. For the recursion, I will create another method which is public void, is because I don't want to return anything. So I will say in order rec. So here we just want to print it. Now, when you say print it, how exactly we are going to print, how we are going to travel this? Of course, the output will not be similar to the value we have inserted. It will have a different order. So what it will do is first it will print the left one, right? So when you start from here, it goes to 8, but then we cannot work on the 8 because that's an in order. Then you go to the left one because in order you first go for left hand side, left subtree. And then from 7 also, you can't print 7 because 7 becomes a root node for the 2. So we have to go to 2. Now we don't have any left here, right? This is empty. So in this case, you will first print 2. Okay, so you will go for 2. But then you go for right. Since we don't have a left, we print the root node because we are considering this subtree now. So you will print 2 and then you will print 5. So here we have 5. Then you go up. Then you print 7 because we don't have anything. So that's a parent for 2. So we'll go for 7. Then we print on the right hand side. We don't have anything right hand side, right? So this is empty. Then you go up, you print 8. Then you go for the right hand side. Right hand side is 12. On 12 left, we don't have anything. So it will not print anything, but you can print 12. And then you can go for right hand side, which is 15. And if you observe, you got a sorted values. So that's why we use BST, which is sorted values. It is easier to search as well. Okay, this is the in order traversal. Okay, so let's implement this. So how do we do it? So first we'll start from the left hand side. But also we want to verify if the tree is empty. If the tree is empty, how will you print something? How will you travel? And how do you know if the tree is empty? By using the root element. So we can simply check if root. But how do you know the root? Because root will keep changing depending on the tree, right? So we have to also accept root here. So we'll say node is root. And then you check if the root is not equal to null, then only you do it. Now, how will you do it? Now, first of all, this is a recursive function, right? So basically you have to call itself. So we'll say in order rec, And then you have to start from the left hand side. So always start from left and then keep going till you find the last left element, okay? And then once you do that, then you have to go for the middle one. Middle one is root itself, which we got here, right? So we can print this value here. So I will say print. And if you observe, for every node, for every subtree, there is always a root node. If you observe, for 8, 7 is left, right? But don't you think 7 in this subtree is a root node? So that's a root we are printing. When you go to 2, 2 becomes a root node, right? When you go 5, 5 becomes a root node for their child, which we don't have. Then we can print data here. So we can say root.data, and then we can print a space in between as well, just to differentiate the values. And also I can skip the new line. Now, once you are done with the root element, of course, not just printing, you can do some other operations as well. Maybe you can add all the values if you want. And then here, I can say in order, but this time you will go for root.write. That's it. This is how basically you print the values. But from in order, we have to call in order rec by passing the root node. So you will call this only once, in order. So that means I can simply create a tree by adding values here first of all. Now what values we have, let me just do that quickly. Okay, so you can see we have added all the values and now it's time for traversal. So I will just print in order and it should do the job for us. Let's try. So I will just run this and you can see we got the values. We got 2, 5, 7, 8, 12 and 15. That's what expected. It is printing in order. But let's say if you want to do post order, so what I can do is I can just change their names, or maybe I can say pre-order. So I can say pre-order, and of course everywhere you have to do that. Now the only change you have to make is in pre-order, first you print the root. So that means this line will go up. That's the only change you have to make in pre-order. Okay, nothing much. Let's run this and see if this works. Save this code and run. And you can see this is now pre-order. So root element is something which will get print first. I think this is a sequence in which we have added. No, a different sequence. But anyway, you got the point. So this is pre-order. You can also do it post-order. Let me know in the comment section if you have done that. And yeah, that's how you implement tree.